Hello everyone, Kaushal this side and welcome to Advanced AWS Training session by Simplilearn. In this video, we'll start this session with an introduction to Amazon Web Services and move forward by covering topics like why AWS, what AWS is, and AWS Architecture. After covering all these topics, we'll see how to set up an AWS account. After that, we'll cover AWS services like AWS EC2, AWS CloudFormation, AWS IAM, AWS S3, AWS Virtual Private Cloud, AWS Lambda, and AWS ECS. After covering all these services, we'll move forward and see the difference between Amazon Web Services and Microsoft Azure. Not just that, but we'll also take you through the difference between AWS and Google Cloud Platform. And at the very end, we'll cover all three cloud providers. These are the three giants of cloud computing today: Amazon, Microsoft, and Google. After that, we'll see some of the best certifications and why should you choose the Simplilearn AWS course. At the end, we'll wrap up this advanced course with AWS Interview Questions. And let me tell you guys that we have regular updates on multiple technologies. So if you're a tech geek in a continuous hunt for the latest technological trends, then consider getting subscribed to our YouTube channel and press that bell icon to never miss any updates from Simplilearn. Also, if you want to master the field of cloud computing, the postgraduate program in cloud computing, designed in collaboration with Caltech CTME, helps you become an Azure, AWS, and GCP expert. This in-depth cloud computing certification course lets you master key architectural principles and develop the skills needed to become a cloud expert. Benefits of this postgraduate program includes Caltech CTME Postgraduate Certificate, enrollment in Simplilearn's JobAssist. You will receive up to 30 CEUs from Caltech CTME. You'll attend masterclasses from Caltech CTME instructors, live virtual classes led by industry experts, hands-on projects and integrated labs, online convocation by Caltech CTME Program Director, 40 plus hands-on projects and integrated labs, capstone project in 4 different domains, and Caltech CTME Circle membership. You can also fast-track your career with this cloud computing certification and its in-depth course curriculum, which covers the key concepts of Microsoft Azure, Amazon Web Services, and Google Cloud Platforms, and services such as AWS Lambda, Amazon S3, Azure App Services, and many more. So this program also covers the essential skills to become an expert in cloud computing. And you can consider this program because it provides you with a certification from Caltech CTME, a well-reputed university in the United States. So what are you waiting for? Check out the link mentioned in the description box below and start your cloud computing career today. So without any further delay, let's get started.
Meet Rob. He runs an online shopping portal. The portal started with a modest number of users, but has recently been seeing a surge in the number of visitors. On Black Friday and other holidays, the portal saw so many visitors that the servers were unable to handle the traffic and crashed. Is there a way to improve performance without having to invest in a new server? Wondered Rob. A way to upscale or downscale capacity depending on the number of users visiting the website at any given point? Well, there is. Amazon Web Services, one of the leaders in the cloud computing market. Before we see how AWS can solve Rob's problem, let's have a look at how AWS reached the position it is at now. AWS was first introduced in 2002 as a means to provide tools and services to developers to incorporate features of Amazon.com to their website. In 2006, its first cloud services offering was introduced. In 2016, AWS surpassed its $10 billion revenue target. And now, AWS offers more than 100 cloud services that span a wide range of domains. Thanks to this, the AWS Cloud Service Platform is now used by more than 45% of the global market. Now, let's talk about what is AWS. AWS, or Amazon Web Service, is a secure cloud computing platform that provides computing power, database, networking, content storage, and much more. The platform also works with a pay-as-you-go pricing model, which means you only pay for how much of the services offered by AWS you use. Some of the other advantages of AWS are security. AWS provides a secure and durable platform that offers end-to-end privacy and security. Experience. You can benefit from the infrastructure management practices born from Amazon's years of experience. Flexible. It allows users to select the OS, language, database, and other services. Easy to use. Users can host applications quickly and securely. Scalable. Depending on user requirements, applications can be scaled up or down. AWS provides a wide range of services across various domains. What if Rob wanted to create an application for his online portal? AWS provides compute services that can support the app development process from start to finish. From developing, deploying, running, to scaling the application, up or down based on the requirements. The popular services include EC2, AWS Lambda, Amazon Lightsail, and Elastic Beanstalk. For storing website data, Rob could use AWS storage services that would enable him to store, access, govern, and analyze data to ensure that costs are reduced, agility is improved, and innovation accelerated. Popular services within this domain include Amazon S3, EBS, S3 Glacier, and Elastic File Storage. Rob can also store the user data in a database with AWS services, which he can then optimize and manage. Popular services in this domain include Amazon RDS, DynamoDB, and Redshift. If Rob's businesses took off and he wanted to separate his cloud infrastructure or scale up his work requests and much more, he would be able to do so with the networking services provided by AWS. Some of the popular networking services include Amazon VPC, Amazon Route 53, and Elastic Load Balancing. Other domains that AWS provides services in are analytics, blockchain, containers, machine learning, Internet of Things, and so on. And there you go. That's AWS for you in a nutshell.
Amazon uses decentralized or distributed IT infrastructure to make several IT resources available on demand. Since the 1990s, it has invested millions of dollars in building and managing large-scale distributed and efficient IT infrastructure. Amazon launched AWS, a cloud computing platform to allow other organizations to take advantage of this reliable IT infrastructure. There are many scenarios in which AWS is an efficient option for running web applications or organization portals. Let's explore a few AWS use cases. A small manufacturing organization can use its expertise in expanding its business through quality production while leaving IT management to AWS. A large enterprise spread across the globe can utilize AWS to deliver training to its distributed workforce. An architecture consulting company can use AWS to get high compute rendering of its construction prototypes. A media company can use AWS to provide different types of content, such as videos, ebooks, and audio files to its worldwide customers. Based on the concept of pay-as-you-go, AWS provides a suite of services that customers can use when required and without any long-term commitments or upfront expenditure. The platform enables customers to procure service such as computing, programming models, database storage, networking, and development platforms in minutes. This allows the customers to enjoy the benefit of low operational overheads. The distributed IT infrastructure provided through AWS has evolved with time through the lessons learned from over 16 years of experience. AWS diligently listens to its customer feedback. This enables the AWS team to efficiently deliver creative features and services. Even today, AWS continues to hone its operational expertise continually to retain lasting reliability by employing its own advances and industry best practices into its cloud infrastructure. As a result, the customers tend to benefit significantly from AWS. These benefits include the following: flexibility, cost-effectiveness, scalability and elasticity, security. Flexibility is the major benefit of using AWS when compared with the traditional IT infrastructure. This benefit is realized in different ways. First, you get more time for core business tasks through the instant availability of new features and services. The traditional IT infrastructure requires a lot of time in planning, designing, procuring, hiring, and managing resources. Second, you enjoy effortless hosting of legacy applications. AWS does not require rewriting legacy applications or learning new technologies. Migrating legacy applications to AWS gives the benefits of advanced computing as well as efficient storage. Last, you get a choice in running services and applications. AWS is flexible enough to run services and applications separately or together as a platform. You can even choose to run a part of your IT infrastructure in AWS and the remaining part in your data centers. Large organizations usually prefer this method of operation. AWS requires no upfront investment, long-term commitment, or minimum expense. This is its significant advantage when compared to the traditional IT infrastructure. Owning and operating one's own infrastructure requires huge investments in IT hardware, power, bandwidth, and human resources. Through AWS, techniques such as auto-scaling and elastic load balancing can automatically scale resources. They scale up the required resources to fulfill a sudden demand and then scale them down when the demand falls without affecting speed and performance. The AWS techniques are ideal for dealing with unpredictable and variable loads. As a result, the organization enjoys the benefits of reduced cost and increased user satisfaction. AWS delivers end-to-end security and privacy to its customers. Its virtual infrastructure offers optimum availability while managing full privacy for customers and isolation of their operations. Customers can expect high physical security, and this is due to Amazon's several years of experience in designing, developing, and running large-scale IT operation centers. AWS ensures confidentiality, integrity, and availability of the user's data. The purpose of AWS compliance is to enable you to understand its powerful controls in action and maintain security and data protection. AWS provides security to their global infrastructure, along with a variety of features for securing critical data in the cloud. Let's explore some of the security highlights. AWS sternly controls, supervises, and audits physical access to their data centers and network. As a customer, you can manage credentials, allowing access to your AWS account. Access Control List, or ACL, type permissions on critical data, as well as encrypted while in storage. Configure a virtual private cloud, or VPC, a virtual network logically isolated in AWS from other virtual networks. Configure and control the operating system on your own Amazon Web Services virtual server. Configure a security group as a virtual firewall to keep an eye on the incoming and outgoing traffic for your virtual servers in AWS. State a key pair at the time of introducing your virtual server in AWS. This key pair is then used to encrypt login information. The AWS IT infrastructure is designed and managed according to the best security practices, certifications, and IT security standards. These certifications include Service Organization Control, or SOC 1, SOC 2, and SOC 3, Federal Information Security Management Act, or FISMA, Department of Defense, or DoD Information Assurance Certification and Accreditation Process, or DIACAP, Federal Risk and Authorization Management Program, or FedRAMP, DoD Cloud Computing Security Requirements Guide, or SRG, Criminal Justice Information Services, or CJIS, National Institute of Standards and Technology, or NIST, Payment Card Industry, or PCI Data Security Standard DSS Level 1. International Organization for Standardization, or ISO 9001 and ISO 27001, U.S. International Traffic in Arms Regulations, or ITAR, Section 508, Voluntary Product Accessibility Template, or VPAT, Federal Information Processing Standard, or FIPS Publication 140-2. The industry-specific standards for customers to deploy their solutions include Health Insurance Portability and Accountability Act, or HIPAA, the Family Educational Rights and Privacy Act, or FERPA, Cloud Security Alliance, or CSA, Motion Picture Association of America, or MPAA.
Today we're going to talk about AWS in 10 minutes. Let's look at the agenda here. Let's talk about what AWS is, why it's such a big hit. We'll have a look at the overview of the services. We'll see how much it costs, how big it is, and what the future of AWS is. So, what is AWS? Everyone is talking about Amazon Web Services, but let's have a look at what it is. It's basically a global cloud platform, which allows you to host and manage services on the internet. It's used by almost 80% of Fortune 500 companies to host their infrastructure, and it has a lot of services which it provides to its customers. There's infrastructure service, which means they provide bare servers as a service, so you don't need to manage the backup and the power supply of the service. They provide platform of the service. You can get Java, Ruby, PHP as a service, so that you don't have to manage the binaries of these applications. You get software as a service, wherein you get email sending capabilities like SES. You get queuing services like SQS, and it's a cloud storage platform wherein you have a lot of storage options including EBS and S3. So all in all, AWS is a hosting provider, which gives you a lot of services, wherein you can run your applications on the cloud. Now, let's take a look at why it's such a big hit. So everyone is trying to use AWS. Everyone is trying to put their applications on the cloud. So what's the reason that AWS is the top provider and the top choice for doing anything on the cloud? One of the biggest reasons is the billing. So the billing is very clear. You get a per hour billing. Every instance or every service has a micro billing. So, be it instances on EC2, you get per hour billing rate, which is very transparent. Even S3 buckets are charged on a per GB basis, although it is a storage service, but still, there is micro billing available there. The sign-up process is easy. You don't need to sign any agreement, nothing. You just go, sign up with an email ID, add a credit card, and you're good to go. You can go from 0 to 100 in just 2 minutes. You can launch your servers, big machines, without buying hardware. Without procuring any hardware, you can just be up and running in minutes. So, their billing dashboard is also very simple. They give you an integrated billing dashboard, which gives you reports. You can pull out reports every month. You can pull out reports based on services, based on various parameters. For the cloud provider to be a hit, you need it to be stable. It has to be a trusted thing. So their services are quite stable. In the last 7 or 8 years, they have seen some 3 or 4 major outages, but those have been only region specific. So that means out of the 12 or 13 regions in which they operate, the outages have been region specific in a particular country or continent. And those also have not been more than 2 or 3 hours and have not affected all of their customers. It's a trusted vendor. So when we talk about AWS, it comes up as something which is used by everyone in the industry. From small startups to big enterprises, everyone sees Amazon as a trusted advisor. Now, let's have an overview of the most commonly used services. So the first and the most commonly used service is EC2, which is Elastic Compute Cloud. This is the service which gives you bare servers. So this service will give you a machine which you can launch and you can run your software on those. You can get small or big machines based on your requirements. The second choice is VPC. So Amazon will not allow you full control of their cloud. Instead, they give you chunks of their cloud, which is VPC, or the virtual private cloud. So VPC lets you create networks in the cloud and then run your servers in those networks. The next one is S3, which is Simple Storage Service. So S3 gives you the opportunity to upload and share files. So it is mostly a file storage and sharing service. Then you've got RDS, which is Relational Database Service. So this RDS allows you to run and manage databases on the cloud. So they've got almost all the major flavors of databases, right from SQL Server to Oracle and MySQL, PostgreSQL. They have recently launched another one, which is called Aurora, which claims to be a very high-performance database. Then Route 53 is there for DNS. So they've got a managed DNS service wherein you can point your DNS to Amazon and they take care of the stuff. So it's a global DNS service, it's a scalable DNS service, so it scales according to demand. There's also Elastic Load Balancer. The ELB is a service which gives you the opportunity to load balance incoming traffic to multiple machines. So this way, you can scale up your web applications to any number of users. You've got auto-scaling, which adds capacity on the fly to Elastic Load Balancers, so that your website or your application is never down due to a load. How much does it cost? This per hour billing is already mentioned for everything. If it's something like a storage thing, again, there's a per hour or per GB month storage. So I think there is region-specific pricing. So Virginia is the cheapest region out of all of them. So the region-specific pricing is because they have got some regions which they have got good hold of, and they are the headquarters. So Oregon and Virginia are the cheapest actually. They also give you services based on the term. So if you sign up for something for a year, it would be cheaper for you rather than signing up for something on an on-demand basis. So they've got reserved instances which are very cheap as compared to the on-demand ones. You can get discounts from 20% to almost 60% if you sign up for a 3-year term. They are spot resources. Examples of these are spot instances. So this is like a bidding market base, where you can bid for a price. The only downside of this kind of pricing is that your machine might be terminated or your resources might be terminated if someone bids higher. People use these kind of things for doing some ad hoc in-search or some ad hoc tasks, which are really not critical. How big is it? They have got 15 regions across major countries of the world. They've got regions in the US, Europe, Asia Pacific. They've got a global footprint. So in today's world, if you are anywhere in the world, you would have a region within 1,000 miles of your location. They've got massive data centers. So each of the region has got multiple availability zones. So one availability zone can be thought of as a big data center. The data centers have anywhere from 300,000 to 500,000 servers. What is the future of AWS? So they currently have 64 services, which span across infrastructural service, software as a service, platform as a service. They are launching new services in all demands every day. Right now, they are focusing on machine learning. So recently, they've launched a couple of services, which focus exclusively on machine learning. And they are focusing on software as a service product, wherein they want to take control of the service you want to utilize. They don't want you to do it. They want you to upload it to them. And every now and then, they keep on reducing the costs. So you would hear it in the blog that, okay, the price of EC2 machines has been reduced. And this is because of their scale. So they scale up and they give the cost benefit to the customer. That's all for today, guys, with just a quick intro of the Amazon Web Services Cloud.
Also, if you want to master the field of cloud computing, the postgraduate program in cloud computing, designed in collaboration with Caltech CTME, helps you become an Azure, AWS, and GCP expert. This in-depth cloud computing certification course lets you master key architectural principles and develop the skills needed to become a cloud expert. Benefits of this postgraduate program includes Caltech CTME Postgraduate Certificate, enrollment in Simplilearn's JobAssist. You will receive up to 30 CEUs from Caltech CTME. you'll attend masterclasses from Caltech CTME instructors, live virtual classes led by industry experts, hands-on projects and integrated labs, online convocation by Caltech CTME program director, 40 plus hands-on projects and integrated labs, capstone project in 4 different domains, and Caltech CTME Circle membership. You can also fast track your career with this cloud computing certification and its in-depth course curriculum, which covers the key concepts of Microsoft Azure, Amazon Web Services, and Google Cloud Platforms, and services such as AWS Lambda, Amazon S3, Azure App Services, and many more. So this program also covers the essential skills to become an expert in cloud computing, and you can consider this program because it provides you with a certification from Caltech CTME, a well-reputed university in the United States. So what are you waiting for? Check out the link mentioned in the description box below and start your cloud computing career today. So without any further delay, let's get started.
In the topic How to Design Cloud Services, we will take a look at the AWS well-architected framework. And we'll take a deeper look at the 4 pillars which make up the framework. And these are security, reliability, performance efficiency, and cost optimization. We'll then take a look at where you can find more information about designing cloud services for Amazon. And we will look at the AWS Quick Start reference deployments, and where you can find out real-life examples about how real businesses are using Amazon Web Services. So let's start by looking at the AWS well-architected framework. Now this was introduced because building cloud infrastructure services is vastly different to what you're used to with on-premise infrastructure. So AWS created this framework to help you understand the pros and cons of decisions you make while building systems on AWS. The AWS framework documents a set of foundation questions that allow you to understand if a specific architecture aligns well with cloud best practices. And there's 5 principles it helps you with. The first of which is stop guessing your capacity needs, test systems at production scale, lower the risk of architecture change, automate to make architecture experimentation easier, and allow for evolutionary architectures. And we'll take a look at each of these in greater detail. So firstly, let's take a look at stop guessing your capacity needs. Now imagine you're designing a brand new application for your business. All the infrastructure decisions you will make are made using estimates, which are basically guesses. If you overestimate, you might end up buying too much hardware and have a fleet of expensive idle resources. Conversely, you might underestimate and have to deal with the performance implications of limited capacity. With cloud computing, these problems go away, as AWS helps you eliminate the guesswork in your infrastructure capacity needs. You can use as much or as little capacity as you need and scale up and down automatically depending on your demand. The cloud allows you to test systems at production scale. Traditionally, in a non-cloud environment, it's usually very difficult to fully test new products or services in development, as it's cost prohibitive to have like-for-like environments, or you just don't have the resources available. Personally, I've lost count how many projects I've worked on when things have gone wrong as soon as the product's gone live, due to insufficient testing. With the cloud, you can duplicate environments on demand, and when you've completed your testing, just shut them down, and you only have to pay for the time the test environment was up and running. So you can test fully before you go live in production. AWS allows you to lower the risk of architecture change, as you can automate the creation of test environments. So you can emulate your production configurations and carry out testing against comparable environments. You can also remove testing bottlenecks where various teams are lining up to use your test environments. As with AWS, you can cheaply spin up as many test environments as you need and ensure that all the production changes have been sufficiently tested. You can automate to make architecture experimentation easier. If you need to make a change to production but not sure what the impact will be, well, you can automate the creation and replication of your systems at low cost and low effort to test these changes. You can then audit the impact, and then, if necessary, you can revert the changes and try again. With AWS, you can allow for evolutionary architectures. In a traditional environment, architecture decisions are often implemented as a static, one-time event that you have to live with during the lifetime of a system. But with the cloud, the capability exists to automate and test on demand to lower the risk of design changes, so you can implement new innovations and features easily. What this means is you aren't stuck with last year's technology, and you can implement new technology as soon as it comes out. As mentioned earlier, the well-architected framework is based on 4 pillars: security, reliability, performance efficiency, and cost optimization. So in the coming slides, we're going to take a further look at these 4 pillars, starting with security. So Amazon defines security as the ability to protect information, systems, and assets while delivering businesses value through risk assessments and mitigation strategies. What this means is you can apply security at all layers. So rather than just running minimal security, like firewalls, at the edge of your infrastructure, you can use firewalls and other security controls on all of your resources. For example, security groups on EC2 instances allow you to define who and what can access that specific resource, rather than just defining it at a global infrastructure level. You can enable traceability, so you can log and audit all changes to your environment. You can automate responses to security events, so you can monitor and automatically trigger alerts depending on your needs. You can focus on sharing your system. The AWS shared responsibility model allows you to focus on securing your application, data, and operating systems, whilst AWS secures your infrastructure and services. And you can automate security best practices. AWS allows you to create and save a custom baseline image of a virtual server, and then you can use that image to automatically launch new servers. This way you can ensure that all new resources adhere to your security standards. So I just briefly mentioned the AWS shared responsibility model. Now we take a look at this in more depth in a later lesson. But what it means is that the AWS shared responsibility model allows AWS customers to focus on using services to accomplish their security and compliance goals, because AWS physically secures the infrastructure that supports your cloud services. So if you look at this diagram, you can see it split into 2. Security measures that the cloud service provider implements and operates is the security of the cloud, and that's the responsibility of AWS. Then there's the security measures that the customer implements and operates, and this is related to the security of customer content and applications that make use of the AWS services. And this is security in the cloud, and this is the responsibility of you. So let's take a look at security in the cloud. And this is composed of 4 areas: data protection, privilege management, infrastructure protection, and detective controls. Let's start with data protection. Before architecting any system, practices that ensure security should be in place. With data protection, these are categorizing data based on levels of sensitivity, granting least privilege while still allowing users to perform their work, and encryption to protect your sensitive data. If you're storing customer credit card data, obviously this needs to be categorized as sensitive and it needs to be encrypted. But log files from a daily maintenance task wouldn't need this level of security. Now there's a number of tools AWS offers to assist you with this. AWS makes it easy to encrypt data and manage keys and key rotation using IAM and Key Management Service. You can perform detailed logging using CloudTrail, and AWS offers resilient storage systems like Amazon S3, which has 11 nines of durability. Now 11 nines of durability means that if you store 10,000 objects with Amazon S3, on average you can expect to incur a loss of a single object once every 10 million years. So in other words, you're not going to lose many files. And finally, AWS offers versioning and lifecycle management, again with S3, so you can protect against accidental deletes or file overwrites. Now, a central part of any information security program is privilege management, so that you can ensure that only authorized and authenticated users are able to access your resources. and that they can only access them in a way that is acceptable. For example, if a user needs access to a resource, don't just give them admin or read-write permissions by default, because they might actually only need read-only access. Now, to control your privilege management, you need to have a few things in place. The first of which is an access control list. And this is a document that needs to be maintained which lists access permissions attached to an object. So if you have some particular documents, you need to define what access is allowed to it. Then you have role-based access controls, and this defines the permissions for a particular end user's role or function. So an administrator would obviously need administrator access to various resources, but a regular end user might only need read-only access. So you need to define which roles have which permissions. Then there's password management, and this includes complexity requirements and change intervals. So you define how often people need to change their passwords and how complex they need to be. Now, Amazon helps you with all this with the Identity and Access Management, or IAM, service. And this is the primary service used to control access to AWS services and resources. We cover IAM in huge detail in a later lesson, but briefly, it allows you to apply granular policies which assign permissions to users, groups, roles, or resources. And you can also control the password strength using this, as well as federation with your existing directory services, such as Microsoft Active Directory. You also need to protect your infrastructure, and to do this it's recommended to have multiple layers of defense and also multi-factor authentication to meet best practices with industry or regulatory obligations. Now, Amazon allows you to do this by implementing stateful or stateless packet inspection, either using AWS native technologies or by using partner products and services available through the AWS Marketplace. Amazon Virtual Cloud, VPC, enforces boundary protection and monitoring points of ingress and egress, and then there's CloudTrail and CloudWatch, which provides comprehensive logging, monitoring, and alerting. You should always have detective controls in place so you can detect or identify security breaches. This needs to happen so you can provide both a quality support process and meet compliance obligation. And by a quality support process, I mean one in which when you have a problem, you're committed to finding out the root cause and actually resolving the issue rather than just saying, oh, we think it was that, let's hope it doesn't happen again. I mean, I know I've worked for some places like that, and it's certainly not a quality support process. AWS helps you with your detective controls by providing these services. AWS CloudTrail is a service that logs API calls, so you can find out the identity of callers, the time of calls, source IP addresses, and things like that, so you can find out who is doing what and when. Amazon CloudWatch is a monitoring service for AWS resources, so you can log EC2 CPU usage or network activity, and you can use CloudWatch with many different services like RDS, EBS, and more. You can also set up alarms, so you can be notified when certain things happen. AWS Config is an inventory and configuration history service that provides information about the configurations and changes in infrastructure over time. With Amazon S3, you can see data access auditing, so you can find out who's been accessing your S3 data and when they did it and when. And Amazon Glacier, you can use the Vault Lock feature to preserve mission-critical data with compliance controls that are designed to be auditable for long-term retention. The next pillar is reliability, and Amazon defines this as the ability of a system to recover from infrastructure or service failures, dynamically acquire computing resources to meet demand, and mitigate disruptions such as misconfigurations or transient network issues. With reliability in the cloud, there's a number of things to look at. Firstly, you can test recovery procedures. Cloud infrastructure means you can test how your system fails, and you can validate your recovery strategy. Places I've worked at in the past, disaster recovery was a big event. It was only done annually, it took months of preparation, it involved working a whole weekend and then some, and was also incredibly disruptive to the business. Imagine being able to duplicate your production environment and test failure and failover whenever you want. You can automatically recover from failure with the cloud. Monitoring a system for a key performance indicator, or KPI, you can automatically trigger automated recovery processes when a threshold is breached. You can scale horizontally to increase aggregate system availability. Using multiple small resources instead of one large resource will reduce your single points of failure. And also you can stop guessing capacity. Gone are the days of using lack of memory or not enough CPU as a failure for a resource. With the cloud, you can scale as and when you need to, so you can't blame badly estimated capacity as the reason for reliability issues. Now, reliability in the cloud is composed of three areas. These are foundations, change management, and failure management. To achieve reliability, a system must have a well-planned foundation and monitoring in place. Plus, systems for handling changes in demand or requirements is also required. In an ideal world, your system would be designed to detect failure and automatically heal itself. Before architecting any system, you should have foundations in place so that your reliability is not impacted. You should have sufficient network bandwidth to your data center. You should have sufficient compute capacity. Your staff should be trained in the areas they need to be, and you should have support contracts with your vendors. With AWS, network bandwidth and compute capacity is already taken care of. AWS also offers a range of support contracts to help you with issues and a range of training courses for your staff. Change management is a critical part. Being aware of how a change affects the system allows you to plan proactively, and monitoring allows you to quickly identify trends that could lead to capacity issues or SLA breaches. With AWS, you can monitor the behavior of a system and automate the response to KPIs. For example, you can add additional servers as a system gains more users. So you can control who has permissions to make system changes and audit the history of these changes. Unfortunately, it's a given that failures will occur, so you need to have some failure management in place. It's good practice to understand why things failed so you can prevent it from happening again. No one wants to work for a company that, when things go wrong, they just get it working again with no understanding of why. A key to managing failure is frequent and automated testing of systems to failure and through recovery. Ideally, you do this on a regular schedule and also after you've made significant system changes. Now, Amazon allows you to do this with a few products. Firstly, AWS CloudFormation. This allows you to launch temporary copies of whole systems at very low cost, so you can use automated testing to verify your recovery processes. You can use CloudWatch to set up automation to react to monitoring data that indicates a failure. And you can store all your data on Amazon S3 buckets for future use. The next pillar is performance efficiency, and Amazon defines this as the ability to use computing resources efficiently to meet system requirements and to maintain that efficiency as demand changes and technologies evolve. So what does this mean? Well, performance efficiency in the cloud means you can democratize advanced technologies. AWS provides products such as NoSQL or media transcoding or even machine learning as a service. So rather than your IT team having to learn how to host and run these new technologies, AWS does it for you. You can go global in minutes. AWS allows you to easily deploy your systems in multiple regions around the world with just a few clicks of your mouse. So this leads to lower latency for your customers. You can use serverless architectures in the cloud, which remove the need for you to run and maintain servers to carry out traditional compute activities. For example, storage services can act as static websites, which remove the need for web servers. And you can also use serverless technologies such as Lambda or Elastic Beanstalk. And you can also experiment more often. With virtual and automatable resources, you can quickly carry out comparative testing using different types of instances, storage, or configuration. So performance efficiency in the cloud is composed of four areas: compute, storage, database, and something called space-time trade-off. And let's take a look at each of these. With the cloud, finding the optimal server configuration for a product will vary based on application design, usage patterns, and configuration settings. Traditional IT infrastructure requires making estimates in advance, which can lead to incorrect server configurations and lower performance efficiency. AWS is virtualized, so you can quickly change the EC2 server configuration to increase its performance efficiency. It may be optimal to run serverless computing. For example, AWS Lambda allows you to execute code without running an instance, and Elastic Beanstalk allows you to run web applications in a similar manner. From an operational standpoint, you should have monitoring in place to notify you of any degradation in performance. The optimal storage solution for a particular system will vary based on whether you need block, file, or object storage, the type of throughput required, frequency of access, and availability and durability constraints. Well-architected systems use multiple storage solutions and enable different features to improve performance. In AWS, storage is virtualized and is available in a number of different types. This makes it easier to match your storage methods more closely with your needs, and also offers storage options that are not easily achievable with on-premise infrastructure. For example, Amazon S3 is designed for 11/9 durability and provides a variety of storage classes for your different data categories, like Glacier for archived data. EBS and EFS offer numerous options for your EC2 instances based on the level of performance you require from your storage. The optimal database solution for a particular system can vary based on requirements for consistency, availability, partition tolerance, and latency. Many systems use different database solutions for various subsystems and enable different features to improve performance. Selecting the wrong database solution and features for a system can lead to much lower performance efficiency. Now, for database usage, you need to be able to monitor them, test them, and also you need to have some database platform knowledge. But Amazon makes this much easier for you, as it provides a suite of Amazon relational database services, which are fully managed relational databases. For example, Amazon DynamoDB is a fully managed NoSQL database that provides single-digit millisecond latency at any scale. Amazon Redshift is a managed petabyte-scale data warehouse that allows you to change the number or type of nodes as your performance or capacity needs change. You can also make use of Aurora or AMIs, where you install your own databases from templates. So what is the space-time trade-off? Well, you can think of space as memory or storage, and you can think of time as the processing time or the compute time to complete a task. So when you're architecting solutions, there's always a series of trade-offs, where it might be better to have more memory or storage to reduce the processing time, or maybe you're happy to sacrifice the processing time in order to reduce your memory or storage requirements. AWS gives you the option to maximize one or the other. For example, you could launch your systems globally, so you're increasing space and memory, so that they're closer to the end users in order to reduce latency, or the time. But whatever resource you use, you need to have monitoring in place to notify you of any degradation in performance. And the final pillar of the well-architected framework is cost optimization. This is defined as the ability to avoid or eliminate unneeded cost or suboptimal resources. AWS Cloud has a number of ways you can provide cost optimization. Firstly, you can transparently attribute expenditure, as the cloud makes it easy to identify the costs of a system and attribute IT costs of individual business owners, so those owners will have an incentive to optimize their resources and reduce costs. You can use managed services to remove the operational burden of maintaining servers for tasks such as sending email or managing databases. You can trade capital expense for operating expense. Instead of investing heavily in data centers and servers before you know how you're going to use them, with AWS, you pay only for the computing resources you consume when you consume them. Also, AWS allows you to achieve higher economies of scale because they can buy way more servers and hardware than you could ever imagine, so it's much cheaper to use their hardware than buy your own. You should also stop spending money on data center operations. AWS has the heavy lifting of racking, stacking, and powering servers, so you can focus on your customers and business projects rather than on your IT infrastructure. Cost optimization in the cloud is composed of 4 areas: match supply and demand, cost-effective resources, expenditure awareness, and optimizing over time. Matching supply to demand will deliver the lowest costs for a system, but you'll need to be able to provide sufficient extra capacity to cope with demand and failures. In AWS, you can automatically provision resources to match demand. Auto-scaling, time-based and event-driven and queue-based approaches allow you to add and remove resources as needed. Monitoring tools and regular benchmarking can help you achieve much greater utilization of your resources. Using the appropriate instances and resources for your system is key to cost savings. For example, a reporting process might take 5 hours to run on a smaller server, but a larger server that is twice as expensive might be able to do it in just 1 hour. Both jobs give you the same outcome, but the smaller server will incur more costs over time. But to be able to find out these things, you need to have monitoring of expenditure in place and also regular benchmarking. AWS helps you with this. AWS Trusted Advisor goes through your resources and tells you where you can make savings. You can use on-demand instances, so you only pay for compute capacity by the hour with no minimum commitments required. Or you could use reserved instances, which allow you to reserve capacity and offer savings of up to 75% off on-demand pricing. And with spot instances, you can bid on unused EC2 capacity at significant discounts. You can also take advantage of managed AWS services, such as RDS or DynamoDB, which can also lower your costs. AWS and its virtually unlimited on-demand capacity requires a new way of thinking about expenditures. So you need to have a different way of budgeting, and you need to understand your business unit's usage. To do this, you can use cost allocation tags to categorize and track your AWS costs for AWS resources, such as EC2 or Amazon S3. And AWS generates a cost allocation report with your usage and costs aggregated by your tags. So you can set up tags for each of your business categories and units. This increased visibility of costs makes it easier to identify resources or projects that are no longer generating value and should be decommissioned. Billing alerts can be set up to notify you of predicted overspend, and the AWS Simple Monthly Calculator allows you to calculate data transfer costs. And you can set up SNS alerts so you can be notified when certain resources or cost breaches occur. Optimizing over time is an important strategy to reduce your costs associated with your cloud environment. AWS is always releasing new products and services. As such, you need to reassess your existing setup to see if it's the most cost-effective. For example, rather than running a database on an EC2 instance, it might be cheaper to run an Amazon RDS database. Or Lambda might be more cost-effective than EC2. But where do you find out more information about these new products and services from Amazon? Well, the first place to look for any new architecture guide is the AWS Architecture Center. This is a resource that provides you with the guidance and application architecture best practices to build highly scalable and reliable applications in the cloud. Here you'll find the AWS Reference Architectures. The AWS Reference Architecture datasheets provide architectural guidance to help you build an application on the AWS cloud. You'll find datasheets that include a description of how each service is used, plus visual representations of the application architecture. For example, web application hosting, or large-scale processing and huge datasets, or even building elastic web front ends for an e-commerce website. AWS white papers provide a comprehensive list of technical AWS white papers that cover all Amazon-related topics, such as architecture, security, and economics. There are new white papers being released all the time and are written by some of the most knowledgeable AWS people around. AWS Quick Start reference deployments use AWS CloudFormation templates to rapidly deploy a fully functional environment for a variety of enterprise software applications. Supplementary deployment guides describe the architecture and implementation in detail. In this course, we'll deploy things manually, step by step, so you can see how it works. But with CloudFormation templates, you can do several hours work with just the click of a button. Examples of CloudFormation templates are SharePoint, RD Gateway, or even SQL Server on Windows Server failover clusters. And finally, case studies. AWS maintains a large list of case studies and success stories from their clients. You can check to see how some of the largest and most successful companies on the planet use AWS for their business. You'll learn how the AWS well-architected framework is used in planning and designing. We'll take a look at scaling and all the different versions. We'll look at the importance of loose coupling, how you can build redundancy into your cloud infrastructure, how you can save money by cost optimization. We'll look at automation and how it can make management of an IT environment easier. And also we'll take a look at security and how you can secure your cloud resources. So let's start with scalability. In the past, you would have to estimate the peak load of your systems and purchase your hardware accordingly. So perhaps you were setting up a new website and you were estimating that you were going to get 1 million people per month hitting your website. So you buy the hardware accordingly. But then you find out that only 50,000 people are hitting it, or 10 million people are hitting it. So your hardware is inappropriate for the work. Cloud computing provides virtually unlimited on-demand capacity, so you can scale whenever you need to. To do this, your designs need to be able to seamlessly take advantage of these resources. And there are two ways to scale, vertically and horizontally. Vertical scaling means increasing the specifications of an individual resource. For example, increasing the memory or the number of CPUs on a server. With AWS, this is easily achieved with a restart of your virtual server, so that it resizes to a larger or smaller instance type. The advantage of this approach is that it's very easy and requires little thought in the short term. However, this type of scaling can eventually hit a limit and sometimes be cost inefficient, especially if you scale up to some very, very large instances. Horizontal scaling means increasing the number of resources rather than the specifications of each individual resource. For example, adding additional web servers to help spread the load of traffic hitting your application. This is a great way to build applications that leverage the elasticity of cloud computing. However, not all architectures can distribute their workload to multiple resources. A stateless application is one that needs no knowledge of previous interaction and stores no session information. An example of this would be a web server that provides the same web page to any end user. A stateless application can scale horizontally as any request from any end user can be serviced by any of the available compute resources. You can add more resources as required and then remove them when the capacity is no longer available. Stateless applications do not need to be aware of their peers. All that is required is a way to distribute the end user sessions to them. And there are two ways to distribute load to multiple nodes. The first of these is the push model. A load balancer, such as the AWS Elastic Load Balancer, is a popular way to distribute a workload across multiple resources. An alternative, but less recommended approach, is to implement a DNS round robin using Amazon Route 53, where DNS responses return an IP address from a list of valid hosts in a round robin fashion. This is an easy to set up option, but it can cause issues if DNS records are cached. The alternative to the push model is the pull model. Tasks that need to be performed can be stored as messages in a queue, and multiple compute resources can pull and process the messages in a distributed fashion. Examples of this are big data processing scenarios, where many servers work to analyze data and return results, or media file conversion processes, where multiple servers convert the files as they arrive. Amazon SQS or Amazon Kinesis are services that can provide pull model load balancing. Most applications need to maintain some kind of state information. For example, an automated multi-step process will also need to track previous activity to decide what its next action should be. You can make components in your architecture stateless by not storing anything on the local file system, and instead storing user or session-based information in a database, like DynamoDB or MySQL, or on shared storage, like Amazon S3 or EFS. Additionally, Amazon SWF can be used to centrally store execution history and make your workload stateless. So the opposite of stateless applications are stateful applications. as it's not possible to turn some layers of your architecture into stateless components. For example, databases, which are stateful by definition, or applications that were designed to run on a single server. Providing multiple users a consistent view of the database or application is much simpler when your components are not distributed. Distributing the load is possible, though, through session affinity. This means that all transactions of a session are bound to a specific compute resource. However, this means that existing sessions would not be able to utilize newly introduced compute nodes. And also, if a node is shut down or becomes unavailable, users bound to that session will be disconnected. For situations when you need to process large amounts of data, it's always beneficial to see if a distributed processing approach can be used. Imagine a task that requires a huge amount of data processing. If it was to run on a single compute resource, it would max out the resources and take a long time to complete. If you can divide the task into smaller fragments of work, then each of the tasks can be executed across a larger set of compute resources. Examples of this are the AWS Elastic MapReduce service, which allows you to run Hadoop workloads across multiple EC2 instances, or Amazon Kinesis allows you to run multiple shards of data on EC2 or Lambda resources for real-time processing of streaming data. The concept of disposable resources is completely new with cloud computing, as cloud computing completely changes the mindset of an IT infrastructure environment. Traditional environments involved purchasing hardware up front and required manual configuration of the software, network, etc. Whereas with cloud computing, all infrastructure is temporary or disposable. You can launch new instances when you need them and get rid of them when you are done. Automate compute resource initiation is a way to speed up the creation of new environments. AWS has plenty of features to make new environment creation an automated and repeatable process. And there's 3 options available which we'll look at in the coming slides: bootstrapping, golden images, and a hybrid approach. Bootstrapping means you can take a newly launched AWS resource with its default configuration and then execute automated scripts to install software or copy data to bring that resource to a required state. So you could launch an EC2 instance and copy data on so that it becomes a web server. Scripts can be parameterized so that different environments, production or development, can be initiated easily. With AWS, bootstrapping can be achieved with your own scripts, Chef or Puppet, ops work, lifecycle events, or CloudFormation. Golden images mean you take snapshots of your EC2 instances or RDS instances or even EBS volumes, and they can be used to launch new instances. These EC2 instances can also be customized and saved as AMIs, Amazon Machine Images, and then you can launch as many instances as you want from this template. If you have an on-premise virtualized environment, you can also use AWS VM Import-Export to create your own AWS AMIs. The hybrid approach makes use of both bootstrapping and golden images. You can launch new instances from a golden image, but then bootstrap to configure other actions. Basically, with AWS, you are only restricted by your imagination or coding skills. AWS assets are programmable, so you can apply all these techniques and principles that we've just talked about to entire environments and not just individual resources, so you can completely rethink the way you work your IT infrastructure. Automation is a big part of planning and designing cloud infrastructure. AWS allows you to reduce the level of manual interaction in your environment. Using automation, you can react to a variety of events without having to do anything. Let's take a look at some examples. AWS Elastic Beanstalk. Developers can upload their code and the Beanstalk service automatically handles resource provisioning, auto-scaling, load balancing, and monitoring. EC2 Auto Recovery. In some situations, you can use auto recovery to automatically recover an EC2 instance if it becomes impaired. The recovered instance is identical to the original, instance name, IP address, metadata, etc. Auto-scaling. You can automatically add resources to cope with demand spikes and decrease again during quiet times. CloudWatch alarms and events. CloudWatch can send SMS notifications to alert when a particular event occurs. For example, CPU usage is too high. The notifications can be used to perform follow-up actions, like run a Lambda function. OpsWorks lifecycle events. You can continually update your instance's configuration to adapt to environment changes. For example, if a new database instance is added to your environment, then an event can automatically trigger a chef recipe that points existing applications to the new server. Loose coupling is an important concept. Applications should be designed so that they're broken into smaller, loosely coupled components. The desired outcome is that a failure in one component should not cause other components to fail. This is achieved through a variety of measures. Firstly, well-defined interfaces. By ensuring that all components only interact with each other through specific technology-agnostic interfaces, for example RESTful APIs, will result in being able to modify resources without affecting other components. Amazon API Gateway is a fully managed service for APIs, which you can do this with. Loose coupling needs services to be able to interact with each other without having any prior knowledge of their existence. For example, imagine two servers communicating on hard-coded IP addresses. Then the addition or modification of resources will result in manual interaction to update the configuration. However, loosely coupled infrastructure is an essential ingredient in making the most of cloud computing elasticity. The easiest way to achieve this is to use an elastic load balancer service to provide a stable endpoint for all your services. This way, they don't have to worry about each other. The elastic load balancer does that for them. Rather than use synchronous integration, where server A completes an action and passes it to server B, which then passes it to server C, asynchronous integration involves the use of an intermediate storage area, like an SQS queue. This approach means that when a server A completes its action, it sends a notification to SQS. This way the compute resources are decoupled and not directly linked to each other. This means you can easily add or remove resources without having to update the configuration of the existing compute resources. Designing applications to fail gracefully allows other resources to continue a service without causing a complete outage. Examples of this would be if your primary website fails, the Route 53 DNS failover feature points your users to a backup site hosted on a static website on Amazon S3. The idea is to continue to provide a service, even if it isn't the full experience. Traditional IT infrastructure involves developing, managing, and operating applications with a wide variety of underlying technology components. AWS isn't just about EC2 instances. There are a suite of products to do everything mentioned and a lot more besides, to help you lower your IT costs and allow you to move faster as an organization. For example, managed services. AWS provides many services that are fully managed: databases, machine learning, analytics, search, email, etc. This lessens the burden on your IT infrastructure department. RDS databases mean you don't have to worry about backups, fault tolerance for your simple databases. S3 allows you to store as much data as you need without having to concern yourself with capacity management. Serverless architectures. You can reduce operational complexity of your applications through the use of serverless architectures. Tools such as the Internet of Things, Lambda, S3, Beanstalk all allow you to run your applications without paying for any server infrastructure. In a traditional IT environment, the type of database in use is typically restricted by constraints on licensing, support capabilities, hardware availability, and things like that. AWS provides you with multiple managed database server options that remove these constraints, meaning that you can choose exactly the right database for your needs rather than making use of what is available to you. AWS offers fully managed, easy scalable services for relational databases, NoSQL, data warehouses, and search functions that provide fully managed, easily scalable services that can create synchronously replicated standby instances in different availability zones. And they'll also automatically fail over without the need for manual intervention. We'll cover databases in a whole lesson later on in this course. Now we'll take a look at redundancy. Introducing redundancy will ensure your systems are highly available so they can withstand the failure of individual or multiple components, for example hard disks, servers, or network links. Introducing redundancy will remove single points of failure from your systems. This is achieved by having multiple resources for the same tasks in either standby or active mode. Standby redundancy is often used for stateful components like databases. The standby resource becomes the primary resource by failing over to it. The standby resource can be brought online only when required to save cost, or it can already be running to speed up the failover process and minimize the outage. Active redundancy is where multiple redundant compute resources share requests and are able to absorb the loss of one or more of the instances failing. Examples of this would be multiple web servers sitting behind a load balancer. Automatic failure detection allows you to react to an outage automatically without the need for manual intervention. Services like Elastic Load Balancer and Route 53 let you configure health checks so you can automatically route traffic to healthy resources. For example, setting up a health check to test for a HTTP 200 response, which means OK, would allow AWS to know if a node is healthy or not. Services such as OpsWorks, Elastic Load Balancer, and EC2 Auto Recovery will let you replace unhealthy resources with brand new healthy ones. Durable data storage is an important part of planning your cloud resources. Replicating your data to other sites or resources will protect its availability and integrity. There's 3 ways you can replicate your data: synchronously, asynchronously, or quorum-based. Synchronous replication ensures that your data has been durably stored on both the primary and replication locations. Any write operation will only be acknowledged as complete when this has taken place. This should only be used on low latency network connections where absolutely necessary to try to ensure maximum performance. Asynchronous replication decouples the primary node from the replicate so that a write operation doesn't have to wait for any acknowledgement. This can introduce a replication lag but does not impact performance. And from personal experience, I've seen the difference between synchronous and asynchronous replication changing performance as much as 100%. Quorum-based replication is a mix of both synchronous and asynchronous replication. Replication to multiple nodes is controlled by defining the minimum number of nodes that must participate in a successful write operation. So if you have a cluster of 4 replicas, you can say, I need confirmation from at least 2 of them before the acknowledgement is sent back to the end user. A traditional data center failover scenario involves failing over all your resources to a secondary distant data center. Because of the long distances between the 2 data centers, synchronous replication is often impractical, slow, and usually involves data loss and isn't tested very often. However, it does protect against low probability scenarios such as a natural disaster. So if your main data center was in New York and your secondary was in, say, Washington, if New York had a massive outage, you could fail over to Washington, but it's going to be slow and practical and take some time. A more likely scenario is a shorter interruption in your data center, which isn't predicted to be too long. In this situation, your choice is to sit it out and wait, or initiate the complex failover procedure. AWS data centers are configured to provide multiple availability zones in a region, with low latency network connectivity. This means you can replicate your data across data centers in a synchronous manner, and as a result, failover becomes much simpler. Also, this concept is baked into many AWS services, such as RDS and S3. Active redundancy is great for disaster recovery situations or balancing traffic, but what if all the requests to your resources were harmful? For example, if a particular request caused a bug and it resulted in multiple instances crashing. A practice called shuffle sharding means only sending some of the requests to some of your resources. This way, if one shard of resources is infected or down, the other shard of resources will be up and running. In the example shown here, if request 2 is bad, then at least one set of resources is still protected. AWS economies of scale offer organizations huge opportunities to make cost savings. By making further use of AWS capabilities, there's even more scope to create cost-optimized cloud architectures. Right-sizing is one such approach. In stark contrast to traditional IT infrastructure, cloud computing means you can select the most cost-effective resource and configuration to fit your requirements. EC2, RDS, Redshift and Elasticsearch give you a wide variety of instance types to choose from. Through benchmarking, you can determine the optimal configuration for your workload. In some cases, it might be optimal to select many of the cheapest instance type available. In others, it might be more beneficial to select fewer instances, but of a larger instance type. AWS Storage offers the same level of right-sizing opportunities. Amazon S3 offers many different storage classes to suit your needs. EBS also comes in a variety of different volume types, all of which will be covered in later lessons. AWS offers many elasticity options to help you save money. You can auto-scale your EC2 workloads horizontally or vertically. You can turn off production workloads when you don't need them. And where possible, you can use Lambda compute workloads so you never have to pay for idle resources. EC2 on-demand instance pricing means you only pay for what you use with no long-term commitments. However, there are two more ways to pay for EC2 instances. One of these is reserved capacity. By committing to a defined period of between 12 to 36 months, you can receive significantly discounted hourly rates compared to on-demand pricing. AWS Trusted Advisor, or AWS EC2 usage reports, identify the resources that would benefit from reserved capacity. There is technically no difference between on-demand and reserved instances. The only difference is the way you pay for it. This concept also exists for Redshift, RDS, DynamoDB, and CloudFront. EC2 spot instances are ideal for workloads that have flexible start and end times, as you are allowed to bid on spare EC2 computing capacity, and spot instances are often available at significant discounts compared to on-demand pricing. Your EC2 spot instance is launched when your bid exceeds the current spot market price, and it will continue to run until either you terminate it or the spot market price exceeds your bid. When the latter happens, your instance is terminated, and you'll not be charged for the partial hour that it was running. So there's three strategies to use for spot instances. There's the one we've just discussed, which is bidding. You could bid much higher than the spot market price for as long as the instance runs. This way, even if the market price spikes occasionally, you'll still make a saving overall. The mix strategy. AWS recommends designing applications that use a mixture of reserved, on-demand, and spot instances. This way you can combine predictable capacity with opportunistic access to cheaper additional compute resources. And then finally, there's spot blocks. AWS allows you to bid for fixed duration spot instances. These have a different hourly pricing, but allow you to define a duration requirement. If your bid is accepted, your instance will run until you terminate it or the duration ends. Now let's take a look at caching. Caching data means storing previously calculated data for future use, so you don't have to recalculate it again. There's two approaches. Application caching. You can design applications to store and retrieve information from fast managed in-memory caches. This way an application can look for results in the cache first, and if the data isn't there, it can then calculate it or retrieve the data and store it in the cache for subsequent requests. This approach improves user response times and reduces load on your resources. An example of this is Amazon Elasticache, which is a service that provides an in-memory cache in the cloud suitable for use with web services. Edge caching uses Amazon CloudFront, so you can cache static content such as images or video and dynamic content such as live video around the world using edge locations. This way users can be served the content that is closest to them, and resulting in low latency response times. The principle applies to both download and upload with edge caching. And finally, security. It's important to have security built into your plans and designs for AWS infrastructure. AWS allows you to take most of the security tools and techniques that you already know and improve them by formalizing security control design into your AWS platform. This simplifies the system for administrators and auditors alike. Now we're not going to cover too much here because this is all covered in the IAM lesson. But there's things like defense in depth, which allows you to add multiple layers of protection to your resources, reduced privileged access, to only give people the access they require. Security as a code lets you capture security requirements in one script that you can use to deploy new environments. And real-time auditing. AWS has multiple services to ensure you can test and audit your environment in real time. AWS offers a wide and deep set of functionality that allows you to integrate your existing network, security, data, lifecycle management, and resource management capabilities with the cloud. AWS allows you to extend your existing on-premise network configuration onto your AWS virtual private clouds, so that your AWS resources will operate as if they're part of your existing network. You can do this using Amazon Virtual Private Cloud, VPC, which is a logistically isolated network in the Amazon cloud that gives you complete control over your virtual networking environment. You can choose your own IP range, subnets, route tables, network, etc. Then there's Direct Connect. Rather than use internet-based connections between your on-site resources and the Amazon cloud, Direct Connect lets you establish a dedicated network connection between the two to provide lower costs and a higher level of service. You can use AWS to reliably and cost-effectively back up and secure your data. AWS allows you to replicate your data across geographical regions, manage the lifecycle of the data, or even synchronously replicate your data to a local AWS data center. AWS Storage Gateway is a VM that you install in your data center and configure to be associated with your AWS account. Then you can either use Gateway Cached, which lets you use Amazon S3 storage as your primary data storage, while retaining frequently accessed data locally in your storage gateway, or Gateway Stored. Gateway Stored volumes let you store your primary data locally and asynchronously back that up to AWS. Amazon Simple Storage Service S3 offers a practically unlimited storage that's available for backing up and archiving your critical data, and Amazon Glacier is extremely low-cost storage for infrequently accessed data, for which recovery intervals of several hours are suitable. AWS Security and Access Control is easily managed using IAM or Microsoft Active Directory services. AWS Identity and Access Management is the service that enables you to securely control user access to all your AWS services and resources. An AWS Directory Service is a managed service that allows you to connect your AWS resources with an existing on-premise Microsoft Active Directory, or you can set up a new standalone directory in the AWS cloud. AWS Security and Access Control is easily managed using IAM or Microsoft Active Directory services. AWS Identity and Access Management is the service that enables you to securely control user access to all your AWS services and resources. An AWS Directory Service is a managed service that allows you to connect your AWS resources with an existing on-premise Microsoft Active Directory, or you can set up a new standalone directory in the AWS cloud. And there's three flavors of Active Directory. There's Microsoft AD, which is a fully blown managed Microsoft Active Directory service that supports up to 50,000 users. There's Simple AD, which is a standalone managed directory that's available in two sizes, small and large. Small is for up to 500 users, and large supports up to 5,000 users. Or there's AD Connector, and this is a directory gateway that allows you to proxy directory requests to your on-premise Microsoft Active Directory. And this also comes in two sizes, small and large. A small AD connector is designed for small organizations of up to 500 users, and a large AD connector is designed for larger organizations for up to 5,000 users. You can also use integrated resource and deployment management tools in your hybrid environment. AWS provides monitoring and management tools with robust APIs, so you can easily integrate your AWS resources with on-site tools. And most major software vendors already support AWS, like Microsoft, VMware, and BMC. Tools such as AWS OpsWorks allow you to deploy and operate applications in the AWS cloud or in your own data center. You can use templates or build your own tasks to specify an application's architecture. AWS Code Deploy automates code deployments to instances in your existing data center or in the AWS cloud. AWS Code Deploy simplifies the code deployment process to your instances.
Also, if you want to master the field of cloud computing, the postgraduate program in cloud computing, designed in collaboration with Caltech CTME, helps you become an Azure, AWS, and GCP expert. This in-depth cloud computing certification course lets you master key architectural principles and develop the skills needed to become a cloud expert. Benefits of this postgraduate program includes Caltech CTME Postgraduate Certificate, enrollment in Simplilearn's JobAssist. You will receive up to 30 CEUs from Caltech CTME. You'll attend masterclasses from Caltech CTME instructors, live virtual classes led by industry experts, hands-on projects and integrated labs, online convocation by Caltech CTME Program Director, 40 plus hands-on projects and integrated labs, capstone project in 4 different domains, and Caltech CTME Circle membership. You can also fast-track your career with this cloud computing certification and its in-depth course curriculum, which covers the key concepts of Microsoft Azure, Amazon Web Services, and Google Cloud Platforms, and services such as AWS Lambda, Amazon S3, Azure App Services, and many more. So this program also covers the essential skills to become an expert in cloud computing, and you can consider this program because it provides you with a certification from Caltech CTME, a well-reputed university in the United States. So what are you waiting for? Check out the link mentioned in the description box below and start your cloud computing career today. So without any further delay, let's get started.
Let's see the steps to create an AWS account. The first step is to open the AWS web page. Then, click Create a Free Account to display the sign-in or Create an AWS Account page. In this page, click I am a new user. Enter your email ID or mobile number in the email or mobile number box, and then click Sign in using Secure Server. The AWS servers verify if an account already exists with the entered email ID. If yes, it displays an error message, else displays the login credentials page. In the Login Credentials page, enter the name. Re-enter the previously entered email ID and the password for your account. Then, click Create Account to display the contact information page. This page gives you the option to create a company account or a personal AWS account. For this demonstration, we will create personal AWS account. Then enter your full name and address in the displayed fields. Next, enter the CAPTCHA characters from the displayed security image. An important step is to open the AWS agreement and read it thoroughly. Then select the AWS Customer Agreement checkbox. Selecting the checkbox indicates that you have read the AWS agreement and you agree to it. Then, click Create Account and continue to display Payment Information page. In this page, enter the credit card details, and then click Verify Card and continue to display the Identity Verification page. Before displaying the Identity Verification page, the AWS servers verify the entered credit or debit card details by performing a reversible transaction of a small amount. This page displays your entered mobile number and is used to verify and confirm your identity. As you click Call Me Now, the AWS system calls you on the displayed number and your computer screen displays a 4-digit verification PIN. Enter the displayed 4-digit PIN in your phone using the keypad. Once the verification is successful, the page displays a message, Identity verification complete. Simply click Continue to select your support plan to display the support plan page. This page displays and explains about the 3 support plans: Basic, Developer, and Business. For this demonstration, we will select the free or basic plan, and then click Continue to display the welcome page of the AWS services. Congratulations! You have successfully created an AWS account.
AWS EC2, a compute service in the cloud, through this video. Somewhere far in the country, a scientist has a lab far in the woods, and at one day he stumbled on a calculation that he had trouble solving. And he was very certain that his computer can handle it. And he asked his computer to do the math or the calculation for him. And the computer thought about it for a while, then took a couple of hours in trying to process the data. And eventually, at one point, it gave up and died due to low memory. And this old scientist is now clueless about how he was going to finish the task and complete his invention and let the whole world know about it. And that's when he was introduced to this new friend AWS, as you see on the screen. AWS was very handy in replacing his old machines, and it was able to give him the service that he wanted at that moment. AWS has been around for a while, helping people with their computer needs, and now this new scientist friend in need is welcomed by the new and trendy IT technology AWS, and sure enough, his new AWS friend welcomed and walked him through the new way of computing. And this new happy-faced AWS friend talked to this scientist about AWS EC2 in specific, and walked him through about all the new innovations in IT and in cloud that he had been missing all these days. So his new friend AWS started the conversation about explaining how there is no need for any hardware units, no managing hardware or provisioning in AWS. And secondly, it explained increasing and decreasing the capacity as per the demand is just a click away. And the best part here is that there is no upfront commitment, and we only pay for what we have used, just like we pay electricity and water bills. And all this comes with complete control from our side. In other words, the whole key for this infrastructure is with us. And as if this was not enough, all this comes with enterprise-grade security that's beyond imagination in on-premises. And if this still does not excite you, then this definitely would. You can work from anywhere in the world. Now this really made the scientist to get excited, especially when he thought about working from home. Working from home, there is nothing like it, isn't it? Now this person, this scientist, is not tied up to a particular environment. He can work from home, work on the fly, work from anywhere. Still, the data and everything else in his IT environment is secure and safe. Now let's move to the next level of discussion. Let's talk about what is EC2 and some of the use cases of EC2. And this use case we're going to talk about, or this architecture we're going to talk about, it notifies a group of users about a new letter. And the components or resources this architecture would need be first EC2 instance, then SNS, a simple notification service, and coupling EC2 and S3 service together. That's all it would require to get an architecture that notifies a group of users about a new newsletter. And now I think it would be a good time to talk about what EC2 is. AWS offers plenty of services offered under different domains like compute, storage, database, migration, network, management tools, media services, security, business productivity, application integration, machine learning, game development, and a lot more coming up, out of which EC2 falls under the compute capacity. So what is EC2? EC2 is a web service which aims to make life easier for developers for providing secure and resizable compute capacity in the cloud. With EC2, it is very easy to scale up or scale down our infrastructure based on the demand. And not only that, this EC2 service can be integrated well with almost all the services in Amazon. And out of all this, the best part could be we only pay for what we use. Alright, let's talk about this use case. A use case here is that a successful business owner has a bunch of users and a successful product that's running, and now he has developed few more products that he thinks will be very successful, that he thinks his customers are going to like. Now, how can he advertise his product to his new and prospective customers? Or the solution for this question can be addressed by AWS. In AWS, we can use services like Simple Notification Service, SNS, and EC2 for compute and S3 for storage. We can, in a way, integrate them all and achieve this business use case. And that sort of got this business owner very cheered up, and now he wants to use the service and he wants to get benefited from the service. He wants to advertise, or he wants to notify his users every time the company creates a newsletter. Alright, so let's talk about what it would take to get this environment up and running, or what it would take to connect the environment and put the applications on top of it. Firstly, we would require an AWS account, and then for compute capacity, we would require an EC2 instance. And here's how we go about doing it. The first thing is to create an AMI, which is Amazon Mission Image. That's really the softwares and the application packages we would need to run our application. And the second is to choose the hardware. In here it's the instance type. Depending on the workload, we would be choosing the hardware, and depending on the intents of the workload, we will be choosing the size of the hardware. And finally, we would configure the instances. How many instances do I want? Which subnet do I want them in? And what's going to be the stop or terminate behavior of the instance, and do I want to update any patches when the instance starts running? All those pieces of information go in here when we configure the instance. And then the first three steps is really about the OS volume and the basic hardware. Now it's time to add additional storage to the EC2 instance. That would be step 4. Here we add additional storage to the EC2 instance. And then tags, we use tags, or we would configure tags to easily identify an EC2 instance at a later point. We give it some meaningful names so we can identify, like which team it belongs to, which billing department it belongs to, what's the purpose behind launching this instance, stuff like that. In an environment where we run 700 to 800 or even more instances, identifying an instance and trying to understand who owns the resource, for what purpose we created, it could be an full-time work. So tagging comes to our rescue at that time. After tagging, as step 6, we would configure the firewall, which is also called security group, for the EC2 instance. And this is where we would allow or deny connection from external world to this particular EC2 instance. Well, it works both ways, from outside and from inside out. This firewall blocks the connection based on port number and IP address. And finally, as step 7, we review all the configurations that you have done, and we make sure that the configurations is what we wanted, and finally click on submit. That's going to launch an EC2 instance. Alright, this was just an overview of how to create an EC2 instance. Now let's talk about each and every step in detail. So to begin with, let's talk about how to create an AMI. Well, the AMI is just a template that's used to create a new instance or a new computer or a new VM or a new machine based on the user requirement. The things that go into an AMI are the software, the operating system, the additional applications that get installed in it, stuff like that. The AMI will also contain software information, information about operating system, information about access permission, information about volumes. They all compact in the AMI. Again, the AMI is of two types. One is predefined AMIs, or called Amazon provided AMIs. The other one would be custom AMIs, the AMIs that we create. And if you're looking at a particular AMI that you don't want to create but still want to get it from Amazon, there is a place or a portal called AMI Marketplace. There we get like thousands of AMIs in there available for us to shop and use them on a pay-as-you-go business model, and use them as pay-as-you-go billing. So there you can search AMI that you're looking for, most probably you'll be able to get it there. Now let's talk about choosing the instance type. The instance type is basically the hardware specification that's required for a machine that we're trying to build. And the instance types is categorized into 5 main families. They are, to begin with, it's compute optimized. Now compute optimized gives us lots of compute power or lots of processing power. So if my application is going to require a lot of processing power, I should be picking compute optimized instance. And the second one is memory optimized. Now this is very good for applications that require in-memory caching. There are some applications that performs well with cache or through cache, or the application would create a lot of data that it wants to keep in cache for rereading or for processing, for lengthy processing, stuff like that. For those type of application, this memory optimized instance that comes with in-memory cache is a very good use case. And the third one is the instance that comes with the GPU, otherwise called GPU optimized. GPU stands for graphical process unit, and this is very good for application that deals with gaming. This is very good for application that's going to require large graphical requirements. And storage optimized is the fourth option. Just like the name says, this is a very good use case for storage servers. And the fifth family type is general purpose. Just like the name says, it's for general purpose. If you're not particular about the family, then you generally would end up picking the general purpose, because here the services are sort of equally balanced. You'll find a balance between the virtual CPU and the memory and the storage and the network performance. It's sort of balanced. All the components, all the features that needs to go in a computer are sort of balanced in general purpose. Now these instance types are fixed and they cannot be altered because it's hardware based. We buy hardware. We do not have much control on the hardware that's being used. Well, we have options, but we do not have control on the hardware. And these instance types are divided into 5 main families. They are compute optimized, memory optimized, GPU enabled, storage optimized, and general purpose. Then as third thing, we have to configure the instance. Now here is where I have a lot of options about purchasing. What type of purchasing do I want to do? Do I want to go for a spot instance? Do I want to go for a reserved instance? Do I want to go for an on-demand instance? These are different billing options available, and that's available under configure instance. Not only that, here's where I'm going to put the EC2 instance. Do I want an public IP address assigned to it? Do I want an IAM role attached to it? IAM role is authentication. What kind of authentication am I going to provide? And the shutdown behavior. The shutdown behaviors include, do I want to stop the instance when the user shuts down the machine from the desktop, or do I want to simply terminate the instance when the user shuts down the instance from the desktop? So those things go in here, just like the name says, configure instance. A lot of instance configuration options comes in here. That's the third step. And not only that, under the advanced details or advanced tab under configure instance, I can bootstrap the instance with some scripts. Now bootstrap is nothing but the scripts that you want to be run in the instance before it actually comes online. Let's say you're provisioning the instance for somebody else. Instead of you launching the instance and then logging in and running some commands and then handing it over to the other person, you can create bootstrap shell scripts and paste it in a console option available under configure instance, and Amazon is going to take those commands, run it on the instance before it hands over to the user that initially requested for that instance. Now it could be a different user or just you. It sort of automates software installation procedures in the instance that we will be launching. And not only that, there are multiple payment options available under configure instance. The user can pick an instance under normal price, and that instance would apply normal rates applied to it. And there are also options like reserved instance, where the user can pay for an instance upfront before a year or before months, for a span of year or a span of months, and that way they can pay less per hour for using that instance. Not only that, you can also go for spot instance, like bidding for those instances. Whoever bids more they get the instance for that particular time. Well, these instances are a lot cheaper than on-demand instances, and through bidding and buying you can keep the instance as long as your bid price doesn't exceed the price that Amazon is proposing. And as the fourth step, we will have to add storage to the instance that we are about to launch. And here we have a bunch of storage options. I can go for ephemeral storage, which is free, or I can go for an external elastic block storage, also called EBS, which is paid and it's a permanent storage, or else I can integrate my EC2 instance with S3 for its storage needs. And the best part about storage is free subscription users, they get to use 30 gigabit of SSD storage or magnetic storage for the whole year. In this page where we are ready to add storage, we will have to mention or provide the size in gigabit and the volume type. Is it going to be an provisioned volume? Is it going to be an general purpose volume? Is it going to be a magnetic volume? Stuff like that. They are volume types, and we also need to give inputs about where the disk will be mounted and whether this volume needs to be encrypted or not. So all these options or all these inputs are received from us under the adding storage section. And then the fifth option would be adding tags. Like we discussed some time back, tags are very helpful to identify a machine in an environment where we have 700 or 1000 VMs running. And security groups are the actual firewall that sits in front of EC2 instance, and it protects that EC2 instance from unintended inbound and outbound traffic. Now here is where I can fine tune the access to my EC2 instance based on port numbers and based on IP address from which it can be accessed. And finally, we get to review the whole changes or the whole configurations that we have made to find out whether they are intact with the requirement, and then click on submit. That's going to launch an EC2 instance. But hold on, we're not done yet. When we're about to launch, or before the Amazon console actually launches the EC2 instance, it's going to give us an option to create a key pair. Remember, I said it's key pair. Key pair is two things. One is public and private. The private key is downloaded by the user and is kept with the user, and the public key is used by Amazon to confirm the identity of the user. So just go ahead and download the private key and keep it for yourself. And this private key gets downloaded as an .pem file. It's a format of the file, and it gets downloaded as .pem file. And our next step is to access the EC2 instance. And because the instance that we have launched in this example, let's assume it's a Linux instance, and that's going to require a tool called PuTTY to be able to access it. And this PuTTY tool is really needed when we are trying to access an Linux instance from Windows instance. Most of the time, Windows instance will have PuTTY installed in them, but in some rare cases, they do not come with PuTTY. In those cases, we can go ahead and download PuTTY and PuTTY generator, and we can start using it to access the Linux instance. Now you might ask, well, I understand PuTTY, what's PuTTY generator? Now the file that we have downloaded is in .pem format, but unfortunately PuTTY does not accept .pem format as input. It has to be converted into a different format called PPK. And PuTTY Gen is a tool that helps us to convert the .pem file into PPK file. So the quick way to do it is download generator, open it up, click on conversion, and insert the .pem key that we have downloaded and save the private key. And this, when we save the private key, it gets saved as a .ppk type private key. And when that's done, the next very step is to open PuTTY and try to log in. And the way to log in is to open PuTTY, put that IP address here, and then click on auth. This is where we would input the file that we have created. So click on auth and then click on browse and find the .ppk file that we have converted and stored, browse it and upload it, and then click on open. Now that's going to open up a login screen for us. And the AMIs comes with a default username. Depending on the AMI that we have picked, the username might differ. In our case, we have picked an AMI for which the username is ec2-user, and this is the default, by the way. Let's put the username ec2-user and hit enter, and that's going to open up the Linux instance using CLI. There are a few other things that we can do with the terminal that we'll explain it a little later. Alright, so we have successfully launched an EC2 instance, and yeah, give yourself a pat on your back. Launching an instance was just one part of the solution. So let's actually talk about how we can notify our customers. SNS, or Simple Notification Service, is a service or a product in Amazon that helps us to notify customers through email. So navigate to SNS in your account and create a topic, and we're going to use this topic for public notification. So let's make it public and then add subscribers to it. Now these subscribers are the people who you want to be notified about the newsletter. So we already have the email database in there. Add them to the subscribers list, and then they will start getting new newsletters as and when we post them to the topic. And as next step, create a bucket in S3 where you can store content, and in that bucket create an event that triggers a notification to Simple Notification Service. So this is how it will be set up. A notification will be sent to our subscribers anytime we put something in our S3 bucket. So S3 bucket is going to create an event for the notification, and the notification is going to make sure that it's delivered to your end customer because they're already subscribed to the topic as subscribers. And finally, let's connect the S3 with EC2 so the bucket and the AWS instance are in sync. So we put some content in the S3 bucket, our email system notifies our customers, and the customers can go online to a website that's hosted in EC2, and because S3 and EC2 are in sync, the items that we put in S3 will also show up in EC2. See how this is all connected and it's working together. And once this is all connected, our subscribers will regularly be informed anytime we put new content in the S3 bucket, and the same content will be made available in EC2 instance through the website. In this section, we're going to learn about why we need a solution called CloudFormation, or why we need a product called CloudFormation. And we're going to talk in detail about what is CloudFormation, and then how CloudFormation works and the concepts involved in CloudFormation, like templates and stacks. There are some concepts involved in CloudFormation. We're going to talk about that. And how do we maintain access control over CloudFormation? We're going to talk about that as well in this video. And then we're going to go through a demo or a lab where we create an LAMP stack environment from a template through CloudFormation. And then we're going to talk about some use cases, one of which include being able to create an redeployable template using CloudFormation. That's a very good use case. We're going to talk about that in this video. So let's talk about why CloudFormation. So when the number of products and services grow more, and managing them and maintaining them becomes an tedious work, and CloudFormation, it sort of eases that environment. Now, CloudFormation is really an infrastructure as a code, and it sort of solves all the problem that we discussed some time back. And with CloudFormation, we can actually create a perfect clone of the server configuration at any point in time. And we can also manage the configuration changes With CloudFormation, we can manage the configuration changes across the environment. And not only that, we can easily embed in the ad hoc changes to our existing environment. So one might ask, why use CloudFormation? Let's look at the current problem that we have. Creating and managing multiple AWS resources in the portal is a big task, especially when you need to replace some services. It becomes a bigger task. Now, CloudFormation eases that work. Let me explain it in detail. Now, at the moment, without the CloudFormation, or environments that don't use CloudFormation have this problem. That is, a lot of time is being spent on building the infrastructure, and less focus and less time at the moment is being given on developing that application that runs on that environment. That's because majority of the time is consumed by building the environment. And if we need to redeploy the same environment again and again, the same happens in a cycle. Again, in a new environment, we start from the scratch, build the environment, and then put application on top of it. Now that can be avoided using CloudFormation. Now without CloudFormation, it still is a problem because the resource or the bandwidth that is needed for the application development is not provided, because that's taken by developing the infrastructure. And to solve that problem, we can use CloudFormation. Now that leads to a discussion about what is CloudFormation. So let's talk about, or let's try understanding what CloudFormation is. CloudFormation is a service that provides users a simple way to create and manage collection of AWS resources by provisioning and updating them in a very orderly and in a predictable way. If I need to expand explanation of CloudFormation, CloudFormation is a service that really helps us to model and set up our Amazon Web Services or resources so we can spend less time on managing the resources and show more focus on the application that runs on top of it. We can simply create a template for an EC2 instance or for an RDS instance and upload it in the CloudFormation portal, and CloudFormation will provision and configure those resources based on the template that we define. We really don't have to sort out the complexities in dependency between those applications. Once the template is vetted and validated, CloudFormation takes the responsibility of handling the dependencies between the application in an orderly and a predictable way. It creates those services and makes it available for us once the template is fully run. So in short, the CloudFormation, it allows us to create and model our infrastructure and applications without we having to perform the manual action. For example, the well-known company called Expedia is able to easily manage and run its entire front and back-end resources they run on AWS in CloudFront. What does that mean? They are spending less time on managing the infrastructure and more time on the core business and the application that runs on top of it. And we're still talking about what CloudFormation is. With CloudFormation, it enables us to manage our complete infrastructure or AWS resource in a text file. Now we're going to see that in a moment. It's either a JSON or an YAML file, and that file is called as the template to begin with. The resources the template provision is called the stack. All right, so the abstract of the code is called the template, and the resource that it provisions is called the stack. And this stack can be, it's going to run resources, obviously, and those resources can be updated as well. It's not like once you create a stack, it's done. If you need a change, you need to go create another resource. That's not needed. This stack is an updatable stack. Let's say if I'm including 2 more servers, if I'm sort of extending my environment, it's branching out to another application. Now I'm including another functionality in my environment. All those can be embedded in the update and can be updated. So like I said, the stack is an updatable one. Now let's talk about what the template can do, or some features and functionality of the template. Now, using a template, we can almost include all the application and resources that a user might require. Let's say, after the EC2 instance is provisioned, running an application on top of it, and you want to templatize that and include that in the template, that's possible as well. And these templates are portable ones, meaning I can use the template in one region and I can use the same template in another region, and that's going to build a very similar environment in another region. I can also share that with the customer, and when they run it, it's going to run an environment from the portable template in their account, in their environment. Of course, all the security is taken care. I'm just saying that if we need to build a resource, if we need to build an architecture, if we need to build an environment which looks very similar to the other environment, that is possible. And these templates are reusable by the use of some sections in the template, like the parameter section, the mapping section, the condition section within the template is what makes the templates reusable. And we will talk about parameters, mapping, and conditions down the line. We're still talking about how AWS CloudFormation works, and we're going to talk about how a template becomes an infrastructure. Right? So to begin with, one requires a template, and the template would be in JSON or YAML format. So one would develop a template based on the requirement, based on number of EC2 instances, based on whether they want a load balancer, based on whether they want a Windows server, based on whether they want an database server in that environment, and then based on the applications that will be running on top of it that can be templatized in the code itself. So one creates a code, and then the code is saved locally, or they can be put in an S3 bucket from which the CloudFormation will call the template and provision the resource. Right? So we use CloudFormation to create a stack or create the resource defined in the template. And CloudFormation analyzes the template first, validates the template, and then it identifies the dependencies between them, and then it starts provisioning the resource one after the other. For example, if you need 5 servers in a new VPC, obviously it's going to create the VPC first and servers second and stack. All right, let's understand the two major components in CloudFormation. By now you might have guessed it. The two major components are the template and the stack. Together they aid or they complement CloudFormation, and that's how the resources are provisioned, that's how the resources are managed, and that eases the job of the administrator who's managing the environment. So let's talk about template first. A template in CloudFormation is an text file or a formatted text file in JSON or YAML language, and that the code or the template or the text file that actually describes how your infrastructure looks like or will look like once provisioned. And for us to create the template or for us to modify an existing template, we can use a tool available called CloudFormation Designer from the console or any text editing tool that's available. But I would recommend the CloudFormation Designer though, that has rich graphics in it. And these templates are built off, or they consist of 9 main objects. The first of which is the format version, and this really identifies the capabilities of the template based on the version number. And then the second object in a template would be description, and this helps us to include any arbitrary comments about the template. For what reason are we building this template? What's the purpose of it? Stuff like that. And then we have the object called metadata in a template, and that includes details about the template, details of the resources in the template. And then we have the optional parameters section. This really helps us to customize our template. Now, parameters enable us to input custom values to our template each time we create or update and stack. And the mapping object, it helps us to match a key to a corresponding set of named values. For example, if you want to set a value based on region, then we get to create a mapping that uses region name as the key, and then the value that we want to specify for each specific regions. And then we have conditions object. This is again an optional object. With this, we can include statements that define when a resource is created or when a property is defined. For example, we can compare whether a value is equal to another value, and based on the result of that condition, we can conditionally create additional resources. And then the object called transform. It's an optional object as well, and this transform section specifies one or more transforms that we can use in our CloudFormation template. For example, AWS CloudFormation transforms helps simplify template authoring by condensing the expression of the AWS infrastructure as a code or the CloudFormation template, and it enables reuse of template components. For example, we can condense multiple line resources, declaring it into a single line in our template. Now we will talk about all these examples in the upcoming slides. And then we have the required section called resource that declares the AWS resource that you want to include in the stack. For example, if you want to include an EC2 instance, if you want to include an S3 bucket, we would be using the resource object in our stack. And then we have object called output. This output object, it's an optional object in the template, and it helps us to sort of declare the outputs that we can import into other stacks, or we can actually show it on the CloudFormation console. For example, if you want the output of the name of the S3 bucket that got created in response to a CloudFormation template, now we can have that outputted into an output section in the CloudFormation console itself. So it's sort of easy for us to identify the resources that the template provisioned. So with all of those objects put together, this is how a full-blown CloudFormation template with all the objects included is going to look like. Now this includes optional and mandatory objects. Let's talk about those objects in detail in the upcoming section. Alright, let's now discuss each and every object of this template structure. And let's begin our discussion with the format version. The format version, it really defines the capabilities of the template. The latest version, format version as of now, is the one that was updated on 2010. Now the value of the template format version, it has to be an string, and if we really don't specify the format version, CloudFormation automatically assumes the latest version. Talking about descriptions are really any comments that help ourselves that we want to embed in the template itself. That can be a description. And this description in a template, it has to be an string. The length of the string can be between 0 to 124 bytes in length. The metadata are really used in the template to provide any additional information using the JSON and YAML objects. And metadata holds some implementation details of a specific resource. And parameters are really a way to customize the template. Each time we create or update our stack, these parameters are the ones that helps us to give some custom value to the template during runtime. In the example shown below, the parameter named instance type parameter, it lets us to specify the EC2 instance type for the stacks to use when creating or updating the stack. By default, as we see, it's picking T2 micro, and this is the value that will get picked if we don't provision another value to it. And mapping really enables us to map a key to a corresponding named value that we specify in a conditional parameter. And also we can retrieve the map or retrieve the values in the map using the function findInMap instrict function. Let's take this example. Let's say based on a region, if you want to set values in a template, we can create a mapping that uses a key and holds the value that you want to specify for each region. And the object conditions can be used when we want to reuse the templates by creating resources in a totally different context. For example, in a template, during stack creation, all the conditions that we mention in the template are evaluated, and any resources that are associated and that come up to be true are created, and any condition that fails or invalid are kind of ignored automatically, and the check moves forward to the next condition. And conditional is an optional object, and it includes statements that define when a resource is created or when a property is actually defined. For example, you can you can compare whether a value is equal to another value, and based on the result of that condition, we can conditionally create resources. If you have multiple conditions, then they are generally separated with commas. Sometimes conditions are very helpful when we want to create templates and we want to reuse those templates which was created for one environment to another environment. For example, if you want to use a template that was created in a test environment in a dev environment, conditions could be helpful. For example, in a production environment, we might want to include instances with certain capabilities, and in a test environment, we might want to include instances with some reduced capability in them for saving money. And condition helps us to create resources based on the environment it will be used in. We can also use intrinsic functions to define conditions like equals. We can also use OR conditions. We can use NOT functions, intrinsic functions in a condition. And when put together, the syntax is going to look like the one that you see on the screen. Now, the optional object called transform, it specifies one or more transforms that the CloudFormation uses to process our template. Now, these transform sections are built on a simple declarative language of AWS CloudFormation with a powerful macro system that helps us to reuse the templates or the template components. And they really help us to condense or simplify our codes by enabling reuse of the template components. For example, condense a multiple line resource declaration into a single line in our template. The resource section, it really declares the AWS resource that you want to include in the stack, such as EC2 instance, such as S3 bucket. And some of the resource fields are the logical ID, the resource type, and the properties. Let's talk about them in brief. The logical ID is unique within the template, and the logical ID name, it actually references the resource in other parts of the template. In this case, it's my bucket. For example, if we want to map an elastic block store volume, or if we want to map an name of the bucket in another place in the template, then we would use the logical ID. And again, in this case, it is my bucket. A logical name has the physical ID with which we actually assign the resource. For example, in this case, my S3 bucket was named as my bucket to begin with. And the resource type In the template, it identifies that the type of the resource is an S3 bucket, and the properties are the additional optional information that we can specify to our resource. For example, if it is an EC2 instance, let's say we would like to know which AMI it used, then property section really defines the AMI that was used, or AMI as the property of the instance. So this section describes the output value that needs to be imported to other stacks, or the output value that needs to be shown in the console for the user to easily navigate to the resource that are being created. For example, for a S3 bucket name, we can declare an output, and once the bucket is created, we can actually declare the output and sort of import the name of the bucket in a different place in the console, so it's easy to view instead of the user getting confused and going to S3 and searching for the bucket name. This can be made available in the CloudFormation console itself. And the output fields, it can include some of these followings, like the logical ID. It's actually the identifier of the current output, and it's very unique within the template, and it can also include a description. Description is really a string type that describes the output value, and it can also include value, and value is the property that was returned by the AWS CloudFormation describe stacks command. Alright, let's talk about the template resource attribute. In this section, we're going to talk about attributes that you can add to a resource to control additional behavior and relationships. So let's talk. There are many resource attributes available, out of which we have, if we need to name them, we have a creation policy, and then we have deletion policy. It depends on metadata attribute, update policy attribute. Let's talk about each of them separately. When we associate the create policy attribute with the resource, it actually delays the resource configuration actions before proceeding with the stack creation. The attribute stack creation is delayed till the time the CloudFormation receives some number of success signals back. This is a very good use case when we do auto scaling. And this creation policy can be used only with a limited number of services like autoscaling and EC2 instances. Some of the use cases would be if you want to install a software application on an EC2 instance, you might want the applications to be running before it proceeds further. So in this case, we would use the creation policy attribute to the instance and then send the success signal after the applications are installed and configured. Then CloudFormation goes to the next step. Here in the syntax that we're looking at, the autoscaling creation policy and the minimum successful instance percentage, it's actually a number of signals that it will have to reply back before it can move forward. Using deletion policy, it preserves backing up of resources when the stack is getting deleted, and by default, if you don't have a delete policy, the data gets deleted just like that. But if we use an deletion policy, we would be able to preserve the data by taking a snapshot of it, or just letting the resource and moving on with deleting the other resources in the stack. And we specify the delete policy attribute for each resource specifically that we want to control. And if there are no deletion policy mentioned for a particular resource, the CloudFormation simply deletes the resources as that's its default behavior. And if you want to keep the resource when the stack is deleted, we mention retain in the delete policy, and that simply retains the resource from getting deleted. So in this example, we're actually retaining an DynamoDB table. Rest of the resources in the stack will get deleted. And using the depends on attribute, we actually create an order in which the resource gets deleted. For example, if I map one resource to another resource and say that this resource depends on the other resource gets created first, then followed by this instance or this resource. So with the depends on attribute, we can specify that the creation of specific resource is actually followed by another. When we add the depends on attribute to a resource, the resource is created only after the creation of the resource specified by the depends on attribute. Let's take this example. In this example, we're saying that the resource X depends on Y. We've said that X depends on Y. So in this case, when CloudFormation is executing, it's going to deploy Y first because it has some resources that depends on it. So it's going to create Y first, and then it's going to create the resource called X. On the same context, let's say in the template, we say that an EC2 is going to depend on S3, and when the CloudFormation is executing, it's going to create an S3 bucket first and then the EC2 instance. That's probably because the codes needed for the EC2 instance are stored in the S3 bucket. And what we're looking at is the syntax of how the depends on template resource attribute will look like. This is how it actually will look like when we put it in the CloudFormation. The instance depends on the bucket. The other template resource attribute is metadata. Metadatas are the one that really helps us to associate our resources with the structured data. And by including this attribute in our template, or by including this attribute to a resource, we can specify the data in JSON or in YAML language. For example, in this section of the template, we're creating a VPC, and the metadata explains, or metadata defines, that the VPC is part of the region US East 1. And the update policy template resource attribute in CloudFormation, we can manage and replace the updates of the instance in an auto-scaling group. For example, you're looking at this sample where it says that the update policy, will it replace the instance in an auto-scaling group or not? So depending on what the value is for the will replace section, whether it's true or false, depending on that, the update policy will replace the instance or will replace the auto-scaling group itself when it's doing a rolling deployment. Now that we've discussed about templates, let's talk about AWS stacks as well. Now we know that AWS stacks are the actual resources that gets generated or that gets created because we ran a template, right? So stack is a collection of AWS resource that we can manage in a single unit. In other words, we can create a stack, update a stack, or delete a stack, and that would actually create, update, delete the collection of resources within the stack. And all the resources in the stack are really defined by the CloudFormation template. And a stack, for instance, can include all the resources required to run a web application, such as a web server, a database server, and some networking rules that come along with it. All that gets embedded in a stack. And let's say if we want to delete all the resources that were created by template that is in a separate stack, we can simply delete the stack, and that would sort of delete all the resources that is in the stack. So it sort of helps us to manage all the resources in a single unit or as a single unit. So to summarize, stack is a collection of AWS resource, and it can be managed as a single unit. And the CloudFormations template defines a stack in which the resource can be created, deleted, or updated in a very predictable way. And a stack can have all the resources like web server, database server, VPC, the network and the security configurations in a VPC, all that is required to run a web or a database application. Now, stack could be nested as well. With CloudFormation, we can actually nest a stack with another stack, and that's going to create a hierarchy of the stacks. For example, there's a very good picture that explains how the stacks are nested in a hierarchical way. Let's say stack P is the root stack, and that could be a parent stack for the stack called R and the stack called Q. And the same way, the stack called R is a parent stack for the stack S, and the stack S is the parent stack for T and Q. You get that, right? So stacks can always be nested. It's possible. CloudFormation allows us to create a Microsoft Windows stack based on Amazon EC2 Windows AMIs, and provide us with the ability to install software and use a remote desktop to access our stack and update the configuration of our stack. And these stacks can be run on Windows Server instances. There are a number of pre-configured templates available, and it's directly available to use from the AWS website itself. To name a few, we have templates available for SharePoint running on an Windows Server 2008 R2. We also have templates that create a single server installation of Active Directory running on a Windows Server. And in fact, we have templates available for Elastic Beanstalk and some sample applications that runs from an Windows Server 2008 R2. Let's talk about stack sets. Stack sets actually has taken the stack level implementation to the next level. Using the AWS CloudFormation template, we can define a stack set that lets us to create stack in AWS account across the globe by using just a single template. And after we create the stack, or after the stack set is defined, creating, updating, or deleting the stack in the target account and the regions can also be specified by us. So the stack set, it really extends the functionality of the stacks by allowing us to create, update, and delete stack across multiple accounts, regions in just a single operation. And using an administrator account, we can define and manage an AWS CloudFormation template and use the template as the basis for provisioning stacks into some selected target accounts across a specified region. Let's talk about CloudFormation access control. With IAM, I can specify the list of users or list of privileged users who would have access to the CloudFormation template, who can create, update, and delete stacks. So that's how IAM helps me with having or putting a layer of control over the CloudFormation service. And we can also use service roles. Service roles are the one that allows AWS CloudFormation to make a call to a resource in a stack on the user's behalf. And I can also have stack policies, and these stack policies are applied to the users who already have access to the CloudFormation service. And these policies are the ones that help the users who attempt to update the stack. All right, let's do a quick lab on creating an LAMP stack on an EC2 instance with a local MySQL database for storage. Now, we can do the other way as well. I can pick an EC2 instance and install the servers one top of the other. That can be done as well, but that's going to take a lot of time. Now, we're talking about automating it. We're talking about, provisioning an infrastructure using a code, and CloudFormation helps us to do that. So this is what we're going to do. We're going to create, or we have a CloudFormation template already, and we're going to use that template to provision a web instance, and that is going to have, look at that, that's going to have MySQL installed in it, that's going to have PHP, that's going to have HTTPD service installed in it and running. And it's also going to have a PHP website running from it. So that's going to receive information from the website, and that's going to store that information in the database that's very local to it. This is the template that defines that environment. All right, this is a very simple provisioning. So let's provision this environment. Let's create a stack. We're going to give a stack name and a database password. Right, and which region is it? This is in California, is it? All right. Now let me do one thing. Let me switch to the Mumbai region, or let me switch to North Virginia region. North Virginia, and from here, actually, let me switch to Mumbai region. Right, just to be sure, it's the same template that we are provisioning. Right, that's the same template that we are provisioning. Right, let's give this name. So it can be great. This could be Simplilearn. Simplilearn LAMP stack, and what could be the DB password? And DB root password, and what could be the DB user. I'm going to keep the rest as defaults, and I'm going to launch. All right, so there's an issue with the password. Password should only have alpha numeric characters. Get that. So let's go back and create a new password. Right. It also needs to have 8 characters. So what can be our password? Look at that. The template is actually creating the resources. And here on the screen, we can see the template that we used to deploy the environment. If you remember, we discussed about instant types in parameters, right? The default instance type is T2 small, but these are also allowed to run. Alright, parameter section is the one that was used to receive information from us, like the DB name, the DB password, the DB root password, DB user instance type, key name, and the SSH locations. Alright, now this resource section is showing us the resource that it actually created. Right, looks like it's rolling back. Why would that be? Give me a moment. Alright, this is one live example. Anytime it could not provision, or if there is an interruption that it could not proceed, it would simply roll back and delete all the resources that it had provisioned, and that's what it did. Now let me fix this. Alright, as a fix, I have switched the region because I had some issue with the VPC. That's going to take time for me to analyze and fix it. So here we're going to understand about CloudFormation. So I thought I'll run the CloudFormation from another VPC that I know is working fine. That's in North Virginia. All right, let's provision a LAMP server which is running out of Linux, which has Apache installed in it, which has PHP and MySQL already installed in it. So one server going to act as web and DB server. All right, so I'm going to create a stack, and from here I'm going to pick a sample stack. If we look at it in the designer, it's going to provision one LAMP server and a security group attached to it. There you go. Right, so let's go ahead and create a stack. All right, parameters are used to receive input from us. What could be the DB password and the DB user, and let's select the key name. Right, I'm going to keep the rest as defaults, and I'm going to create a stack. All right, so our stack that we ran from the template, at the moment it's getting created, it's in progress. From here I can watch the events as to what is getting created at the moment. Like I said, a lot of these would have already sorted out their dependencies, which one needs to get created first, which one needs to get created second. All that is sorted out by CloudFormation itself. And parameters are the values that we have inputted, and resource tab is a section where we can find what resources are being provisioned at the moment. So to begin with, it created a security group. At the moment it's creating an instance, and output, it's empty as of now. We're going to come back and see it. Now output is where we can get outputs of a finished job. Let's say here I wanted an URL of the server that got created. So instead of me going to a couple of other places within the console and find the output of the URL or the output of the resource that was created, I can simply get it from here. Well, this needs to be defined in the templates first. Once we define it in the template, it's going to be made available like here. Right, so I can open it up, and so there you go. So it already has a database locally installed, and it's connected to it. If I launch an application on top of it, that will get connected to the database, which is very local, and my single server with web and database in it is ready for production. Now, while we're talking about a LAMP server, a single LAMP server, let's talk about creating an environment like this, which has Elastic Load Balancer, a VPC, a server running in an auto-scaling group, and putting some restrictions that nobody will be able to access the EC2 instance directly, but they should be able to access the EC2 instance or the data only through the Elastic Load Balancer. This is a bit complicated than the environment that we've already created. Let's see how this is done. All right, in this lab, we're going to create Elastic Load Balanced Autoscaling group, which is going to create a load balancer and an autoscaling group, and that autoscaling group receives traffic only from the load balancer. So here's the template, and here's the architecture that we're going to provision. Let me call it right, and the key pair it's going to use is Simplilearn key pair. Now this is where the problem was. Now we were selecting few subnets. So now if I provision it, now this is going to take its short time to provision the resources. So through parameters we can see the values that we have inputted, and the events look good. No rollback, no deletes, and the resource section shows the resource that it is creating. So previously it created a target group, now it's creating the application load balancer itself. All right, so it created a load balancer, and then it created a security group. It created a launch configuration. At the moment it's creating a web server group. And the events look good with all green and yellow. Green ones are completed, yellow ones are in progress. We don't have any red delete or rollback errors, so it looks good. Alright, it took a while, and the resources have been created. Some of them show that they are in progress, but the status of the stack is complete. All resources have been created, and we do have an output to access the URL. There you go. And remember, there was another feature of the CloudFormation that was it should restrict access, direct access to EC2 instance. Let's see if that has been done. If I try to access using the load balancer, it lets me access. But if I try to access it using the EC2 instance IP or the DNS name, my connection won't go through because it's blocked through the security group. But direct access through the load balancer is allowed, and that's what we wanted to achieve through that template.
Also, if you want to master the field of cloud computing, the postgraduate program in cloud computing, designed in collaboration with Caltech CTME, helps you become an Azure, AWS, and GCP expert. This in-depth cloud computing certification course lets you master key architectural principles and develop the skills needed to become a cloud expert. Benefits of this postgraduate program includes Caltech CTME Postgraduate Certificate, enrollment in Simplilearn's JobAssist. You will receive up to 30 CEUs from Caltech CTME. You will attend masterclasses from Caltech CTME instructors, live virtual classes led by industry experts, hands-on projects and integrated labs, online convocation by Caltech CTME Program Director, 40+ hands-on projects and integrated labs, capstone project in 4 different domains, and Caltech CTME Circle membership. You can also fast-track your career with this cloud computing certification and its in-depth course curriculum, which covers the key concepts of Microsoft Azure, Amazon Web Services, and Google Cloud Platforms, and services such as AWS Lambda, Amazon S3, Azure App Services, and many more. So this program also covers the essential skills to become an expert in cloud computing, and you can consider this program because it provides you with a certification from Caltech CTME, a well-reputed university in the United States. So what are you waiting for? Check out the link mentioned in the description box below and start your cloud computing career today. So without any further delay, let's get started.
Here in this section, we're going to talk about what is security in AWS, and then we're going to slowly or gradually move on to the other topics like types of security available in AWS. Out of all the services, why IAM is the most preferred one, and then we're going to talk about what is IAM in general, how it works, the building blocks or components in IAM, and the features, the attractive features that it provides that makes IAM stand out from the rest of the services available. We're going to talk about that, and then we're going to end today's session with a demo about how IAM gets well interacted with other services in Amazon and help create a secure environment in the cloud. Let's talk about AWS security. Now, cloud security is the highest priority in AWS. And when we host our environment in the cloud, we can be rest assured that we are hosting our environment in a data center or in a network architecture that's really built to meet the requirement of the most security sensitive organization. And this high level of security is available to us on a pay-as-you-go type, meaning there is really no upfront cost that we need to pay. And the cost for using the service is a lot cheaper than what it is in an on-premises environment. So AWS Cloud provides a secure virtual platform where we can deploy our application. Now, compared to the on-premises, with AWS, the security level is very high and the cost involved in using or attaching that type of security to our application is very low compared to on-premises. There's really no upfront cost, and the cost is very lower. Whatever cost that we pay is very lower than what it would be in on-premises. And all this contributes to the secure environment we can get through IAM in AWS Cloud. There are really many types of security services available in AWS. To name a few, or to name the familiar ones, IAM stands first, followed by Key Management System, KMS, and then we have Cognito, that's another service, and Web Access Firewall, WAF, is another security service in AWS. Now let's start our discussion by talking about IAM, and that's what this whole series is about. Now, IAM, or Identity and Access Management, it really enables us to manage access to AWS services and AWS resources in a very secure manner. With IAM, we can create groups. We can actually allow those users or groups to access some service, or we can sort of deny them to access the service, whichever we want. That's all possible through identity and access management. And this feature comes with no additional charge. Now let's talk about how things were before AWS. Before AWS, or before IAM in general, it was not that safe in a corporate to share the password over the phone or through the email. That was the practice that was existed at that time. Now, we all can remember the days when we need to switch to a different account, or we had just one admin password commonly stored in a location, or one person would reset it and maintain it, and anytime we need to log in, we call the person, ask for the admin password over the phone, and then we try logging in. Now, that was not secure at all back then. Somebody could walk by and sort of eavesdrop, get the password. Now they walk away with the password with them. So they're all possible when we share the password over the phone and through the internet or email. Now with AWS, a lot of options are available that I'm not sharing password over the unsecure medium. Now Slack is a third-party product available with AWS. It's not an AWS product, but Slack is a third-party application that's hosted on AWS. And it's really a communication tool that helps people to share documents. So now we're not sharing the password over the phone, rather through the applications, and no eavesdrop person can really catch the password and try it in their system to access our environment. That's not possible. So you see the difference now. Back then, sharing password was only through phone and email, and you would write it on a paper and you give it to somebody. But now technology is providing provisions enough for us to share the password in a secure way. We're still talking about IAM. IAM is an web service for securely controlling access to the AWS resource. Now it really helps us to authenticate or sort of limit access to a certain set of users accessing the AWS account, or certain set of users accessing a certain set of resources in AWS account. Now you see this picture, we have an IAM administrator who's trying to allocate permissions to different group of people. So we have group 1 on the top and group 2 in the middle and group 3 towards the end. The administrator using IAM, or IAM empowers the administrator, allow access to certain group to certain resources. That's what IAM is all about. Now let's talk about the building blocks, or let's talk about the elements that make and complete IAM. So the elements are categorized into 6 different elements. We have the principal in IAM, the authentication, the request, the actual request coming in, the authorization, allowing, denying access, actions, what are the scope of actions can be taken, and on what resource. Is it EC2, is it RDS, is it S3 bucket? So what resource these actions are applied to. So they are the basic elements of an IAM workflow. Let's talk about principal, for example. An action on AWS resource can only be performed by a principal. An individual user, they can be a principal. A role in AWS IAM, it can be a principal as well. In other words, a principal is an entity that can take an action on an AWS resource. A principal can be an user, a principal can be a role, a principal can be an application that's trying to access the AWS environment. Secondly, authentication. Now, authentication is a process of confirming the identity of the principal trying to access the AWS environment. Now, how do we get authenticated, or how does a user get authenticated? By providing credentials or the required keys to validate that this is what he or she is as per what's in the record. So all principal must be authenticated, and we get authenticated using the username and password to log into the console. If it is CLI, or we get authenticated using the access key and the secret access key. The other component that makes up IAM is request. When a principal tries to use the AWS Management Console, what the principal is doing, or what the user is doing, is sending a request to the AWS environment. And the request will have the principal actually wants to perform. Is it a put request, or is it a get request, or is it a delete request, stuff like that. And it's also going to carry information about on which resource the action needs to be done. Is it on EC2.1? Is it on S3 bucket Simplilearn.com? Stuff like that. So it has a specific action that it wants to perform and the resource on which it wants to perform, and also some information about from where the request is originating from. Is it within an AWS environment, or is it with another cloud service provider, or is it with on-premises, stuff like that. So these information will be present in the request. Authorization. Now this IAM uses information from the request context to check for matching policies, and it takes a decision whether to allow or to deny the request. Now here it has a logic. By default, all the resources are denied, and IAM authorizes your request only if every part of the request is allowed by a matching policy. So there is an evaluation logic that says by default all requests are denied, and if there is an explicit allow, then it overrides the default deny. And if you are explicitly denying a service, then all the allow statements gets overridden, and all the other statements gets overwritten, and this explicit deny stands. By default, only the AWS account root user has access to all the resources in that account. So if you're not signed in as a root user, then we must be specifically granted permission through a policy. In other words, we need to be authorized through the policy. Now let's talk about action. Now after authenticating and authorizing the request, AWS approves the action that we are about to take. Now using action, we can view the content, we can create a content, or create a bucket, or create an EC2 instance. I can edit content, or even I can delete a resource. That's all based on the action that I'm allowed to do. Now that was about actions. Now where is the action performed? The action is performed on the resources. A set of actions can be performed on a resource, and anything that's not mentioned in the action, or anything that's not tagged with the action and the resource, they don't get to complete. For example, let's say if you attempt to delete an IAM role, and you also request to access the EC2 instance for that role, then the request gets denied. Now let's talk about some of the other components of IAM. So the other components of IAM are the basic building block is an user, and then many users together, they form a group, and then policies are the engines that allows or denies a connection. Based on policy, one gets to access or gets no access to a resource. And then roles are another component. Roles are temporary credentials, I would say, that can get assumed to an instance as and when needed. Right, let's talk about this component called user in an IAM.
With IAM, we can securely manage access to AWS services, and we can create an IAM user anytime there is a new employee joining our corporate. So it's a one-to-one mapping. One user or one employee gets a username directly attached to them. And a username or a user is an account specific thing. It's very local to that AWS account that we are using. So in detail, an IAM user is an entity that we create in an AWS environment to represent a person or a service that interacts with AWS environment. And this user is going to have some credentials attached to them. And by default, they do not have a password, and they do not have any access key or secret access key attached to them. In fact, literally no credentials of any kind. Now we must create an user, and we must create the type of credential that gets attached to the user. Do they want to access CLI? So based on that, we would be adding credentials to them. A user by default is not authorized to perform any action in AWS. And the advantage of having one-to-one user is that we can assign permissions individually to that user. For example, we might want to assign administrative permissions to few users who can administer our AWS environment, and users are entity within an AWS account. Users don't have to pay separately. They start using the servers, and that get bills under the account they are attached to. So separate users doesn't mean that separate payment for those users. They are just users in our account, and the whole account gets to pay for the resources that they provision. Again, the IAM user does not always represent a person. An IAM user is really just an identity with associated credential and permissions attached to it. It could be an actual person who is a user, and it could be an application also who is a user. Next, we'll talk about groups. Talking about groups or understanding group is very easy. A collection of user forms an IAM group, and we can use IAM group to specify permission for multiple users, so that any permission that's applied to the group is also applied to the users who are add to that group. Now, there are a few things you might want to know about group. A group can have many users, and a user, they can belong to many groups, but groups can't be nested, meaning group can only have users. A group cannot have a group inside a group. That's not possible. And there's nothing called a default group that sort of automatically includes all users in the AWS account. If you want to have a group, then we will have to create a group. Now let's take this diagram for example. Now this is a diagram of a small company. Now the company owner creates an admin group for users to create and manage other users as the company expands every day. And the admin group creates a developer group and a test group. Each of these groups consists of users who are people, users who are applications that interact with AWS environment. So the different types of users we have are Jim is a user, Brad is a user, and Dev App 1 is a user, and so on. So each users have an individual set of security credential. Like I said, it's 1-to-1. And the 10 users that we see on screen are shared between, or they belong to multiple groups in the account. And managing group is quite easy. We set permission to the group, and that permission gets applied to all the users automatically in the group. And after we applied the policy, if I add another user to the group, the new user will automatically inherit all the policies, all the permissions that's already mentioned in that group. So administrative burden is sort of taken away. Administrative burden about user privilege or user permission management is sort of taken out with IAM. Alright, the next thing we will want to discuss is policy. A policy sets permission and controls the access to AWS resource. And the policies, these permissions and controls are stored in JSON format. A policy is a very clear document. It defines who has access to a resource and what are all the actions they can perform. So in other words, policy is an entity in AWS that when a policy gets attached to an identity or a resource, it really defines the permission, what they can and cannot do. And AWS, it evaluates these policies when a principal, such as a user, makes an request. And the permission statement in the policy, it really defines whether the user is allowed to access a service or is he denied to access a service. Alright, let's take this example. Now we have a task. The task is to give Paul, who is a developer, access to Amazon S3 environment. And what you're looking at is a snippet of what a policy would look like. So these are some questions we will have to answer, or these are some questions the policy tries to answer, and once it found an answer, then it becomes a complete policy. So who wants access to the service? It's Paul who wants access to the service. And what action do Paul want? Now Paul wants to download, or Paul wants to upload objects in S3. In JSON language, it's otherwise called Paul wants to get information, Paul wants to put information. Otherwise, Paul wants to get object, Paul wants to put object in S3. And which resource does he want? Now, in this case, every bucket. The star symbol represents all buckets in S3. So, which resource? It's all bucket in S3. So, we can start reading already from the data present here. So, who wants access? Paul wants access. What action does he want? He wants to get, he wants to put. And what's the resource that he's trying to access, or you want to give him access? It's all the bucket in AWS. And when does he want? These are additional statement that goes in a policy. So since when does he want that access? He wants access till March 2nd, 2019. So all this who, all this action, all this resource, till the time all this gets allowed. So this is the statement that really defines. Now, does this all refer to an allow statement, or does this all refer to a deny statement? If we had deny here, it's the direct opposite of what we discussed, but we have allow. That means Paul is allowed to get and put access in an S3 bucket, and all the buckets in S3 till March 2nd, 2019, he's allowed to access the resources. So if we put all the information that we have gathered, or all the answers that we have so far, if we put together in a JSON format, this is how it's going to look like. So the effect is allow or deny. Here it's allowing, and the principal is any. Now who can access it? It's any. And action, it's any bucket in S3. Any action in S3, put get request, and the resource is any bucket in S3. So that's how a basic policy would look like, or that's how a basic policy is formed, by answering those basic questions. So let's talk about the types of policies. So we have two broad categories: managed policy and inline policy. Now, managed policy, it's the default policy that we attach to multiple entries, be it users, be it groups, and be it roles in our AWS account. On the other hand, inline policy are the policies that we create and manage them. And these policies are embedded directly into a single user, group, or a role. So if I need to brief it a little bit more, then managed policies are standalone identity-based policies that we can attach to multiple users, groups, and roles in our AWS account. We can use two types of managed policies. In other words, managed policies, they themselves have two categories. One is AWS managed policies, which is created and managed by AWS. And the other one is customer managed policies. Just like the name says, it's managed by the customer. Now we can create and edit an IAM policy in Visual Editor, or simply create a JSON policy document directly and upload it in the console and start using them. So that's managed policy. On the other hand, inline policies are policies that we create and manage, and that are embedded directly into a single user, group, or role. Let's talk about this next component called role. Now this role is very similar to everything that we discussed so far. It's a set of permission that defines what actions are allowed and denied by an entity in an AWS console. The role is very similar to an user. I said very similar. I didn't say it's the same as the user, but I said it's very similar to the user. And the difference is that user is hard-coded. User permissions are hard-coded. But the role permissions are accessed by any entity, be it a user or be it an AWS service, and moreover, the role permissions are temporary. On the other hand, user permissions are permanent and the role permissions are temporary. So in detail, a role is very similar to a user in that it's an AWS entity with permission policies that determines what the identity can and cannot do in AWS. Now, instead of it being uniquely associated with one person, a role is intended to be assumable by anyone who needs it. Roles generally do not have a long-term credential, password or access keys associated with it. It does not have long-term credentials. It only has temporary credentials. created dynamically and provided to the user as and when the user assumes a role and wants to access any service. Roles can be assumed by users, roles can be assumed by applications, roles can be assumed by services that normally don't have access to AWS resources. For example, you might want to grant a user in your AWS account access to your resource that they do not normally have, or grant users in one AWS account access to resource in another AWS account. Now this is something that we don't have by default, and this is something we may not need all the time. Or you might want to allow a mobile app to use AWS resource, but you do not want to save the key or save the credential or save the passwords in the mobile app. Or sometimes you might want to give access to resources who already have identities defined outside of AWS, like a user who's already an Google or Facebook authenticator. If you want to give them some service, or if you want to let them to access some of the resources in your account, we can use roles for that purpose. Or you also might want to grant access to your account to a third party, a consultant or an auditor, so they can for some time get some temporary access to audit our AWS resources. Remember, they're not permanent users, just temporary users. They want some temporary access to our environment till the audit is over. So for those cases, roles are a very good use case. So let's take this example. Let's see where role sits, and let's see how roles give permission to other services. So here is a scenario where an EC2 instance wants access to an S3 bucket. By default, though both of them were created by the same username or the same admin, they do not have access by default. So by default, they don't have access. And I also do not want to give permanent access, one-on-one hard-coded permanent access. Instead, I would like to create and share access. So that's possible through roles. So coming back to the discussion, the scenario here is that an EC2 instance wants to access data in an S3 bucket. So the first thing is to create a role or a permission. We saw how that's done, right? Using policies. Roles use policies. Policy is the actual working engine for any permission related actions, right? So create a role with an appropriate policy that gives access to S3's bucket, and then launch an EC2 instance with the role attached to it. We said roles are assumed by any entity, right? It could be user, it could be an application, it could be a service, it could be another resource in AWS account. So here it's another resource in AWS account, right? So we create a role and we attach it to an EC2 instance. So now the EC2 instance can assume the role. Now the same role can be attached to another EC2 instance. The same role can be attached to another user. The same role can be attached to another database service. We get the idea, right? Roles can be assumed by anyone. So when the EC2 instance wants to communicate with S3, it contacts the role, and then the role gives this EC2 instance some temporary username and password that expires after 1 hour, let's say. So it's a temporary username and password. Now with that temporary username and password, the EC2 instance can access the S3 bucket and access the file with the credential that it already has. And that credential is a temporary one. And the credential will expire after 1 hour, or how much ever time the admin sets it to be. And then the next time when an EC2 instance wants to contact S3, it will have to contact the role, and the role will propose a new access key and secret access key. In other words, a new credential. With that new credential, the second time the EC2 instance will be able to contact the S3 bucket and get the information. So the password is not a permanent or a one-time or a hard-coded password. It keeps rotating. It's a token. It's a secure token that an EC2 instance or any application that uses the role gets to access the resources on the other end. Well, let's talk about the features of IAM. The main feature of IAM is that I can create separate username and password for individual users or resources, and I can delegate access. Now, those days where we had just one username and password for admin and we need to call the other person to get the username and password over the phone, if it gets compromised, the whole account gets compromised, stuff like that, those issues are gone. I can create separate username and password for all 1000 users in my account. No more username and password sharing. I can manage access to all those 1000 accounts in a very simple and an easy way. So IAM provides shared access for all the 1,000 users in my account. It provides shared access to the AWS environment. And the permissions that can be given through IAM are very granular. Now we saw how restrictions can be put on GET requests. We can allow a user to download information and not update an information. So that's possible through the IAM policies that we looked at some time back. And with the use of roles, we're authenticating an EC2 instance instead of the application running on top of it. So if there are like 10 or 20 applications running on top of an EC2 instance, instead of creating a separate username and password for all those 20 instances, I can create a role and assign that role to the EC2 instance, and all the applications running on the EC2 instance get a secure access to the other resources, use the role credential that's provided to that EC2 instance. Now, besides username and password, IAM also supports multi-factor authentication, where we provide our credential, the username and password, plus an OTP from our phone or an randomly generated number that gets displayed in our phone before Amazon console or before Amazon CLI would authenticate and lets us access some of the service in the account. So it's called multi-factor authentication. It's username and password plus something else from what you have. IAM also provides identity federation. If a user is already authenticated with a corporate AD or Facebook or Google, IAM can be made to trust that authentication method and then allow access based on that authentication. Now, without federation, what would happen is the users will have to remember two passwords, one for on-premises and one for cloud. Anytime they work on on-premises, they'll have to use one set of password, and anytime they switch to the cloud, which is going to be very frequent in every day. So anytime they switch to the cloud, they will have to again type in the cloud username and password. Now, with identity federation, we can sort of federate, or we can connect both the authentication systems, both on-premises and IAM. So users can just use one username and password for both on-premises and cloud environments. And all that we saw so far, it's free to use. There is no additional charge for IAM security. There is no additional charge for creating additional users, groups, or policies. It's a free service, comes along with any account. IAM is an PCI DSS compliant product. IAM comes with password policy where we can reset the password remotely or rotate the passwords remotely. And we can set rules like how a user should pick and password. It should not be the one that was used in the past, any of the past 3 times, stuff like that. So you get the idea, right? How the features of IAM help us to build an secure authentication and authorization system in or for our AWS account. All right, it's time to do a quick lab. Let's put all the knowledge that we have earned so far together and apply it and try a lab and solve the problem. So here's a problem statement. We need to create an S3 bucket for a company where users can read or write the data only if they are multi-factor authenticated. So there could be like 20 users in an account, but a user is allowed to read or write a data in an S3 bucket only if the user is multi-factor authenticated. This is a very good use case if we have sensitive data in an S3 bucket and you only want privileged or MFA authenticated users to do changes to those buckets. And for those privileged users, you would enable multi-factor authentication. So let's see how that's done. Before that, let me talk to you a bit more about multi-factor authentication. Now, multi-factor authentication is that additional level of security process. It's provided by AWS. Here, the user's identity is confirmed only after the user proposes or the user passes 2 levels of verification. Now, one being the username and password and another being an OTP that gets generated. In this case, it's the mobile phone. It could also be an RSA token key that generates the one-time password. That's possible as well. But in this case, it's the mobile phone. Now, that's going to be very similar to how we log in to our Gmail account sometimes. When we log into a Gmail account and if you have the proper setting enabled, it's going to send an one-time password to the mobile phone, and only after we put that information, it's going to let us log in. Let's see how all this is done in an AWS account. So the first thing is to log in to the AWS account, create a user, and attach the user to the virtual MFA device. Now we're going to use Google Authenticator here, and we're going to attach the user to Google Authenticator and make the user use the Google Authenticator one-time password every time he logs in to the account. Now this is in addition to the username and password that he or she already has, right? So the first thing is to log into the account, connect or sync the virtual appliance with the AWS username and password. Now when we sync, there will be an one-time password that gets shown in the phone. Type in the password in the AWS console, and then the phone and the username comes to sync. And from that point onwards, the user, anytime they log in, they will have to propose their username and password, which is the first step of security. And then once they typed in the username and password, type in the MFA code that gets generated on the phone. That would be the second step of security, or the last step of security. Once that is done, the account is going to let them log in and access the AWS resources. Alright, so in order to test IAM, MFA, S3 together, this is what we're going to do. So we're going to create a bucket, and we're going to have two users, and we're going to allow or deny access to the S3 bucket to those two users based on whether they are MFA authenticated or not. And on purpose, we're going to assign MFA to one user and no MFA to the other user. Like you might have guessed by now, the user with MFA will have access to the bucket, and the user with no MFA attached will not have access to the bucket. Both of them are going to have full S3 services, but MFA, like I said, is one layer above the other permissions. MFA stands at all time. So irrespective of whether the underlying policy says but they have full access to the S3 bucket, they're not going to, because MFA stands on top of it. Let's see how that's done. To begin with, firstly, we need a bucket. So let's create a bucket. So I'm in my AWS console. So let me go to S3. And in here, create a bucket. Call that bucket as Simplilearn MFA bucket. And let me put it in North Virginia and create. Alright, so that's done. Now I'm going to put a separate folder in here. I'm going to create another folder in here, and the name of the folder is tax documents. Now this is where I'm planning to keep my tax files, and I only want my privileged users to be able to upload and download information from the tax document. So on the bucket side, it's partially done, or on the S3 side, it's partially done. So let's go back to IAM, and here we're going to create two users, one a junior employee and another one an senior employee. The senior employee is the one who's going to have MFA access and more access to the S3 bucket, and the junior employee is the one who's not going to have access to that particular bucket. So let's get started. Let's create an user under IAM. Click on users, and let's create a user. Call this user junior right. So he's a junior user, and for the password, set a password. The user does not need to create a new password at sign in, because it's a test environment, and the user who creates the username and the user are the same person. So let's keep it simple. Username, password, management console access, and this user is going to have full S3 bucket access. All right, this is really the policy. We should be familiar with this JSR document by now. It says effect is allow, and what action? Any action in S3, and what resource? Anybody who's attached to it. Review and create a user. So this user is having S3 full access. Now let's create another user, call them as senior employee. All right, attach a policy to the user. From the surface level, both of them have the same permissions. Both of them have S3 full access. All right, so both of them have S3 full access, as we see. There's one thing different we're going to do to this senior employee. Now we're going to attach MFA to this employee. So the way we would do it is under the summary section of that particular user, click on security credential and see here is a place we can attach an MFA to this user. So let's attach MFA to this user. For MFA, I can use both virtual MFA or hardware MFA. This being a lab environment, we're going to use virtual MFA. Now, that is an application. There are a lot of applications available, but there is one application that I'm using at the moment called Google Authenticator. So once we have installed the application, and once it is running, so I can go to virtual MFA device, and once it is running, I can scan the code using the Google Authenticator in my mobile phone. Once you turn on the application and once you do scan the barcode that is showing right here, now that's going to give us codes that we can use. And we will have to put in those codes here twice. We'll have to wait for some time and it would generate a second set of key that we can put. So my first set of key is 402351. Right, I'll have to wait for some time. And then it would throw me a second set of key. It's like validating twice right here. So let me put in my second set of key. So this user is now MFA authenticated user. So anytime this user logs in, it's going to ask for MFA. Anytime this user proposes something, it's going to attach the MFA key along with it. Alright, so we're done with the IAM. What have we done with IAM? We have created two users. Both of them have S3 full access, but one of them have MFA access and the other one does not have MFA access. And based on whether the user is having MFA or not, we're identifying privileged users by this MFA. Alright, so based on whether the user has MFA or not, we're going to allow deny access in the S3 bucket. So we already have a bucket, we already have a folder, and this is a very privileged folder path. Here I would like to restrict access based on whether the user is having MFA or not. So let me create a bucket policy here. Now here's a policy that I have written. The policy says that, under tax document folder, give access only if the user is MFA authenticated, right? If the user is not MFA authenticated, simply deny the access to that user. So as you might guess right now, the user 1 will not have access, or the junior employee will not have access because it's a privilege, and junior employee might tend to delete them unknowingly, and only privileged users get access to the tax document because it's confidential, because it's privileged, because if it gets deleted, we won't be able to get it back for those reasons, right? So apply the bucket policy. Now try logging in as the different users and see how the permissions are applied on both the users. All right, so let's make a note of the IAM URL. And then the two usernames and password. Let's log in. So let me log in as the privileged user. Sure enough, I'm being asked for an MFA code. Let me put my MFA code. So let's directly navigate to the S3 bucket. Right, here's my privileged path. Let me try uploading some content. Claim forms. Sure enough, I'm able to upload content into it. Will I be able to delete? Yes, I'm able to delete as well. Now let's see what's the situation for the other user. So let's log in as the other user. Navigate to the S3 bucket. If you noticed, when logging in, it did not ask for an MFA code because the user is not set up for MFA. So navigate to the folder which we want to test. Now try adding some files. As you see, it's failing to add content to this bucket. It shows error because the bucket policy is requiring MFA and this user is not MFA, and we did that in IAM or under IAM. But still, as you see, they will be able to view the content in the bucket. They can do all that. We have specifically restricted access to upload and download content from the bucket, and that's exactly this user is now denied with.
So what are we going to learn? We're going to learn about what is cloud storage in general, and then the types of storage available in general in the cloud, and how things were before anybody adopted using S3. That's something we're going to learn. And then we're going to immediately dive into what is S3 and then the benefits of using S3 over other storage. And then we're going to do a couple of labs or console walkthroughs about what is object and how to add an object, what is bucket, how to create a bucket, stuff like that. And then we're going to talk about how Amazon S3 generally works. Now, it comes with a lot of features, it comes with a lot of promise. How does this all work? How does Amazon able to keep up with the promise? We're going to talk about that. And then we will talk about some features, add-on features that comes along with Amazon S3. So what is cloud storage in general? Cloud storage is a service that provides web services where we can store our data. And not only that, the data can be easily accessed and the data can be easily backed up, everything over the internet. In short, if you could store your data, if you could access the data, if you could back up your data, everything you do through the internet, then that's a good definition for cloud storage. And additional definitions are, in cloud storage we only pay for what we use. No commitment, no pre-provisioning, is pay as you go type subscription. And the best part is we pay on a monthly basis. We don't rent a hardware for the year, or we don't give commitment for the whole year. It's pay as you go and pay on a monthly basis. And these cloud storages are very reliable, meaning once you put the data in it, it's never going to get lost. And these cloud storages are scalable. Assuming I have a requirement to store 100 times of what my actual data size is and I want it now, it's available in the cloud. And these storages are secure as well, because we're talking about data virginity. They need to be secure, and Amazon provides tools and technologies through which we can secure our data, and these are generally not found in the on-premises storage system. So let's talk about the different types of storage in general. So S3 is cloud storage in AWS, and then we have Elastic Block Store. Now, Elastic Block Store is actually the SSD hard drives that gets attached to our EC2 instance. It's like the C drive, it's like the D drive, it's like the E drive that gets attached to our instances. Now, EFS is Elastic File System. The underlying technology is kind of the same, but it differs from EBS in a way that EBS can be accessed only by the system that's attached to it, meaning the E volumes and the D volumes we spoke about. They can be accessed only if there is an instance connected to it. But these EFS are actually shared file systems, Elastic File System. Alright, they are shared systems. They can be accessed by multiple systems. They can be accessed from inside the Amazon environment. It can be accessed from on-premises equipment as well. Glacier is actually the archiving solution in the cloud. If you want to dump a data and try to keep them in the low cost as possible, then Glacier is the product we should be using. And then we have Storage Gateway. If I want to safely move my data from my local environment to the cloud environment and also want to keep a copy of the data locally, so users locally can access them, and cloud users or internet users can access the data from the cloud. If that's your requirement, then storage gateway is the one we would be choosing. And then we have Snowball. Snowball is really an data import and export system, but it is actually an hardware that gets shipped to our premises, where we can copy a data into it and then ship it back to Amazon, and Amazon would copy the data into whatever destination we give them in our account. And if the data is really huge, then I can call for a snowmobile, which is actually a data center on a truck, where Amazon would send me a truck loaded with a data center, as you see, that has compute capacity, lots and lots of storage capacity, and electricity, AC, and a lot more. So they get come parked near our data center, and cables run into our data center. We can copy data into it, send it back to Amazon, and they would copy it to our account in whatever storage that we advise them. So if the data is really huge, then I would be calling Snowmobile. Snowmobile is not available in all the regions. Alright, let's take this example, how things were before S3 was introduced. Two professionals are having a conversation, and one of them is finding it very difficult to sort of manage all the data in the organization. Well, if the data is small, it can be easily managed, but as company grow, and we are living in an era where data is everything. We want data to back up every idea. We want data to back up every proof of concept that we provide. So data is everything. So this era, it's all about collecting data, analyzing them, and saving, not losing logs, saving them, analyzing, stuff like that. So coming back to our discussion, here one person finds it very difficult to store and manage all the data that they have. So some of the data that this person is having problem storing is data that application use to running, and then data that get sent to the customers, and data that the websites require, the data that are because of the email backups, and a lot more other storages that an enterprise can have. And this person is having problem backing up all those data. And even if we think of increasing the local storage capacity, that's going to cost a fortune. And few things that make it sometimes impossible to increase the storage capacity in-house is we will have to go and pay heavy to buy hardware and software to run these storages, and we need to hire a team of experts for maintaining them, the hardware and the software. And anytime if there is a dynamic increase in the storage capacity, the on-premises or in-house hardwares won't be able to scale. And data security is very costly when it comes to building our own storage environment in-house and adding data security on top of it. So the other guy in the conversation was sort of quietly listening everything the manager was saying, and then he slowly introduced him to S3, because he knew that all the problem that this manager was worried about can be solved to S3. In other words, all the scalability, all the data security, all the not being able to provision hardware and software components are all available with S3. So that actually brings us to the discussion about what S3 is. S3 is simple storage service. It actually provides an object storage service. Let me talk to you about object and block storage. Object storage is where you can store things and retrieve. Alright, you can't install anything in it, and this object storage can be accessed directly from the internet, whereas block storage is something that needs to be attached to an instance, and we can't directly access it, but we can install software in it. So that's a high level difference between object storage and block storage. And S3 is an object storage. What does that mean? We can store data from the internet, we can retrieve from the internet, but we can't install anything in S3. Alright, so S3 is an object-based storage, and it's really built for storing and recovering or retrieving any amount of data or information from anywhere in the internet. Few other things you need to know about S3 is that this S3 is accessible through the web interface. The storage, one type of accessing or one way of accessing S3 is by dragging, dropping content into it, and another way of retrieving data from S3 is go to a browser, click on download. That's going to let you download any content, and the data can be 5 terabytes in size. Now we're talking about one file. You can have hundreds or thousands of files like that. One file can be as big as 5 terabytes in size. And S3 is basically designed for developers where they can push logs into S3 or retrieve logs anytime they want instead of storing locally in the server. They can use S3 as code repositories, where they can save the code and have the applications read the code from there, and a lot more. If they want to safely share the code with another person with a lot of encryption and security added on top of it, that's possible as well. So there are a few things about S3, and on top of all this, S3 provides 11.9 durability and 4.9 availability. Meaning durability is, if I store the data, will it get lost? Amazon is like, no, it's not going to get lost. You're going to have the data because we provide 11.9 durability for the data. And availability is, if you want the data now, will you be able to show it? Amazon is like, yes, we will be able to show it. We have 99.99% availability, and when you request the data, we will be able to show the data to you. Alright, so let's talk about the benefits of S3. S3 is durable. As we saw, it provides 11.9 durability. S3 is low cost. Out of all the storage options in Amazon, S3 is the cheapest, and S3 is very scalable. Like we were saying, there's no required to pre-provision a storage capacity. If you need more, go ahead and use more. If you need even more, go ahead and use even more. And once you're done, some data needs to be removed, just remove the data. So that particular month you will be paying less. So it's very scalable in nature, and it's very available as well. S3 isn't regional service. It's not based on one availability zone. So one availability zone going down within Amazon, the whole availability going down, it's not going to affect your ability to access S3 storage. And S3 is secure. A lot of security features like bucket policy, a lot of security features like encryption, and then MFA authentication are possible with S3 that actually adds a very good security layer on top of the data that we have stored in S3. And not only that, this S3 is very flexible in terms of cost, flexible in terms of where I want to store the data. In terms of cost, there are a lot of pricing tiers within S3. S3 itself is a cheap service. Now within that, we have a lot of pricing tiers depending on the durability. So I can always choose to put data on a different storage tier or storage option in S3. We're going to talk about it as you stick along. And in terms of flexibility in region, I can always choose any of the region available in the console or in the S3 console to put my data to. There is no restrictions on where I can or cannot put the data in the cloud, as long as there are regions available for me to move the data to. And data transferring with S3 is very simple. All I have to do is browse to the bucket, upload the data, and the data gets uploaded. And we can also upload data using CLI. Commands are very similar to Linux. Commands are very similar to what we would use in the run command prompt in Windows, and what we would use in the run command prompt in the PowerShell. Alright, let's talk about a basic building block of S3, which is bucket and objects. Now what's a bucket? What's an object? Object is the actual data, and bucket is the folder where the objects get stored. Let me give you a new definition for object. So object is the actual data plus some information that reference the data, like is it an JPEG file, the name of the file, and at what time it was added to. So they're called metadata. Alright, so object is actually data plus metadata, and bucket is actually a container that receives the data and safely stores in it. And when we add a data in a bucket, Amazon S3 creates an unique version ID and allocates it to the object so we can easily identify it at a later point. Let me show you a quick lab on S3. Alright, I'm in the S3 console. If you're wondering how I reached here, go to services under storage and S3 is right here. And let's create a bucket called Simplilearn. Now the bucket names will have to be unique. So I really doubt if Simplilearn will be available. Let's check it anyway. All right, it doesn't seem to be available. So let me pick another name, or let's call it simplylearn.samuel.com. And I'm going to put this in Mumbai, or I can choose Oregon. Let me choose Oregon. Yes, let me choose Oregon. And let me create a bucket. Sure enough, a bucket got created. Let me upload an object into the bucket. And you know, these objects can be as big as 5 terabytes. We talked about it, right? All right, let me upload an object. All right, so that's my object. So you get the relation, right? Here's my bucket. All right, here's my bucket, and within that is my object. Now object is the actual file plus what type of file it is, and then the size of the file, the date in which it got added, and the storage class it is in at the moment. So if I have to access it, I can simply access it through the internet. So let's talk about how does this S3 bucket work anyway. Alright, so how does it work? A user creates a bucket. They will specify the region in which the bucket should be deployed. We had an option. We could have chosen to deploy in all the regions Amazon provides S3 service. You know, be it North Virginia, be it Mumbai, be it Tokyo, be it Sydney, be it Oregon. And we chose Oregon to be the destination region where we want to create a bucket and save our data there. And when we upload data into the bucket, we can specify 3 types of storage classes. In our case, we picked the default, which was S3 standard. As we saw on the object data, it was on S3 standard. So that's the basic thing. Later, once the object gets added, we can always add bucket policies. You know, policies define who access it and who should not access it. What can they access? Are we going to allow users only to read or to write as well? Stuff like that. So that's bucket policy. We're defining the life cycle or the lifespan of the data in the S3 bucket. Now over the time, do you want the data to automatically move to a different storage tier? And at any point, do you want to sort of expire the data, you know, get the data flushed out of your account automatically? You know, those things can be configured in lifecycle policies. And version control is creating multiple versions. If you're going to use S3 for a code repository, creating multiple versions. Let's say if you want to roll back to whatever you had before a month, how are we going to do it if you kept updating the file and never took a version of it? So version control helps us to keep different versions, and it helps us to roll back to the older version anytime there is a need. So let's talk about the different storage classes in S3. The different storage classes in S3 begins with S3 standard. Now this is the default, and it's very suitable for use cases where you need less or low latency. For example, if you want to access the data of a student's attendance, you would retrieve them very quickly as much as possible. So that's a good use case to store data in S3. Let's understand the different storage classes in Amazon S3. Now let's take a school, for example, and the different data present in a school, and the features of those data, the validity of the data. Alright, so let's take this example, and there are different storage options in S3. Let's take S3 standard, for example, and what would be the actual candidate data that can be stored in S3 standard. Let's talk about that. So S3 standard in general is suitable for use cases where the latency should be very low, and in here the good example or the good candidate file that can be stored in S3 is data that needs to be frequently accessed and that needs to be retrieved quickly, something like students attendance report or students attendance sheet, which we access daily, and then it needs to be retrieved immediately as and when we need it. The other type of storage tier in S3 is infrequent access or infrequent data access. Just like the name says, the use case for that is less frequently accessed data. I mean, the candidate data that should go in infrequent access data is a student's academic record, which we don't need to access on a daily basis, but if there is a requirement, we might want to go and look at it, and that's going to be quick. So it's not a data that we would access on a daily basis, but it's a data that needs to show up on your screen real quick. And the third option is Amazon Glacier. Now, Glacier is really an archival solution in the cloud. So for archives, high performance is not a requirement. So let's talk about some candidate data that can go into archives. Something like students' admission fee, and it's not critical also. Now, anytime if you want to look at the data, you can always wait to retrieve the data. So in other words, put it in the archive, and retrieving from the archival takes time. So students' old record are a good candidate to be put in the archives. The other options are one zone IA storage class, where the data is infrequently accessed and the data is stored in a single availability zone. For example, by default, Amazon stores data in multiple availability zones, and there is a charge for that. Now, it's not an option, but the charge includes storing data in multiple availability zones. But if your data requirement is you want to keep the charges low even further, you can choose a one zone IA storage class where it stores data in one availability zone. And the candidate data that can go in one zone infrequent access is student's report card. And the other option with Amazon S3 is standard reduced redundancy storage. It is suitable for cases where the data is not critical and the data can be reproduced quickly. For example, take a copy of the library book, take a copy of the PDF library book, for example. Now, we would have a source PDF and we would make copies of it, and then we make it available for the readers to read. The other option in S3 is reduced redundancy storage. Here the use case is data that's not critical and data can be reproduced quickly. For example, books in the library are not that critical and we always have a copy of the book. We're talking about PDF. So if the customer facing or the student facing book gets deleted, I can always copy the same PDF, put it in the destination folder and make it available for the users to read. That would be a very good use case for reduced redundancy storage. Alright, let's summarize everything that we learned about different storage options in S3. So S3 standard, it's for frequently accessed data. It's the default storage. If you don't mention anything, the data gets stored in S3 standard. It can be used for cloud applications, content distribution, gaming applications, big data analytic, dynamic websites. They are a very good use case for S3 standard frequently accessed data. The other one, on the contrary, is S3 standard infrequently accessed data. Just like the name says, the use case is this is good for data that will be less frequently accessed, and then the use case are it's good for backups, it's good for disaster recovery, and it's good for lifelong storage of data. Glacier, on the other hand, is very suitable for archiving data which is infrequently accessed, and the vault lock feature is the security feature of the Glacier that also provides a long-term data storage in the cloud. This is the lowest storage tier within S3. The other options are one zone infrequent access storage class, just like the name says. It's infrequently accessed and it is stored in just one availability zone. And use cases are any data that doesn't require any high level of security can be stored here in one zone. The fifth storage tier is reduced redundancy storage. This is good for data that's frequently accessed. It's good for data that is non-critical and that can be reproduced if it gets lost. And reduced redundancy storage, or RRS, is an highly available solution designed for sharing or storing data that can be reproduced quickly. Alright, let's compare and contrast a couple of other features that are available in S3. For example, durability, availability, SSL support, first byte latency, and lifecycle management. So in standard, the durability is 11.9 durability. It's the same for standard IA, one zone IA, Glacier, except for reduced redundancy, the durability is 11.9. And availability of all the storage classes is all the same, except for one zone IA, where the availability zone is 99.5%. All of these products support SSL connection, and the first byte latency of these products are, most of them provide access with millisecond latency, except for Glacier. It provides a retrieval time of couple of minutes to a maximum of hours, and all of them can be used for a lifecycle management, moving data from one storage tier to another storage tier. That's possible with all of these storage options. Alright, now that we've understood the different types of storage options available in S3, let's talk about some of the features that are available in S3. Lifecycle management. Now, lifecycle management is a service that helps us to define a set of rules that can be applied to an object or to the bucket itself. Lifecycle is actually moving the data from one storage tier to another storage tier and finally expiring it and completing the life cycle of the object. With lifecycle management, we can manage and store our objects in a very cost-effective way. It has two features basically: transition actions and expiration actions. Let's talk about transition actions. With transition action, we can choose to move the objects or move the data from one storage class to another storage class. With lifecycle management, we can configure S3 to move our data from one storage class to another storage class at a defined time interval or at a defined schedule. Let's talk about transition actions in more detail. Let's say we have our data in S3 at the moment and we haven't used the data for quite some time, and that's how it's going to be for the rest of the time. So that data is a very good candidate to move to the infrequent access, because S3 standard is a bit costlier and S3 infrequent access is a bit cheaper than S3 standard. So the kind of usage sort of fits very well for moving that data into infrequent access. So using lifecycle transition or lifecycle management, I can move the data to S3 infrequent access after 30 days. And let's say that the data stayed in infrequent access for 30 more days, and then now I realize that nobody is looking into the data. So I can find an appropriate storage tier for that particular data again, and I can move it to that particular storage tier, which is Glacier. So in this case, after 30 days or in a total of 60 days from the time the data got created, the data can be moved to Glacier. And what does this really help us with? The lifecycle management helps us to automatically migrate our data from one storage cost to another storage cost, and by that it really helps us to save the storage cost. Lifecycle management can also help us with object expiration, meaning deleting the object or flushing it out after a certain amount of time. Let's say that our compliance requirement requires that we keep the data for 7 years, and we have like thousands and thousands of data like that. It would be humanly impossible to check all those or keep track of all the dates and when they need to be deleted, stuff like that. But with lifecycle management, it is very much possible. I can simply create a data and set up lifecycle management for the data to expire after 7 years, and exactly after 7 years the data is going to expire, meaning it's going to be deleted automatically from the account. Alright, let me show you a lab on lifecycle management and let me explain to you how it it's actually done. So I'm into the bucket that we have created, and here's our data into the bucket. Assume we have thousands and thousands of data in the bucket, and that requires to be put in a different storage tier over time, and that requires to be expired after 7 years, let's say. So the way I would create a lifecycle management is go to management from inside the bucket and click on lifecycle, and then add an lifecycle rule. Just give it a name like expire. So all the objects that's present in this bucket, meaning the current version of it, set a transition for it. So the transition is, at the moment they are in S3. So here I would like to put them in infrequent access after 30 days. And then after it's been in infrequent access for 30 days, I would like to move it to Glacier. All right, plus 30 days. So how do you read it? So for the first 30 days, it's going to be in Glacier. So how do we actually read it? So after I put the data in S3, the data is going to get moved to standard IA, and then it's going to stay in standard IA, and after 60 days from the data creation, it's going to get moved to Glacier. So on the 31st day, it's going to move to standard IA. On the 61st day, it's going to move to Glacier. Let's say if I want to sort of delete the data, if I want the data to get deleted automatically after 7 years, being in a Glacier, how do I go about doing it? Let me open up a quick calculator. 365 into 7, that's 2,555 days. Right after that, the data is gonna get deleted. Pretty much, I have created a life cycle. So after on the 31st day, it's going to get moved to infrequent access, and on the 61st day, Glacier, and after 7 years is over, any data that I put in the bucket, it's going to get deleted. Alright, let's talk about bucket policies. Bucket policies are some permission files that we can attach to a bucket that allows or denies access to the bucket based on what's mentioned in the policy. So bucket policy is really an IAM policy where you can allow and deny permission to an S3 resource. With bucket policy, we can also define security rules that apply to more than one file in a bucket. Now in this case, we can create an user, or let's say there's already a user called Simplilearn. We can allow or deny that user connection to the S3 bucket or connecting to the S3 bucket using bucket policy. And bucket policies are written in JSON script. And let's see how that's done. Alright, there are tools available for us to help us create bucket policies. What you're looking at is a tool available online that helps us to create a bucket policy. So let's use this tool to create a bucket policy. I'm going to create a deny statement. I'm going to deny all actions to the S3 bucket. And what is the ARN to which we want to attach? The ARN of the resource is actually the name of the bucket, but it really expects us to give that key in a different format. So the ARN is available right here, copy bucket ARN. So this is actually going to deny everybody. Now we wanted to deny a user, just one user. Now look at that. Now we have a policy that has been created that's denying access to the bucket, and it's denying a user called Simplilearn. Pretty much done. So I can use the policy and go over to bucket policies. So once I save it, only the user called Simplilearn won't have access to the bucket, and the rest of them will have access to it. So once I save it, it gets added, and only the user Simplilearn will not have access to the bucket because we're denying them purposefully. The other features of S3 include data protection. We can protect our data in S3 with now one of which is bucket policy. I can also use encryptions to protect my data. I can also use IAM policy to protect my data. So Amazon S3 provides a durable storage. Not only that, it also gives us a protected and scalable infrastructure needed for any of our object storage requirements. So here the data is protected by two means. One is data encryption and the other one is data versioning. Data encryption is encrypting the data so others won't get access, or even if they get access to the file, they won't be able to access the data without the encryption key. And versioning is making multiple copies of the data. So let's talk about them in detail. What's data encryption? Now, data encryption refers to protecting the data while it is being transmitted and protecting the data while it is at rest. Now, data encryption can happen in two ways. One is client encryption, encryption at rest, and server-side encryption, encryption that's in motion. Client-side encryption refers to when client sends the data, they encrypt the data and send it across to Amazon. And server-side encryption is when the data is being transferred, they get encrypted and stay encrypted throughout the transfer. Versioning is another security feature. It helps us so our unintentional edits are not actually corrupting the data. For example, let's say you edited the data and now you realize that the data is incorrect and you want to roll back. Now, how do you roll back? Without versioning, it's not possible. In other words, only with versioning, it's possible. So versioning, it can be utilized to preserve, recovery, and restore any early versions of every object that we stored in our Amazon S3 bucket. Unintentional erases or overwrites of the object can be easily regained if we have versioning enabled. And it's possible only if we have one file with the same key name, and anytime we update the file, it keeps the file name but creates a different version ID. Take this bucket and data for example. Photo.pmg is a file that was initially stored. It attached a version ID to it, and then we edited it. Let's say we added some watermark, we added some graphic to it, and that's now the new version of it. When we store it with the same file name. It accepts the same file name but creates a new version ID and attaches it. Anytime we want to roll back, we can always go to the console, look at the old versions, pick the version ID, and roll back to the old version ID. Alright, let's take this example. Now, I'm in a bucket that we've been using for a while, and let me upload an object. Now, before we actually upload an object, this bucket needs to be versioning enabled. So let me version enable this bucket. From this point onwards, this bucket is going to accept versioning. So let me upload an object, photo.jpg. Let me upload it. Alright, it successfully got uploaded. Good enough. It's uploaded. Now, let me upload another object with the same file name. Now look at that. It was uploaded at 7:35 a.m. Let me upload another object with the same file name that I have it stored right here. That got uploaded but with the same name. Alright, so that's the other photo. Now what if I want to switch back? The way I would switch back is simply switch back to the older version. Look at that. This is the latest version and this is the old version that I have. I can simply switch back to the old version that was created at such and such time, and I can open it. That's going to open the old file. So in short, it creates different version of the data that I create as long as it's with the same name, and at any point I can go and roll back to the original data. This is a very good use case if you want to use S3 for storing our codes. Let's talk about other feature like cross-region replication. Now, cross-region replication is a very cool feature if you want to automatically keep a copy of the data in a totally different region for data durability, for any additional data durability, or if you want to serve data to your customers who live in another country or who are accessing your data from another country. If you want to serve the data with low latency, cross-region replication is a very cool feature that you can use and get benefited from. And let's see how that's done. So before we actually do a lab on cross-region replication, let's put together a proper definition for it. Cross-region replication is a feature that provides automatic copying of every object uploaded to our bucket or your bucket, source bucket, and it automatically copies the data to the destination bucket, which is in a different AWS region. As you see here in the picture, I put data only in region 1. It's going to copy the data to region 2. And for us to use cross-region replication, versioning must be turned on. So it creates versions and copies the versions as well. If tomorrow the original region goes down, let's say the other region will be active and it has the complete data that was present in the original region. Or at any point, if we want to simply cut the region replication and use the other bucket as a standalone bucket, it can be used as well. because it already has all the data that was present in the master, or all the data that was present in the original replication bucket. Let's see how that's done. So there are two things needed. One is versioning, and another one is role. When we transfer data from one bucket to another bucket, we need proper permissions to do so, and these roles, they give us proper permissions to transfer data from one bucket to another bucket. Let's see how that's done. Right, so here's a bucket in US Oregon. Let's create another bucket in Mumbai. Call it .mumbai.com and put it in Mumbai, or create that bucket in Mumbai. There you go. We have one in Oregon, we have one in Mumbai. We're planning to replicate or create replication between these two, right? Create replication between these two buckets. So go to the first bucket, go to management, and start a replication. Add a rule. So all content in this bucket is going to get replicated. This is my source bucket. It's quite simple. Select the destination bucket. Now my destination bucket is going to be simplilearn.samuel.mumbai.com. All right, it says, well, you have versioning enabled in your source bucket, but not on your destination bucket. Do you want to enable it now? Without which we won't be able to proceed further. So let's go ahead and enable versioning through the console that shows up. And then, like I said, it's going to require permission to put data onto the other bucket. Now I can create different roles. These are different roles that are used for different other services. I can also choose to create a role that specifically gives permission only to move the data from one bucket to another bucket. Pretty much it's done. So if I go over to my source bucket, and if I add some data to it, let's say index.html, assuming I'm adding some files to it, in theory they should move to the other region automatically. There you go. I'm in the Mumbai region, and the datas, they got moved to the other region automatically. Let's talk about the other feature called transfer acceleration. Now it's a very handy and a helpful tool or a service to use if we are transferring data which is very long distance from us, meaning from the client to the S3 bucket. Let's say from my local machine, which is in India, if I transfer the data over to Oregon, let's say, it's a long distance. If it is going to go through the internet, it's going to go through high latency connections, and my transfer might get delayed. If it is an 1 gigabit file, it's okay. But if we're talking about anything that's 5 terabyte size, if you're talking about anything that's a 5 terabyte in size, then it's not going to be a pleasant experience. So in those cases, I can use transfer accelerator, which in a secure way, but in a fast way, or a fastest way, transfers my data from the laptop or from client to the S3 bucket. And it makes use of a service called CloudFront to transfer or to enable the data acceleration. So the way it would do it is, instead of copying the data directly to the location, instead of copying the data directly to the destination bucket, it copies the data locally into a CloudFront location, which is available very local to whatever place we are in, and from there it copies the data directly to an S3 bucket, not going through the internet. It helps eliminate a lot of latency that could get added when transferring the data. So let's see how that's done. Right here, I'm in the S3 bucket, and under properties I can find transfer accelerator, and if I enable transfer accelerator, so I'm in another bucket. Let me go to properties, and let me go to transfer accelerator and enable transfer accelerator. So now if I put data into this bucket, they're going to get copied to the local CloudFront location, and from there they're going to get copied to the S3 bucket from the CloudFront. Now if I need to compare how the speed is going to be compared to directly putting the data through the internet and using CloudFront, there is a tool available that actually runs for a while and then comes with a report that tells me how much will be the improved speed if I use transfer accelerator, and it shows for all the regions available in Amazon. So from the source to the destination, if you want to put what's the normal and what's the accelerated speed when you transfer the data. Those results we will get in this screen. So at the moment, this tool is going through its testing, like uploading some file through the internet and uploading some file using CloudFront, and it has come up with the calculation that if I'm uploading file to San Francisco compared to uploading through the internet and through CloudFront, it's 13 times faster. So similar way, it's going to calculate for all the regions available and it's going to give me a result.
Also, if you want to master the field of cloud computing, the postgraduate program in cloud computing, designed in collaboration with Caltech CTME, helps you become an Azure, AWS, and GCP expert. This in-depth cloud computing certification course lets you master key architectural principles and develop the skills needed to become a cloud expert. Benefits of this postgraduate program includes Caltech CTME Postgraduate Certificate, enrollment in Simplilearn's JobAssist. You will receive up to 30 CEUs from Caltech CTME. You will attend masterclasses from Caltech CTME instructors, live virtual classes led by industry experts, hands-on projects and integrated labs, online convocation by Caltech CTME Program Director, 40 plus hands-on projects and integrated labs, capstone project in 4 different domains, and Caltech CTME Circle membership. You can also fast-track your career with this cloud computing certification and its in-depth course curriculum, which covers the key concepts of Microsoft Azure, Amazon Web Services, and Google Cloud Platforms, and services such as AWS Lambda, Amazon S3, Azure App Services, and many more. So this program also covers the essential skills to become an expert in cloud computing, and you can consider this program because it provides you with a certification from Caltech CTME, a well-reputed university in the United States. So what are you waiting for? Check out the link mentioned in the description box below and start your cloud computing career today. So without any further delay, let's get started.
Hi, this is the 4th lesson of the AWS Solutions Architect course. Migrating to the cloud doesn't mean that resources become completely separated from the local infrastructure. In fact, running applications in the cloud will be completely transparent to your end users. AWS offers a number of services to fully and seamlessly integrate your local resources with the cloud. One such service is the Amazon Virtual Private Cloud. This lesson talks about creating virtual networks that closely resemble the ones that operate in your own data centers, but with the added benefit of being able to take full advantage of AWS. So let's get started.
In this lesson, you'll learn all about virtual private clouds and understand their concept. You'll know the difference between public, private, and elastic IP addresses. You'll learn about what a public and private subnet is. And you'll understand what an internet gateway is and how it's used. You'll learn what route tables are and when they are used. You'll understand what a NAT gateway is. We'll take a look at security groups and their importance. And we'll take a look at network ACLs and how they're used in Amazon VPC. We'll also review the Amazon VPC best practices and also the costs associated with running a VPC in the Amazon cloud. Welcome to the Amazon Virtual Private Cloud and Subnet section. In this section, we're going to have an overview of what Amazon VPC is and how you use it. And we're also going to have a demonstration of how to create your own custom virtual private cloud. We're going to look at IP addresses and the use of elastic IP addresses in AWS. And finally, we'll take a look at subnets, and there'll be a demonstration about how to create your own subnets in an Amazon VPC. And here are some of the terms that are used in VPCs. There's subnets, route tables, elastic IP addresses, internet gateways, NAT gateways, network ACLs, and security groups. And in the next sections, we're going to take a look at each of these and build our own custom VPC that we'll use throughout this course. Amazon defines a VPC as a virtual private cloud that enables you to launch AWS resources into a virtual network that you've defined. This virtual network closely resembles a traditional network that you'd operate in your own data center, but with the benefits of using the scalable infrastructure of AWS. A VPC is your own virtual network in the Amazon cloud, which is used as the network layer for your EC2 resources. And this is a diagram of the default VPC. Now there's a lot going on here, so don't worry about that. What we're going to do is break down each of the individual items in this default VPC over the coming lesson. But what you need to know is that a VPC is a critical part of the exam, and you need to know all the concepts and how it differs from your own networks. Throughout this lesson, we're going to create our own VPC from scratch, which you'll need to replicate at the end of this so you can do well in the exam. Each VPC that you create is logically isolated from other virtual networks in the AWS cloud. It's fully customizable. You can select the IP address range, create subnets, configure route tables, set up network gateways, define security settings using security groups, and network access control lists. So each Amazon account comes with a default VPC that's pre-configured for you to start using straight away, so you can launch your EC2 instances without having to think about anything we mentioned in the opening section. A VPC can span multiple availability zones in a region. And here's a very basic diagram of a VPC. It isn't this simple in reality. And as we saw in the first section, here's the default Amazon VPC, which looks kind of complicated. But what we need to know at this stage is that the CIDR block for the default VPC is always a 16 subnet mask. So in this example, it's 172.31.0.0/16. What that means is this VPC will provide up to 65,536 private IP addresses. So in the coming sections, we'll take a look at all of these different items that you can see on this default VPC. But why wouldn't you just use the default VPC? Well, the default VPC is great for launching new instances when you're testing AWS. But creating a custom VPC allows you to make things more secure, and you can customize your virtual network as you can define your own IP address range. You can create your own subnets that are both private and public, and you can tighten down your security settings. By default, instances that you launch into a VPC can't communicate with your own network. So you can connect your VPCs to your existing data center using something called hardware VPN access, so that you can effectively extend your data center into the cloud and create a hybrid environment. Now to do this, you need a virtual private gateway, and this is the VPN concentrator on the Amazon side of the VPN connection. Then on your side, in your data center, you need a customer gateway, which is either a physical device or a software application that sits on your side of the VPN connection. So when you create a VPN connection, a VPN tunnel comes up when traffic is generated from your side of the connection. VPC peering is an important concept to understand. A peering connection can be made between your own VPCs or with a VPC in another AWS account, as long as it's in the same region. So what that means is, if you have instances in VPC A, they wouldn't be able to communicate with instances in VPC B or C unless you set up a peering connection. Peering is a one-to-one relationship. A VPC can have multiple peering connections to other VPCs, but, and this is important, transitive peering is not supported. In other words, VPC A can connect to B and C in this diagram, but C wouldn't be able to communicate with B unless they were directly peered. Also, VPCs with overlapping CIDRs cannot be peered. So in this diagram you can see they all have different IP ranges, which is fine, but if they had the same IP ranges, they wouldn't be able to be peered. And finally for this section, if you delete the default VPC, you have to contact AWS support to get it back again. So be careful with it and only delete it if you have good reason to do so and know what you're doing. This is a demonstration of how to create a custom VPC. So here we are, back at the Amazon Web Services Management Console. And this time we're going to go down to the bottom left where the networking section is. I'm going to click on VPC. And the VPC dashboard will load up. Now there's a couple of ways you can create a custom VPC. There's something called the VPC wizard, which will build VPCs on your behalf from a selection of different configurations. For example, a VPC with a single public subnet, or a VPC with public and private subnets. Now this is great because you click a button, type in a few details, and it does the work for you. However, you're not going to learn much or pass the exam if this is how you do it. So we'll cancel that and we'll go to your VPCs and we'll click on Create a VPC. And we're presented with the Create a VPC window. So let's give our VPC a name. I'm going to call it Simplilearn_VPC. And this is the kind of naming convention I'll be using throughout this course. Next, we need to give it the CIDR block, or the classless interdomain routing block. So we're going to give it a very simple one, 10.0.0.0, and then we need to give it the subnet mask. So you're not allowed to go larger than 15. So if I try to put 15 in, it says no, not going to happen. For a reference, subnet mask of 15 would give you around 131,000 IP addresses, and subnet 16 will give you 65,536, which is probably more than enough for what we're going to do. Next, you get to choose the tenancy. And there's two options, default and dedicated. If you select dedicated, then your EC2 instances will reside on hardware that's dedicated to you. So your performance is going to be great, but your cost is going to be significantly higher. So I'm going to stick with default. And we just click on yes, create. It'll take a couple of seconds. And then in our VPC dashboard, we can see our Simplilearn VPC has been created. Now, if we go down to the bottom here to see the information about our new VPC, we can see it has a route table associated with it, which is our default route table. So there it is. And we can see that it's only allowing local traffic at the moment. We go back to the VPC again, we can see it's been given a default network ACL. And we'll click on that and have a look. And you can see this is very similar to what we looked at in the lesson. So it's allowing all traffic from all sources, inbound and outbound. Now if we go to the subnet section and just widen the VPC area here, you can see there's no subnets associated with the VPC we just created. So that means we won't be able to launch any instances into our VPC. And to prove it, I'll just show you. We'll go to the EC2 section. So this is a glimpse into your future. This is what we'll be looking at in the next lesson. And we'll just quickly try and launch an instance. We'll select any instance, it doesn't matter. Any size, not important. So here, the network section, if I try and select Simplilearn VPC, it's saying no subnets found, this is not going to work. So we basically need to create some subnets in our VPC, and that is what we're going to look at in the next lesson. Now, private IP addresses are IP addresses that are not reachable over the internet, and they're used for communication between instances in the same network. When you launch a new instance, it's given a private IP address and an internal DNS hostname that resolves to the private IP address of the instance. But if you want to connect to this from the internet, it's not going to work. So then you'd need a public IP address, which is reachable from the internet. You can use public IP addresses for communication between your instances and the internet. Each instance that receives a public IP address is also given an external DNS hostname. Public IP addresses are associated with your instances from the Amazon pool of public IP addresses. When you stop or terminate your instance, the public IP address is released and a new one is associated when the instance starts. So if you want your instance to retain its public IP address, you need to use something called an elastic IP address. An elastic IP address is a static or persistent public IP address that's allocated to your account and can be associated to and from your instances as required. an elastic IP address remains in your account until you choose to release it. There is a charge associated with an elastic IP address if it's in your account but not actually allocated to an instance. This is a demonstration of how to create an elastic IP address. So we're back at the Amazon Web Services Management Console. We're going to head back down to the Networking VPC section and we'll get to the VPC dashboard. On the left hand side we'll click on Elastic IPs. Now you'll see a list of any elastic IPs that you have associated in your account, and remember, any elastic IP address that you're using that isn't allocated to something you'll be charged for. So I have one available and that is allocated to an instance currently. So we want to allocate a new address, and it reminds you that there's a charge if you're not using it. I'm saying yes, allocate, and it takes a couple of seconds, and there's our new elastic IP address. Now we'll be using this IP address to associate with the NAT gateway when we build that. AWS defines a subnet as a range of IP addresses in your VPC. You can launch AWS resources into a subnet that you select. You can use a public subnet for resources that must be connected to the internet, and a private subnet for resources that won't be connected to the internet. The net mask for the default subnet in your VPC is always 20, which provides up to 4,096 addresses per subnet, and a few of them are reserved for AWS use. A VPC can span multiple availability zones, but a subnet is always mapped to a single availability zone. This is important to know. So here's our basic diagram, which we're now going to start adding to. So we can see the virtual private cloud, and you can see the availability zones, and now inside each availability zone we've created a subnet. Now you won't be able to launch any instances unless there are subnets in your VPC. So it's good to spread them across availability zones for redundancy and failover purposes. There's two different types of subnet, public and private. You use a public subnet for resources that must be connected to the internet, for example web servers. A public subnet is made public because the main route table sends the subnet's traffic that is destined for the internet to the internet gateway, and we'll touch on internet gateways next. Private subnets are for resources that don't need an internet connection or that you want to protect from the internet, for example database instances. So in this demonstration we're going to create some subnets, a public and a private subnet, and we're going to put them in our custom VPC in different availability zones. So we'll head to Networking and VPC, wait for the VPC dashboard to load up. We'll click on Subnets. We'll go to Create Subnet. And I'm going to give the subnet a name. So it's good to give them meaningful names. So I'm going to call this first one for the public subnet 10.0.1.0, and I'm going to put this one in the US East 1B availability zone, and I'm going to call it Simplilearn public. So it's quite a long name, I understand, but at least it makes it clear for what's going on in this example. So we need to choose a VPC. So we obviously want to put it in our Simplilearn VPC. And I said I wanted to put it in US East 1B. I'm using the North Virginia region, by the way. So we click on that. Then we need to give it the CIDR block. Now, as I mentioned earlier, when I typed in the name, that's the range I want to use. And then we need to give it the subnet mask. And we're going to go with 24, which should give us 251 addresses in this range, which obviously is going to be more than enough. If I try and put a different value in that's unacceptable to Amazon, it's going to say, it's going to give me an error and tell me not to do that. Let's go back to 24 and click. I'm going to cut and paste this, by the way, just because I need to type something very similar for the next one. Click Create. And it takes a few seconds. Okay, so there's our new subnet. And if I just widen this, you can see, so that's the IP range, that's the availability zone, it's for Simplilearn, and it's public. So now we want to create the private. So I'm going to put the name in. I'm going to give the private the IP address block of that. I'm going to put this one in US East 1C, and it's going to be the private subnet. Obviously I want it to be in the same VPC. Availability zone of US East 1C, and we're going to give it 10.0.2.0/24, and we'll click Yes, Create. And again, it takes a few seconds. Okay, so we sort by name. So there we are, we can see now we've got our private subnet and our public subnet. In fact, let me just type in Simplilearn, there we are. So now you can see them both there. And you can see they're both in the same VPC, Simplilearn VPC. Now if we go down to the bottom, you can see the route table associated with these VPCs. And you can see that they can communicate with each other internally, but there's no internet access. So that's what we need to do next. In the next lesson, you're going to learn about internet gateways and how we can make these subnets have internet access. Welcome to the networking section. In this section, we're going to take a look at internet gateways, route tables, and NAT devices. And we'll have a demonstration on how to create each of these AWS VPC items. So to allow your VPC the ability to connect to the internet, you need to attach an internet gateway. And you can only attach one internet gateway per VPC. So attaching an internet gateway is the first stage in permitting internet access to instances in your VPC. Now here's our diagram again, and now we've added the internet gateway, which is providing the connection to the internet to your VPC. But before you can configure internet correctly, there's a couple more steps. For an EC2 instance to be internet connected, you have to adhere to the following rules. Firstly, you have to attach an internet gateway to your VPC, which we just discussed. Then you need to ensure that your instances have public IP addresses or elastic IP addresses, so they're able to connect to the internet. Then you need to ensure that your subnet's route table points to the internet gateway, and you need to ensure that your network access control and security group rules allow relevant traffic to flow to and from your instance. So you need to allow the rules to let in the traffic you want, for example HTTP traffic. After the demonstration for this section, we're going to look at how route tables, access control lists, and security groups are used. In this demonstration, we're going to create an internet gateway and attach it to our custom VPC. So let's go to Networking VPC, bring up the VPC dashboard, and on the left hand side we click on Internet Gateways. So here's a couple of internet gateways I have already, but I need to create a new one. So create Internet Gateway. I'll give it a name, which is going to be Simplilearn Internet Gateway, IGW. And I'm going to click Create. So this is an internet gateway which will connect a VPC to the internet, because at the moment our custom VPC has no internet access. So there it's created, Simplilearn IGW, but its state is detached because it's not attached to anything. So let me try and attach it to a VPC. and it gives me an option of all the VPCs that have no internet gateway attached to them currently. So I only have one, which is Simplilearn VPC. Yes, attach. Now you can see our VPC has internet attached, and you can see that down here. So let's click on that and it will take us to our VPC. But before any instances in our VPC can access the internet, we need to ensure that our subnet route table points to the internet gateway. And we don't want to change the main route table, we want to create a custom route table. And that's what you're going to learn about next. A route table determines where network traffic is directed. It does this by defining a set of rules. Every subnet has to be associated with a route table, and a subnet can only be associated with one route table. However, multiple subnets can be associated with the same route table. Every VPC has a default route table, and it's good practice to leave this in its original state and create a new route table to customize the network traffic routes associated with your VPC. So here's our example, and we've added two route tables, the main route table and the custom route table. The new route table, or the custom route table, will tell the internet gateway to direct internet traffic to the public subnet. But the private subnet is still associated to the default route table, the main route table, which does not allow internet traffic to it. All traffic inside the private subnet is just remaining local. In this demonstration, we're going to create a custom route table, associate it with our internet gateway, and associate our public subnet with it. So let's go to Networking and VPC. The dashboard will load and we're going to go to Route Tables. Now our VPC only has its main route table at the moment, the default one it was given at the time it was created. So we want to create a new route table and we want to give it a name. So we're going to call it Simplilearn. I'm going to call it route table, RTB for short. And then we get to pick which VPC we want to put it in. So obviously we want to use Simplilearn VPC. So we click Create. It'll take a couple of seconds, and here you are. Here's our new route table. So what we need to do now is change its route so that it points to the internet gateway. So if we go down here to routes, at a minute you can see it's just like our main route table. It just has local access. So we want to click on Edit, and we want to add another route. So the destination is the internet, which is all the zeros, and our target, and we click on this, it gives us the option of our internet gateway, which we want to do. So now we have internet access to this subnet, to this route table. And we click on Save. Save was successful. So now we can see that as well as local access, we have internet access. Now at the moment, if we click on subnet associations, you do not have any subnet associations. So basically both our subnets, the public and private subnets, are associated with the main route table, which doesn't have internet access. So we want to change this. So we'll click on Edit, and we want our public subnet to be associated with this route table. So click on Save. So it's just saving that. So now we can see that our public subnet is associated with this route table, and this route table is associated with the internet gateway. So now anything we launch into the public subnet will have internet access. But what if we wanted our instances in the private subnet to have internet access? Well, there's a way of doing that with a NAT device, and that's what we're going to look at in the next lecture. You can use a NAT device to enable instances in a private subnet to connect to the internet or other AWS services, but prevent the internet from initiating connections with the instances in the private subnet. So we talked earlier about public and private subnets to protect your assets from being directly connected to the internet. For example, your web server would sit in the public subnet, and your database in the private subnet, which has no internet connectivity. However, your private subnet database instance might still need internet access or the ability to connect to other AWS resources. If so, you can use a Network Address Translation device, or a NAT device, to do this. A NAT device forwards traffic from your private subnet to the internet or other AWS services, and then sends the response back to the instances. When traffic goes to the internet, the source IP address of your instance is replaced with the NAT device address, and when the internet traffic comes back again, the NAT device translates the address to your instance's private IP address. So here's our diagram, which is getting ever more complicated, and if you look in the public subnet, you can see we've now added a NAT device, and you have to put NAT devices in the public subnet so that they get internet connectivity. AWS provides two kinds of NAT devices, a NAT gateway and a NAT instance. AWS recommends a NAT gateway as it's a managed service that provides better availability and bandwidth than NAT instances. Each NAT gateway is created in a specific availability zone and is implemented with redundancy in that zone. A NAT instance is launched from a NAT AMI, an Amazon Machine Image, and runs as an instance in your VPC, so it's something else you have to look after, whereas a NAT gateway, being a fully managed service, means once it's installed, you can pretty much forget about it. A NAT gateway must be launched into a public subnet because it needs internet connectivity. It also needs an elastic IP address, which you can select at the time of launch. Once created, you need to update the route table associated with your private subnet to point internet-bound traffic to the NAT gateway. This way, the instances in your private subnets can communicate with the internet. So if you remember back to the diagram when we had the custom route table, which was pointed to the internet gateway, now we're pointing our main route table to the NAT gateway, so that the private subnet also gets internet access, but in a more secure manner. Welcome to the Create a NAT Gateway demonstration, where we're going to create a NAT gateway so that the instances in our private subnet can get internet access. So we'll start by going to Networking and VPC. And the first thing we're going to do is take a look at our subnets, and you'll see why shortly. So here are our Simplilearn subnets. So this is the private subnet that we want to give internet access, but if you remember from the section, NAT gateways need to be placed in public subnets. So I'm just going to copy the name of this subnet ID for the public subnet, and you'll see why in a moment. So then we go to NAT gateways on the left hand side, and we want to create a new NAT gateway. So we have to put a subnet in there. So we want to choose our public subnet. Now, as you can see, it truncates a lot of the subnet names on this option, so it's a bit confusing. So we know that we want to put it in our Simplilearn VPC in the public subnet, but you can see it's truncated. So it's actually this one at the bottom, but what I'm going to do is just paste in the subnet ID, which I copied earlier, so there's no confusion. Then we need to give it an elastic IP address. Now, if you remember from the earlier demonstration, we created one, so let's select that. But if you hadn't allocated one, you could click on the Create New EIP button. So we'll do that. Okay, so it's telling me my NAT gateway has been created. And in order to use your NAT gateway, ensure that you edit your route table to include a route with a target of, and then our NAT gateway ID. So it's given us the option to click on our edit route tables. So we'll go straight there. Now here's our route tables. Now here's the custom route table that we created earlier, and this is the default, the main route table, which was created when we created our VPC. So we should probably give this a name so that we know what it is. So let me just call this Simplilearn RTB main. So now we know that's our main route table. So if you take a look at the main route table and the subnet associations, you can see that our private subnet is associated with this table. So what we need to do is put a route in here that points to the NAT gateway. So if we click on routes and edit, and we want to add another route, and we want to say that all traffic can either go to the Simplilearn internet gateway, which we don't want to do. We want to point it to our NAT instance, which is this NAT ID here, and we click save. So now any instances launched in our private subnet will be able to get internet access via our NAT gateway.
Welcome to the Using Security Groups and Network ACL section. In this section, we're going to take a look at security groups and network ACLs, and we're going to have a demonstration on how you create both of these items in the Amazon Web Services console.
A security group acts as a virtual firewall that controls the traffic for one or more instances. You add rules to each security group that allow traffic to or from its associated instances. Basically, a security group controls the inbound and outbound traffic for one or more EC2 instances. Security groups can be found on both the EC2 and VPC dashboards in the AWS Web Management Console. We're going to cover them here in this section, and you'll see them crop up again in the EC2 lesson. And here is our diagram, and you can see we've now added security groups to it. And you can see that EC2 instances are sitting inside the security groups, and the security groups will control what traffic flows in and out. So let's take a look at some examples, and we'll start with a security group for a web server. Now obviously a web server needs HTTP and HTTPS traffic as a minimum to be able to access it. So here is an example of the security group table, and you can see we're allowing HTTP and HTTPS, the ports that are associated with those two, and the sources, and we're allowing it from the internet. We're basically allowing all traffic to those ports. And that means any other traffic that comes in on different ports would be unable to reach the security group and the instances inside it. Let's take a look at an example for a database server security group. Now imagine you have a SQL Server database, then you would need to open up the SQL Server port so that people can access it. Which is port 1433 by default, so we've added that to the table and we've allowed the source to come from the internet. Now because it's a Windows machine, you might want RDP access, so you can log on and do some administration. So we've also added RDP access to the security group. Now you could leave it open to the internet, but that would mean anyone could try and hack their way into your box. So in this example we've added a source IP address of 10.0.0.0.0. So only IP ranges from that address can RDP to the instance. Now there's a few rules associated with security groups. By default, security groups allow all outbound traffic. So if you want to tighten that down, you can do so in a similar way to you can define the inbound traffic. Security group rules are always permissive. You can't create rules that deny access, so you're allowing access rather than denying it. Security groups are stateful, so if you send a request from your instance, the response traffic for that request is allowed to flow in regardless of the inbound security group rules. And you can modify the rules of a security group at any time, and the rules are applied immediately. Welcome to the Create Security Group demonstration, where we're going to create two security groups, one to host DB servers and one to host web servers. Now if you remember from the best practices section, it said it was always a good idea to tier your applications into security groups, and that's exactly what we're going to do. So if we go to networking and VPC to bring up the VPC dashboard, on the left hand side under security we click on security groups. Now you can also get to security groups from the EC2 dashboard as well. So here's a list of my existing security groups, but we want to create a new security group, and we're going to call it Simplilearn Web Server SG security group, and we'll give the group name as the same, and our description is going to be Simplilearn Web Servers Security Groups. Okay, and then we need to select our VPC. Now it defaults to the default VPC, but obviously we want to put it in our Simplilearn VPC. So we click Yes, Create. Takes a couple of seconds. And there it is. There's our new security group. Now if we go down to the rules, the inbound rules, you can see there are none. So by default, a new security group has no inbound rules. But what about outbound rules? If you remember from the lesson, a new security group by default allows all traffic to be outbound. And there you are. All traffic has destination of everywhere. So all traffic is allowed. But we want to add some rules. So let's click on inbound rules. Click on edit. Now this is going to be a web server. So if we click on the drop down, we need to give it HTTP. So you can either choose custom TCP rule and type in your own port ranges, or you can just use the ones they have for you. So HTTP, this pre-populates the port range. And then here you can add the source. Now if I click on it, it's giving me the option of saying allow access from different security groups. So you could create a security group and say I only accept traffic from a different security group, which is a nice way of securing things down. You could also put in here just your IP address so that only you could do HTTP requests to the instance. But because it's a web server, we want people to be able to see our website, otherwise it's not going to be much use. So we're going to say all traffic, so all source traffic can access our instance on port HTTP 80. I want to add another rule because we also want to do HTTPS, which is hiding from me. There we are. And again, we want to do the same. And also, because this is going to be a Linux instance, we want to be able to connect to the Linux instance to do some work and configuration. So we need to give it SSH access. And again, it would be good practice to tie it down to your specific IP or an IP range. But we're just going to do all for now. And then we click on Save. And there we are. There we have our ranges. So now we want to create our security group for our DB servers. So let's click Create Security Group. And then we'll go through it and give it a similar name. Simplilearn DB servers SG. And the description is going to be Simplilearn DB servers security group. And our VPC is obviously going to be Simplilearn VPC. So let's click Yes, Create. We'll wait a few seconds. And here's our new security group. As you can see, it has no inbound rules by default, and outbound rules allow all traffic. So this is going to be a SQL Server database server. And so we need to allow SQL Server traffic into the instance. So we need to give it Microsoft SQL port access. Now the default port for Microsoft SQL Server is 1433. Now in reality, I'd probably change the port the SQL Server was running on to make it more secure, but we'll go with this for now. And then the source. So we could choose the IP ranges again, but what we want to do is place the DB server in the private subnet and allow the traffic to come from the web server. So the web server will accept traffic, and the web server will then go to the database to get the information it needs to display on its on the website. Or if people are entering information into the website, we want the information to be stored in our DB server. So basically, we want to say that the DB servers can only accept SQL Server traffic from the web server security group. So we can select the Simplilearn web server security group as the source traffic for Microsoft SQL Server data. So we'll select that. Now our SQL Server is obviously going to be a Windows instance. So from time to time we might need to log in and configure it. So we want to give RDP access. Now again, you would probably put a specific IP range in there. We're just going to do all traffic for now. Then we click Save. And there we are. So now we have two security groups, DB servers and web servers. A network ACL is a network access control list, and it's an optional layer of security for your VPC that acts as a firewall for controlling traffic in and out of one or more of your subnets. You might set up network ACLs with rules similar to your security groups, in order to add an additional layer of security to your VPC. Here is our network diagram, and we've added network ACLs to the mix. Now you can see they sit somewhere between the route tables and the subnets. This diagram makes it a little bit clearer, and you can see that a network ACL sits in between a route table and a subnet. And also you can see an example of the default network ACL, which is configured to allow all traffic to flow in and out of the subnets to which it's associated. Each network ACL includes a rule, whose rule number is an asterisk. This rule ensures that if a packet doesn't match any of the other numbered rules, it's denied. You can't modify or remove this rule. So if you take a look at this table, you can see on the inbound, some traffic would come in and it would look for the first rule, which is 100. And that's saying I'm allowing all traffic from all sources. So that's fine, the traffic comes in. If that rule 100 wasn't there, it would go to the asterisk rule. And the asterisk rule is saying traffic from all sources is denied. Let's take a look at the network ACL rules. Each subnet in your VPC must be associated with an ACL. If you don't assign it to a custom ACL, it will automatically be associated to your default ACL. A subnet can only be associated with one ACL. However, an ACL can be associated with multiple subnets. An ACL contains a list of numbered rules which are evaluated in order, starting with the lowest. As soon as a rule matches traffic, it's applied regardless of any higher numbered rules that may contradict it. AWS recommends incrementing your rules by a factor of 100, so there's plenty of room to implement new rules at a later date. Unlike security groups, ACLs are stateless. Responses to allowed inbound traffic are subject to the rules for outbound traffic. Welcome to the network ACL demonstration, where we're just going to have an overview of ACLs where they are in the dashboard. Now you don't need to know a huge amount about them for the exam, you just need to know how they work and where they are. So let's go to networking and VPC, and when the dashboard loads, on the left hand side under security there's network ACLs. So let's click on that. Now you can see some ACLs that are in my AWS account. So we want the one that's associated with our Simplilearn VPC. So if we extend this VPC column, that's our network ACL there, Simplilearn VPC. Now let's give it a name because it's not very clear to see otherwise. Also, I'm kind of an obsessive tagger, so let's call it Simplilearn ACL and click on the tick. So there we are. So now it's much easier to see. So we click on inbound rules. So this is exactly what we showed you in the lesson. The rule is 100, so that's the first rule that's going to get evaluated, and it's saying allow all traffic from all sources. And the outbound rules are the same. So if you wanted to tighten down the new rule, you could click edit, we'll give it a new rule number, say which would be 200. So you should always increment them in 100. So that means if you had 99 more rules you needed to put in place, you'd have space to put them in between these two. And then you could do whatever you wanted. You could say, you know, we are allowing HTTP access from all traffic, and we're allowing, or you could say, actually, you know what, we're going to deny it. So this is the way of blacklisting traffic into your VPC. Now I'm not going to save that because we don't need it, but this is where network ACLs sit, and this is where you would make any changes. It's also worth having a look at the subnet associations with your ACL. So we have two subnets in our Simplilearn VPC, so we would expect to see both of them associated with this network ACL because it's the default. And there they are. There's both our public and our private subnets are associated. And you can also see up here on the dashboard, it says default. So this is telling us this is our default ACL. If you did want to create a new network ACL, you would click create network ACL. You'd give it a name, just say new ACL, and then you would associate it with your VPC. So we would say Simplilearn VPC. Takes a few seconds, and there we are. There we have our new one. Now you can see this one says default no, because it obviously isn't the default ACL for our Simplilearn VPC, and it has no subnets associated with it. So let's just delete that because we don't need it. But there you are, there's a very brief overview of network ACLs. Welcome to the Amazon VPC Best Practices and Costs, where we're going to take a look at the best practices and the costs associated with the Amazon Virtual Private Cloud. Always use public and private subnets. You should use private subnets to secure resources that don't need to be available to the internet, such as database services. To provide secure internet access to the instances that reside in your private subnets, you should provide a NAT device. When using NAT devices, you should use a NAT gateway over NAT instances because they're a managed service and require less administration effort. You should choose your CIDR blocks carefully. Amazon VPC can contain from 16 to 65,536 IP addresses, so you should choose your CIDR block according to how many instances you think you'll need. You should also create separate Amazon VPCs for development, staging, test and production, or create one Amazon VPC with separate subnets, with a subnet each for production, development, staging and test. You should understand the Amazon VPC limits. There are various limitations on the VPC components. For example, you're allowed 5 VPCs per region, 200 subnets per VPC, 200 route tables per VPC, 500 security groups per VPC, 50 in- and outbound rules per VPC. However, some of these rules can be increased by raising a ticket with AWS support. You should use security groups and network ACLs to secure the traffic coming in and out of your VPC. Amazon advises to use security groups for whitelisting traffic and network ACLs for blacklisting traffic. Amazon recommends tiering your security groups. You should create different security groups for different tiers of your infrastructure architecture inside VPC. If you have web tiers and DB tiers, you should create different security groups for each of them. Creating tier-wise security groups will increase the infrastructure security inside the Amazon VPC. So if you launch all your web servers in the web server security group, that means they'll automatically all have HTTP and HTTPS open. Conversely, the database security group will have SQL Server ports already open. You should also standardize your security group naming conventions. Following a security group naming convention allows Amazon VPC operation and management for large-scale deployments to become much easier. Always span your Amazon VPC across multiple subnets in multiple availability zones inside a region. This helps in architecting high availability inside your VPC. If you choose to create a hardware VPN connection to your VPC using Virtual Private Gateway, you are charged for each VPN connection hour that your VPN connection is provisioned and available. Each partial VPN connection hour consumed is billed as a full hour. You'll also incur standard AWS data transfer charges for all data transferred via the VPN connection. If you choose to create a NAT gateway in your VPC, you are charged for each NAT gateway hour that your NAT gateway is provisioned and available. Data processing charges apply for each gigabyte processed through the NAT gateway. Each partial NAT gateway hour consumed is billed as a full hour. This is the practice assignment for designing a custom VPC, where you'll create a custom VPC using the concepts learnt in this lesson. Using the concepts learnt in this lesson, recreate the custom VPC as shown in the demonstrations. The VPC name should be Simplilearn VPC. The CIDR block should be 10.0.0.0/16. There should be 2 subnets, one public with a range of 10.0.1.0 and one private with a range of 10.0.2.0, and they should be placed in separate availability zones. There should be one internet gateway and one NAT gateway, and also one custom route table for the public subnet. Also create 2 security groups, Simplilearn Web Server Security Group and Simplilearn DB Server Security Group.
AWS Lambda tutorial now.
One day at office in a growing company, there was discussion going on between two IT personnel. It was about the new role that his colleague Jessica has taken. Benjamin, the guy standing here, wants to know about it. And Jessica's job is new, different, and dynamic and interesting too. She scale and manage servers and operating systems and apply security patches onto them and monitor all of these at the same time to ensure the best quality for application is given to the users. And Benjamin was awestruck with the amount of work Jessica is doing and with the time it would take to complete all of them. But Jessica, being a very dynamic person, very suitable for the job, said it was easy for her to handle all of it and even more. But that easiness on the job did not last longer. As the environment grew more and more, it being a startup company, Jessica was getting drained and was not really happy about all her job as she used to be. Jessica's manual way of scaling an environment did not last long, and she was also finding out that she missed to scale down some of the resources and it's costing her a lot. She needs to pay for the service that she was not at all using. She sort of felt that she was at the end of the road and there was no way out from this manual task. She was very desperate. And that's when Benjamin suggested something, and that brought back the peace and joy Jessica initially had. Benjamin suggested about a service called Lambda that can ease the work that Jessica is doing at the moment. And Lambda, as happy as it looks like, it's a solution that solves the manual, repetitive work and lot more. And Lambda introduced itself as the problem solver and started to explain the following things, the very same thing that we're going to learn about in this series. So in this section, we're going to learn about the features of AWS Lambda, and we're going to talk about what Lambda is, and then we're going to talk about where Lambda is being used in the IT or in the cloud environment as we speak, and then we're going to talk about how Lambda works and some use cases of Lambda, and we're going to be particularly discussing about the use case about automatically backing up the data that's put in the cloud storage. Let's talk about Lambda in detail. Lambda automatically runs our code without requiring us to provision or manage servers. Just write the code and upload it to Lambda, and Lambda will take care of it. That means that we don't require any server to run or to manage, and all you need to do is write the code and upload it to Lambda, and Lambda will take care of it. Which also means that we can stop worrying about provisioning and managing servers. The only thing Lambda expects from you is a code that's working. AWS Lambda also automatically scales our application by running code in response to each trigger. Our code runs in parallel and processes each triggers individually, scaling precisely with the size of the workload. Scaling here is done automatically based on the size of the workload. Lambda can scale the application running the code in response to each and every trigger that it receives. Billing in Lambda is metered on the seconds. We only pay for the amount of time that our code is running, which means that we're not charged for any of the servers. The only payment required is for the amount of time the code is computed. With AWS Lambda, we are charged for every 100 milliseconds. We are actually charged for 100 milliseconds our code executes and the number of times our code is triggered, and we don't pay anything when the code is not running. Let's talk about what is AWS Lambda. Now, Lambda is one of the services that falls under the compute section or the compute domain of services that AWS provides, along with EC2, EBS, Elastic Load Balancer. Lambda is also a service that comes under the bigger umbrella of compute services in AWS. And Lambda allows us to execute code for any type of application. With AWS Lambda, we can run code for virtually any type of application or backend services. All we need to do is supply our code in one of the languages that AWS Lambda supports. As we speak, the languages that are supported by AWS Lambda are Node.js, Java, C#, Go, and Python. And Lambda can be used to run code in response to certain events from other services. And based on the event, it can run functions, and those functions can be of Node.js, Java, C#, etc. Now let's talk about where is Lambda used. There are a huge number of use cases for Lambda, and there are many ways AWS Lambda is used specifically in the business world. Let's talk about some of them. One use case is AWS Lambda is used to process images when it is uploaded in an S3 bucket. Let's say the object gets uploaded in an S3 bucket in a format that we don't expect it to be, which means the file needs to be formatted. So it gets uploaded in a raw format, and AWS Lambda is triggered anytime a new object is added to the bucket, and the images are processed and converted into thumbnails based on the devices. The other end device that would be reading the data, it could be an PC, it could be an Apple machine, it could be an Android phone, it could be an Apple phone, it could be a tablet, whatnot. So based on the devices, different formats, Lambda can get triggered and convert the video or convert the picture into the different format that it requires. Another use case for Lambda is to analyze the social media data. Let's say we're collecting the hashtag trending data, and the data is received and it's added into the Kinesis stream to feed into the Amazon environment, and Lambda action get triggered and it receives the data, and then the data is stored into the database, which can be used by businesses for later analysis. And some of the companies that have gotten tremendous benefit using Lambda are Thomson Reuters, Benchlinks, Nordstorm, Coca-Cola, Robot are some of the companies to name at the moment that have received tremendous amount of benefit by using Lambda. Let's look at how Lambda works. In other words, let's look at how the complicated function behind the scenes work in a simple and in a seamless way. So here clients send data. Now clients send data to Lambda, and clients could be anyone who's sending request to AWS Lambda. It could be an application or other Amazon web services that's sending data to the Lambda. And Lambda receives the request, and depending on the size of the data or depending on the amount or volume of the data, it runs on the defined number of containers. If it is a single request or if it is less request, it runs on a single container. So the requests are given to the container to handle, and the container which contains the code the user has provided to satisfy the query would run. And if you're sort of new to containers, then let me pause here for a while and explain to you what container is. Now, container image is a lightweight, standalone, executable package of a piece of software that includes everything needs to run it, like the codes, the runtimes, the system tools, the system libraries, and any other settings needed. And it is at the moment available both on Linux and Windows based application, and containerized software will always run the same regardless of the environment it's running on. And containers isolate software from its surrounding. For example, there could be difference between a development and staging environment, so that's sort of isolated, and this helps in reducing the conflict between the teams running different software on the same infrastructure. Alright, now that we know containers needed to understand Lambda, so if there are few requests, it sends to a single container, but as and when the request grows, it actually creates multiple containers, shares the multiple requests to the different containers there. And depending on the volume, depending on the size, depending on the number of sessions, the more number of containers are provisioned so to handle those requests. And when the requests reduce, the number of containers reduce as well, and that helps in saving costs. We're not running any resources and paying for it when we're not using them. And in fact, we're not at all paying for the resources. We're only charged for the amount of time a function is running inside these containers. Now consider a situation where you have to set up a temporary storage and as a system to back up the data as soon as the data is uploaded, which is a near real-time backup. Now, a near real-time manual backups are nearly impossible, and they're not that efficient too. A near real-time manual backups, that's what the business demands, but that's not near real-time backup. That too a manual one, that's not at all efficient. Even if we come up with a solution of manually backing up close to near real time, that's not going to be efficient looking at the amount of data that will be put in and looking at the random times the data will be put into the source bucket. And there is no way we can do a manual backup and keep it as real as possible. But if that's still your requirement, we can use AWS Lambda
and set things up so AWS Lambda manually handles the backup. In other words, for an impossible or a difficult situation like that, AWS Lambda comes for the rescue. And this is what we do. Create a two S3 bucket. One would be the source bucket where the data will be uploaded, and the other one is a destination bucket where the data will be backed up from the source bucket. And for these buckets to talk to themselves, it's going to require an IAM role. And then for the automatic copy, it's going to require an Lambda function to copy the files from the source bucket to the destination bucket. And what triggers the Lambda function? The Lambda function is triggered every time there's a change in the metadata for the bucket, and this data is then uploaded into the destination bucket. And after setting all this up, we can literally test it by putting a data in the source bucket that's going to automatically replicate, or that's going to automatically copy the data from the source bucket to the destination bucket. All right, let's see how we can replicate data between two buckets. Well, we have a feature to cross-region replicate in S3. That's a feature that comes along with S3. What if you want to replicate between two different buckets in two different accounts? In those cases, we can use Lambda to replicate the data between the buckets. So you put one data, or you put data in the source bucket, and that data gets replicated to the destination bucket. And let's see how that's done. The procedure here would be to have two buckets to begin with, and then create an IAM role that lets you access to pull data from the source bucket and put data on the destination bucket, and then create Lambda files or Lambda event or triggers to actually look for event in the source bucket, and anytime a new data gets added, Lambda gets triggered, copies the data from the source bucket and moves the data to the destination bucket, and it uses the IAM role and policy for the needed permissions. And in just a couple of clicks, we have set up a temporary backup system that can run seamlessly without any manual intervention, and that can be as near real time as possible. Alright, that's the concept, and let's see how it is done real time through this lab. So to begin with, we need two buckets. So I have here a source bucket and a destination bucket, and the source bucket as of now do not have any data in it, so as the destination bucket. Alright, so that's one down. The second would be to create an IAM role. Alright, so let me create an IAM role, and the role is going to have this policy in it. A policy that's allowing get object on the source bucket, and a policy that's allowing put object on the destination bucket. And here I'm going to use, or I'm going to paste my source and destination buckets ARN. All right, go to services, go to S3, source bucket. All right, click on the source bucket and copy the bucket ARN. So that would be the source bucket ARN. All right, on the destination bucket, copy the destination bucket ARN, and this is going to be my destination bucket ARN. So with this, I'm going to create a policy. All right, go to IAM and create a policy. Now I have already created a policy with the same information. All right, destination bucket ARN, and a policy is available with the name S3 bucket copy Lambda. Attach the policy to the role. Right, go to roles, create a role. Lambda is the service that's going to use it. In here, attach the policy that we have created. Right, give it a name, and then create a role. Now I have a role created as well. Right, copy Lambda, and that's having the policy that we have created sometime back. Now create a Lambda function. Right, so go to Lambda, create a function, give it a name like S3 bucket copy. Right, choose the role that we want to use. Right, that's the role that we want to use. Copy 1, 2, create a function. All right, and in here we're going to use Node.js code. Right, I have a sample code. This can be used as template. In here, replace the source bucket with the name of the source bucket and the destination bucket
with the name of the destination bucket. This is a Node.js code that gets run when an event gets triggered. Now what's an event? Anytime there is a new object placed in the S3 bucket, it creates an event, and the event triggers Lambda, and Lambda checks the source S3 bucket, picks the data, puts it in the destination bucket. All right, paste it here. Paste it here and click on save. All right, now before you click on save, just ensure that you have the appropriate roles defined. That's all you got to do. Click on save. All right, now I already have created a Lambda function, all right, which is the same thing, same code, and the role is attached to it. Now it's running, it's active. Now let's put this to test. Go to S3, pick the source bucket, put some data in it, all right, and in theory those data should be present in the destination bucket as well. There you go. It's all done by Lambda.
Also, if you want to master the field of cloud computing, the postgraduate program in cloud computing, designed in collaboration with Caltech CTME, helps you become an Azure, AWS, and GCP expert. This in-depth cloud computing certification course lets you master key architectural principles and develop the skills needed to become a cloud expert. Benefits of this postgraduate program includes Caltech CTME Postgraduate Certificate, enrollment in Simplilearn's JobAssist. You will receive up to 30 CEUs from Caltech CTME. You will attend masterclasses from Caltech CTME instructors, live virtual classes led by industry experts, hands-on projects and integrated labs, online convocation by Caltech CTME Program Director, 40 plus hands-on projects and integrated labs, capstone project in 4 different domains, and Caltech CTME Circle membership. You can also fast-track your career with this cloud computing certification and its in-depth course curriculum, which covers the key concepts of Microsoft Azure, Amazon Web Services, and Google Cloud Platforms, and services such as AWS Lambda, Amazon S3, Azure App Services, and many more. So this program also covers the essential skills to become an expert in cloud computing, and you can consider this program because it provides you with a certification from Caltech CTME, a well-reputed university in the United States. So what are you waiting for? Check out the link mentioned in the description box below and start your cloud computing career today. So without any further delay, let's get started.
Here we're going to talk about Amazon ECS, a service that's used to manage Docker containers. So without any further ado, let's get started. In this session, we would like to talk about some basics about AWS, and then we're going to immediately dive into why Amazon ECS and what is Amazon ECS in general, and then it uses a service called Docker, so we're going to understand what Docker is. And there are competitive services available for ECS. I mean, ECS is not the own and only service to manage Docker containers. But why ECS? Advantage of ECS. We will talk about that. And the architecture of ECS. So how it functions, what are the components present in it, and what are the functions that it does. I mean, each and every component, what are all the functions that it does. All those things will be discussed in the architecture of Amazon ECS. And how it works, how it all connects together. That's something we will discuss. And what are the companies that are using ECS? What were the challenge and how ECS helped to fix the challenge? That's something we will discuss. And finally, we have a wonderful lab that talks about how to deploy Docker containers on an Amazon ECS. So let's talk about what is AWS. Amazon Web Service, in short called as AWS, is an web service in the cloud that provides a variety of services such as compute power, database storage, content delivery, and a lot of other resources, so you can scale your business and grow, not focus more on your IT needs and the rest of the IT demands. Rather, you can focus on your business and let Amazon scale your IT, or let Amazon take care of your IT. So what is that you can do with AWS? With AWS, we can create, deploy, any application in the cloud. So it's not just deploying, you can also create your application in the cloud. It has all the tools and services required, the tools and services that you would have installed in your laptop or you would have installed in your on-premises desktop machine for your development environment. The same thing can be installed and used from the cloud. So you can use cloud for creating, and not only that, you can use the same cloud for deploying and making your application available for your end user. The end user could be internal users, the end user could be in the internet, the end user could be kind of spread all around the world. It doesn't matter. So it can be used to create and deploy your applications in the cloud. And like you might have guessed, now it provides service over the internet. That's how your users worldwide would be able to use the service that you create and deploy, right? So it provides service over the internet. So that's for the end customer. And how will you access those services? That's again through the internet. It's like the extension of your data center in the internet. So it provides all the services in the internet. It provides compute service through the internet. So in other words, you access them through the internet. It provides database service through the internet, over the internet. In other words, you can securely access your database through the internet, and a lot more. And the best part is this is pay as you go, or pay only for what you use. There is no long-term or beforehand commitment. Here, most of the services does not have any commitment. So there is no long-term and beforehand commitment. You only pay exactly for what you use. There's no overage, there's no overpaying, right? There's no buying in advance, right? You only pay for what you use. Let's talk about what ECS is. So before ECS, before containers, right? ECS is a service that manages Docker containers, right? It's not a product or it's not a feature all by itself. It's a service that's dependent on Docker container. So before Docker containers, all the applications were running on VM or on a host or on a physical machine, right? And that's memory bound, that's latency bound. The server might have issues, on and on, right? So let's say this is Alice and she's trying to access her application, which is running somewhere in her on-premises, and the application isn't working. What could be the reason? Some of the reasons could be memory full, the server is currently down at the moment, we don't have another physical server to launch the application, a lot of other reasons. So a lot of reasons why the application wouldn't be working in on-premises. Some of them are memory full issue and server down issue, very less high availability, or in fact single point of failure and no high availability, if I need to tell it correctly. With ECS, the services can kind of breathe free, right? The services can run seamlessly. Now how is that possible? Now those things we will discuss in the upcoming sessions. So because of containers and ECS managing containers, the applications can run in a high available mode. They can run in a high available mode, meaning if something goes wrong, right, there's another container that gets spun up and your application runs in that particular container. Very less chances of your application going down. That's what I mean. This is not possible with a physical host. This is very less possible with a VM, or at least it's going to take some time for another VM to get spun up. So why ECS, or what is ECS? Amazon ECS maintains the availability of the application and allows every user to scale containers when necessary. So it not only meets the availability of the application, meaning one container running your application or one container hosting your application should be running all the time. So to meet that high availability, availability is making sure your service is running 24/7. So container makes sure that your services run 24/7. Not only that. Suddenly if there is an increase in demand, how do you meet that demand? Right? Let's say you have like 1,000 users. Suddenly the next week there are like 2,000 users. Right. So how do you meet that demand? Container makes it very easy for you to meet that demand. In case of VM or in case of physical host, you literally will have to go buy another physical host, or add more RAM, add more memory, add more CPU power to it, right? Or kind of club 2-3 hosts together, clustering you would be doing a lot of other things to meet that high availability and also to meet that demand. But in case of ECS, it automatically scales the number of containers. It automatically scales the number of containers needed, and it meets your demand for that particular hour. So what is Amazon ECS? The full form of ECS is Elastic Container Service, right? So it's basically a container management service which can quickly launch and exit and manage Docker containers on a cluster. So what's the function of ECS? It helps us to quickly launch and quickly exit and manage Docker containers. So it's kind of a management service for the Docker containers you will be running in Amazon or running in the AWS environment. So in addition to that, it helps to schedule the placement of container across your cluster. So it's like this: you have two physical hosts, joined together as a cluster, and ECS helps us to place your containers. Now, where should your container be placed? Should it be placed in host 1? Should it be placed in host 2? So that logic is defined in ECS. We can define it. You can also let ECS take control and define that logic. Most cases you will be defining it. So schedule the placement of containers across your cluster. Let's say two containers want to interact heavily. You really don't want to place them in two different hosts, right? You would want to place them in one single host so they can interact with each other. So that logic is defined by us. And these container services, you can launch containers using AWS Management Console, and also you can launch containers using SDK kits available from Amazon. You can launch through a Java program. You can launch container using an .NET program. You can launch container using an Node.js program, as in when the situation demands. So there are multiple ways you can launch containers through Management Console and also programmatically. And ECS also helps to migrate application to the cloud without changing the code. So anytime you think of migration, the first thing that comes to your mind is that how will that environment be? Based on that, I'll have to alter my code. What's the IP? What is the storage that's being used? What are the different parameters I'll have to include? The environment parameters of the new environment. With containers, now that worry is already taken away, because we can create an pretty exact environment. The one that you had on premises, the same environment gets created in the cloud. So no worries about changing the application parameter, no worries about changing the code in the application. Right? You can be like, if it ran in my laptop, a container that I was running in my laptop, it's definitely going to run in the cloud as well, because I'm going to use the same container in the laptop and also in the cloud. In fact, you're going to ship it. You're going to move the container from your laptop to Amazon ECS and make it run there. So it's like the very same image, the very same container that was running in your laptop will be running in the cloud or production environment. So what is Docker? We know that ECS helps to quickly launch, exit, and manage Docker containers. What is Docker? Let's answer that question. What is Docker? Now, Docker is a tool that helps to automate the development of an application as a lightweight container so that the application can work efficiently in different environments. This is pretty much what we discussed right before the slide. I can build an application in my laptop or in on-premises in a container environment, Docker container environment, and anytime I want to migrate, right, I don't have to kind of rewrite the code and then rerun the code in that new environment. I can simply create an image, a Docker image, and move that image to that production or the new cloud environment and simply launch it there. Right? So no compiling again, no relaunching the application. Simply pack all your code in a Docker container image and ship it to the new environment and launch the container there. That's all. So Docker container is a lightweight package of software that contains all the dependencies. So because, when packing, you'll be packing all the dependencies. You'll be packing the code. You'll be packing the framework. You'll be packing the libraries that are required to run the application. So in the new environment, you can be pretty sure, you can be guaranteed that it's going to run because it's the very same code, it's the very same framework, it's the very same libraries that you have shipped, right? There's nothing new in that new environment. It's the very same thing that's going to run in that container. So you can be rest assured that they are going to run in that new environment. And these Docker containers are highly scalable and they are very efficient. Suddenly you wanted like 20 more Docker containers to run the application. Think of adding 20 more hosts, 20 more VMs, right? How much time would it take? And compared to that time, the amount of time that Docker containers would require to kind of scale to that amount, like 20 more containers, it's very less, or it's minimal or negligible. So it's a highly scalable and it's a very efficient service. You can suddenly scale number of Docker containers to meet any additional demand. Very short boot up time because it takes it's not going to load the whole operating system. And these Docker containers, they use the Linux kernel and features of the kernel like C groups and namespaces to kind of segregate the processors so they can run independently any environment, and it takes very less time to boot up. And the data that are stored in the containers are kind of reusable. So you can have an external data volume and I can map it to the container, and whatever the space that's occupied by the container and the data that the container puts in that volume, they are kind of reusable. You can simply remap it to another application. You can kind of remap it to the next successive container. You can kind of remap it to the next version of the container, next version of the application you'll be launching, and you don't have to go through building the data again from the scratch. Whatever data the container was using previously or the previous container was using, that data is available for the next container as well. So the volumes that the containers uses are very reusable volumes. And like I said, it's isolated application, so it kind of isolates by its nature. It kind of, by the way it's designed, by the way it is created, it isolates one container from another container, meaning anytime you run applications on different containers, you can be rest assured that they are very much isolated. Though they are running on the same host, though they are running on the same laptop, let's say, though they are running on the same physical machine, let's say, running 10 containers, 10 different applications, you can be sure that they are well disconnected or well isolated applications. Now let's talk about the advantages of ECS. The advantage of ECS is improved security. Its security is inbuilt in ECS. With ECS, we have something called as a container registry. That's where all your images are stored, and those images are accessed only through HTTPS. Not only that, those images are actually encrypted, and access to those images are allowed and denied through identity and access management policies, IAM. And in other words, let's say two containers running on the same instance. Now one container can have access to S3 and the others, or the rest of the others, are denied access to S3. So that kind of granular security can be achieved through containers when we mix and match the other security products available in Amazon, like IAM, encryption, accessing it using HTTPS. These containers are very cost efficient. Like I've already said, these are lightweight processes, right? We can schedule multiple containers on the same node, and this actually allows us to achieve high density on an EC2 instance. Imagine an EC2 instance that's very less utilized. That's not possible with a container, because you can actually dense or crowd an EC2 instance with more container in it, so to best use those resources. In EC2, straightforward, you can just launch one application. But when we use containers, you can launch like 10 different applications on the same EC2 server. That means 10 different applications can actually feed on those resources available and can benefit the application. And ECS not only deploys the container, it also maintains the state of the containers, and it makes sure that the minimum set of containers are always running based on the requirement. That's another cost efficient way of using it, right? And anytime an application fails, and that has a direct impact on the revenue of the company, and ECS makes sure that you're not losing any revenue because your application has failed. And ECS is a pretty extensible services. It's like this. In many organizations, there are majority of unplanned work because of environment variation. A lot of firefighting happens when we kind of deploy the code from one, or kind of move the code or redeploy the code in a new environment. A lot of firefighting happens there, right? This Docker containers are pretty extensible. Like we discussed already, environment is not a concern for containers because it's going to kind of shut itself inside a Docker container, and anywhere the Docker container can run, the application will run exactly the way it performed in the past. So environment is not a concern for the Docker containers. In addition to that, ECS is easily scalable. We have discussed this already, and it has improved compatibility. We have discussed this already. Let's talk about the architecture of ECS. Like you know now, the architecture of ECS is the ECS cluster itself. That's group of servers running the ECS service, and it integrates with Docker, right? So we have a Docker registry. Docker registry is a repository where we store all the Docker images or the container images. So it's like three components. ECS is of three components. One is the ECS cluster itself. Right? When I say ECS itself, I'm referring to ECS cluster of servers that will run the containers. And then the repository where the images will be stored, right? The repository where the images will be stored, and the image itself. So container image is the template of instructions which is used to create a container, right? So it's like, what's the OS? What is the version of node that should be running? And any additional software do we need? So those questions gets answered here. So it's the template of instructions which is used to create the containers. And then the registry is the service where the Docker images are stored and shared. So many people can store there, and many people can access, or if there's another group that wants to access, they can access the image from there, or one person can store the image and rest of the team can access, and the rest of the team can store image, and this one person can pick the image from there and kind of ship it to the customer or ship it to the production environment. All that's possible in this container registry. And Amazon's version of the container registry is ECR. And there's a third party. Docker itself has a container registry, that's Docker Hub. ECS itself, which is the group of servers that runs those containers. So these two, the container image and the container registry, they kind of handle Docker in an image format, just an image format. And in ECS is where the container gets live, and then it becomes an compute resource and starts to handle requests, starts to serve the page and starts to do the batch job, whatever your plan is with that container. So the cluster of servers, ECS, integrates well with the familiar services like VPC. VPC is known for securing. VPC is known for isolating the whole environment from rest of the customers, or isolating the whole environment or the whole infrastructure from the rest of the clients in your account, or from the rest of the applications in your account, on and on. So VPC is a service that provides or gives you the network isolation. ECS integrates well with VPC. And this VPC enables us to launch AWS resources such as Amazon EC2 instance in a virtual private network that we specify. This is basically what we just discussed. Now let's take a closer look at the ECS. How does ECS work? Let's find answer for this question. How does ECS work? ECS has got a couple of components within itself. So these ECS servers can run across availability zone. As you can see, there are two availability zones here. They can actually run across availability zones. And ECS has got two modes, Fargate mode and the EC2 mode. Right here we're seeing Fargate mode, and then here we're seeing nothing. That means it's an EC2 mode. And then it has got different network interfaces attached to it, because they need to be running in an isolated fashion, right? So anytime you want network isolation, you need separate IP, and if you want separate IP, you need separate network interface card, and that's what you have, Elastic network interface card, separate elastic network interface card for all those tasks and services. And this runs within an VPC. Let's talk about the Fargate service. Tasks are launched using the Fargate service. So we will discuss about tasks. What is Fargate? Now, Fargate is a compute engine in ECS that allows users to launch containers without having to monitor the cluster. ECS is a service that manages the containers for you, right? Otherwise, managing containers will be a full-time job. So ECS manages it for you, and you get to manage ECS. That's the basic service. But if you want Amazon to manage ECS and the containers for you, we can go for Fargate. So Fargate is a compute engine in ECS that allows users to launch containers without having to monitor the ECS cluster. And the tasks that we discussed, the tasks has two components. You see task right here. So they have two components. We have ECS container instance and then the container agent. So like you might have guessed right now, ECS container instance is actually an EC2 instance, right, capable of running containers. Not all EC2 instances can run containers. So these are like specific EC2 instances that can run containers. They are ECS container instances. And then we have container agent, which is the agent that actually binds those clusters together, and it does a lot of other housekeeping work, right? Kind of connects clusters, makes sure that the version needed is present. So it's all part of that agent, or it's all job of that agent. Container instances is part of Amazon EC2 instance, which run Amazon ECS container agent. Pretty straightforward definition. And then a container agent is responsible for communication between ECS and the instance, and it also provides the status of the running containers. Kind of monitors the container, monitors the state of the container, make sure that the container is up and running, and if there's anything wrong, it kind of reports it to the appropriate service to fix the container, on and on. Right? So container agent, when we don't manage container agent, it runs by itself, and you really don't have to do anything to make the container agent better. It's already better. You really won't be configuring anything in the agent. And then Elastic Network Interface Card is a virtual interface network that can be connected to an instance in VPC. So in other words, Elastic Network Interface is how the container interacts with another container, and that's how the container interacts with the EC2 host, and that's how the container interacts with the internet, external world. And a cluster is a set of ECS container instances. It's not something that's very difficult to understand. It's simply a group of EC2 instances that runs that ECS agent. And this cluster handles the process of scheduling, monitoring, and scaling the request. We know that ECS can scale, the containers can scale. How does it scale? That's all monitored and managed by this ECS cluster. Let's talk about the companies that are using Amazon ECS. There are a variety of companies that use ECS clusters. To name a few, Okta uses ECS cluster, and Okta is a product that uses identity information to grant people access to applications on multiple devices at any given point of time. They make sure that they have a very strong security protection. So Okta uses Amazon ECS to run their Okta application and serve their customers. And Abima is a TV channel, and they chose to use microservices and Docker containers. They already had microservices and Docker containers, and when they thought about a service that they can use in AWS, ECS was the only service that they can immediately adapt to. And because in Abima TV the engineers have already been using Docker and Docker containers, it was kind of easy for them to adapt themselves to ECS and start using it, along with the benefits that ECS provides. Previously they had to do a lot of work, but now ECS does it for them. Right? Similarly, Remain and Ubisoft, GoPro are some of the famous companies that use Amazon ECS and get benefited from its scalability, get benefited from its cost, gets benefited from its Amazon managed services, get benefited from the portability that ECS and the migration option that ECS provides. Let's talk about how to deploy a Docker container on Amazon ECS. The way to deploy a Docker container on ECS is, first we need to have an AWS account and then set up and run our first ECS cluster. So in our lab, we're going to use the launch wizard to run an ECS cluster and run containers in them. And then task definition. Task definition tells the size of the container, the number of the container. And when we talk about size, it tells how much of CPU do you need, how much of memory do you need. And talking about numbers, it requires how many numbers of container you're going to launch. Is it 5, is it 10, or is it just 1 running all the time? Now those kind of information goes in the task definition file. And then we can do some advanced configuration on ECS, like load balancers and what port number you want to allow and you don't want to allow, who gets access, who shouldn't get access, and what's the IP that you want to allow and deny requests from, on and on. And this is where we would also mention the name of the container, so to differentiate one container from the other, and the name of the service. Is it an backup job? Is it a web application? Is it an data container? Is it going to take care of your data backend? And the desired number of tasks that you want to be running all the time. Those details go in when we try to configure the ECS service, right? And then you configure cluster. You put in all the security in the configure your cluster step or configure cluster stage. And finally, we will have an instance and bunch of containers running in that instance. All right, let's do a demo. So here I have logged in to my Amazon portal, and let me switch to the appropriate region. I'm going to pick North Virginia. North Virginia, look for ECS. And it tells ECS is a service that helps to run and manage Docker containers. Well and good. Click on it. I'm in North Virginia. Just want to make sure that I'm in the right region. And go to clusters. And here we can create cluster. This is our Fargate, and this is our EC2 type launching for Linux and Windows environment. But I'm going to launch through this walkthrough portal. Right? This gives a lot of information here. So the different steps involved here is creating a container definition, which is what we're going to do right now, and then a task definition, and then a service, and finally the cluster. It's a 4-step process. So in container definition, we define the image, the base image we are going to use. Now here I'm going to launch an HTTPD or a simple HTTP web page, right? So a simple HTTPD 2.4 image is fair enough for me, and it's not a heavy application, so 0.5 gigabit of memory is enough. And again, it's not a heavy application, so 0.25 virtual CPU is enough in our case, right? You can edit it based on the requirement. You can always edit it, and because I'm using HTTPD, the port mapping is already port 80. That's how the container is going to receive the request. And there's no health check as of now. When we want to design critical and complicated environments, we can include health check, right? And this is the CPU that we have chosen. We can edit it, and I'm going to use some bash commands to create an HTML page, right? This page says that Amazon ECS sample app, right? And then it says Amazon ECS sample app. Your application is running on a container in Amazon ECS. So that's the page, the HTML page that I'm going to create, right? Index.html. So I'm going to create and put it in an appropriate location, so those pages can be served from the container, right? If you replace this with any of your own content, then it's going to be your own content. ECS comes with some basic logs, and these are the places where they get stored. That's not the focus as of now. Right, so I was just saying that you can edit it and customize it to your needs. We're not going to do any customization now. We're just getting familiar with ECS now. And the task definition, name of the task definition is first run task definition, and then we are running it in a VPC, and then this is an Fargate mode, meaning the servers are completely handled by Amazon, and the task memory is 0.5 gigabit and the task CPU is 0.25 virtual CPU. Name of the service: is it a batch job? Is it an a front end? Is it a back end? Or is it a simple copy job? What's the service? Name of the service goes here. Again, this you can edit it. And here's our security group. As of now, I'm allowing port 80 to the whole world. If I want to restrict to a certain IP, I can do that. The default option for load balancing is no load balancer, but I can also choose to have a load balancer and use port 80 to map that port 80 to the container port 80, right? I can do that. The default is no load balancer. All right, let's do one thing. Let's use load balancer. Let's use load balancer and port 80 that receives information on port 80, HTTP. What's going to be the cluster name? We're in the last step. What is the cluster name? Cluster name can be Simplilearn ECS demo. Next, we're done and we can create. So it's launching a cluster, as you can see, and it's picking the task definition file that we've created, and it's using that to launch an service. And then these are the log groups that we discussed, and it's creating a VPC. Remember, ECS clubs well with the VPC. It's creating a VPC and it's creating two subnets here for high availability. It's creating that security group, port 80, allowed to the whole world, and then it's putting it behind an load balancer. It generally would take like 5 to 10 minutes, so we just need to be patient and let it complete its creation. And once this is complete, we can simply access these servers using the load balancer URL. And when this is running, let me actually take you to the other products or the other services that are integrated with ECS. It's getting created. Our service is getting created as of now. ECR repository. This is where all our images are stored. Now, as of now, I'm not pulling my image from ECR. I'm pulling it directly from the internet, Docker Hub. But all custom images, they are stored in this repository. So you can create a repository, call it app1, create a repository. So here's my repository. So any image that I create locally, or any Docker image that I create locally, I can actually push those images using these commands right here, and they get stored here. And I can make my ECS connect with ECR and pull images from here. So they would be my custom images. And as of now, because I'm using a default image, it's directly pulling it from the internet. Let's go to EC2 and look for a load balancer, because we wanted to access the application from behind a load balancer, right? So here is a load balancer created for us, and anytime I put the URL, so a cluster is now created. You see there's one service running. All right, let's click on that cluster. Here is the name of our application, and here is the tasks, the different containers that we are running. And if you click on it, we have an IP, right? IP of that container, right? And it says it's running, it was created at such and such time and started at such and such time. And this is the task definition file that this container uses, meaning the template, the details, all the version details, they all come from here, and it belongs to the cluster called Simplilearn ECS demo, right? And you can also get some logs, container logs from here. So let's go back. And there are no ECS instances here, because remember, this is Fargate. You're not managing any ECS instance, right? So that's why you're not seeing any ECS instance here. So let's go back to tasks and go back to the same page where we found the IP. Pick that IP, put it in the browser, and you have this sample HTML page running from an container. So let me go back to load balancer, EC2, and then under EC2 I'll be able to find a load balancer, find that load balancer, pick that DNS name, put it in the browser, and now it's accessible through the load balancer URL. Right now this URL can be mapped to other services like DNS. This URL can be embedded.
Hi guys, today we've got something very special in store for you. We're going to talk about the best cloud computing platform available, Amazon Web Services.
Rahul, I think you said something wrong here. The best cloud computing platform is obviously Google Cloud Platform.
No, it isn't. AWS has more than 100 services that span a variety of domains.
Alright, but Google Cloud Platform has cheaper instances. What do you have to say about that?
Well, I guess there's only one place we can actually discuss this. A boxing ring.
So guys, I'm Apeksha and I will be Google Cloud Platform.
And I'm Rahul, I'll be AWS.
So welcome to Fight Night.
This is AWS versus GCP. The winner will be chosen on the basis of their origin and the features they provide, their performance in the present day, and comparing them on the basis of pricing, market share and options, the things they give you for free, and instance configuration. Now first let's talk about AWS. AWS was launched in 2004 and is a cloud service platform that helps businesses grow and scale by providing them services in a number of different domains. These domains include compute, database, storage, migration, networking, and so on. A very important aspect about AWS is its years of experience. Now AWS has been in the market a lot longer than any other cloud service platform, which means they know how businesses work and how they can contribute to the business growing. Also, AWS has over $5.1 billion of revenue in the last quarter. This is a clear indication of how much faith and trust people have in AWS. They occupy more than 40% of the market, which is a significant chunk of the cloud computing market. They have at least 100 services that are available at the moment, which means just about every issue that you have can be solved with an AWS service.
Now that was great, but now can we talk about GCP? I hope you know that GCP was launched very recently in 2011 and it is already helping businesses significantly with a suite of intelligent, secure and flexible cloud computing services. It lets you build, deploy and scale applications, websites, services on the same infrastructure as Google. The intuitive user experience that GCP provides with dashboards, wizards is way better in all the aspects. GCP has just stepped in the market and it is already offering a modest number of services. And the number is rapidly increasing. And the cost for a CPU instance or regional storage that GCP provides is a whole lot cheaper. And you also get a multi-regional cloud storage. Now what do you have to say on that?
I'm so glad you asked. Let's look at present day. In fact, let's look at the cloud market share of the fourth quarter of 2017. This will tell you once and for all that AWS is the leader when it comes to cloud computing. Amazon Web Services contributes 47% of the market share. Others like Rackspace or Verizon Cloud contribute 36%, Microsoft Azure contributes 10%, the Google Cloud Platform contributes 4%, and IBM Software contributes 3%. 47% of the market share is contributed by AWS. Do you need me to convince you any more?
Wait. All that is fine, but we only started a few years back and have already grown so much in such a less span of time. Haven't you heard the latest news? Our revenue is already $1 billion per quarter. Wait for a few more years and the world shall see.
And AWS makes $5.3 billion per quarter. It's going to take a good long time before you can even get close to us.
Yes, we'll see.
Now, let's compare a few things. For starters, let's compare pricing. For AWS, a compute instance of 2 CPUs and 8 GB RAM costs approximately $68 US. Now, a compute instance is a virtual machine in which you can specify what operating system, RAM, or storage you want to have. For cloud storage, it costs 2.3 cents per GB per month with AWS.
You really want to do that? Because GCP wins this hands down. Let's take the same compute instance of 2 CPUs with 8 GB RAM. It will cost approximately $50 per month with GCP. And as per my calculations, that's a 25% annual cost reduction when compared to AWS. Talking about cloud storage costs, it is only 2 cents per GB per month with GCP. What else do you want me to say?
Let's talk about market share and options. Now, AWS is the current market leader when it comes to cloud computing. Now, as you remember, we contribute at least 47% of the entire market share. AWS also has at least 100 services available at the moment, which is a clear indication of how well AWS understands businesses and helps them grow.
Yeah, that's true, but you should also know that GCP is steadily growing. We have over 60 services that are up and running, as you can see here, and a lot more to come. It's only a matter of time when we will have as many services as you do. Many companies have already started adopting GCP as their cloud service provider.
Now, let's talk about things you get for free. With AWS, you get access to almost all the services for an entire year with usage limits. Now, these limits include an hourly or by-the-minute basis. For example, with Amazon EC2, you get 750 hours per month. You also have limits on the number of requests to services. For example, with AWS Lambda, you have 1 million requests per month. Now, after these limits are crossed, you get charged standard rates.
With GCP, you get access to all cloud platform products like Firebase, the Google Maps API, and so on. You also get $300 in credit to spend over a 12-month period on all the cloud platform products. And interestingly, after the free trial ends, you won't be charged unless you manually upgrade to a paid account. Now, there is also the always free version for which you will need an upgraded billing account. Here, you get to use a small instance for free and 5 GB of cloud storage. Any usage above this always free usage limits will be automatically billed at standard rates.
Now let's talk about how you can configure instances. With AWS, the largest instance that's offered is of 128 CPUs and 4 TBs of RAM. Now, other than the on-demand method like I mentioned before, you can also use spot instances. Now, these are for situations where your application is more fault tolerant and can handle an interruption. Now, you pay for the spot price, which is effective at a particular hour. Now, these spot prices do fluctuate but are adjusted over a period of time.
The largest instance offered with Google Cloud is 160 CPUs and 3.75 TBs RAM. Like spot instances of AWS, Google Cloud offers short-lived compute instances suitable for batch jobs and fault-tolerant workloads. They are called as preemptible instances. So these instances are available at 80% off on-demand price. Hence, they reduce your compute engine costs significantly. And unlike AWS, these come at a fixed price. Google Cloud Platform is a lot more flexible when it comes to instance configuration. You simply choose your CPU and RAM combination. Of course, you can even create your own instance types this way. Before we wrap it up, let's compare on some other things as well. Telemetry. It's a process of automatically collecting periodic measurements from remote devices. For example, GPS. GCP is obviously better because they have superior telemetry tools which help in analyzing services and providing more opportunities for improvement.
When it comes to application support, AWS is obviously better since they have years of experience under their belt. AWS provides the best support that can be given to the customers.
Containers are better with GCP. A container is a virtual process running in user space. As Kubernetes was originally developed by Google, GCP has full native support for the tool. Other cloud services are just fine-tuning a way to provide Kubernetes as a service. Also, the containers help with abstracting applications from their environment they originally run in. The applications can be deployed easily regardless of their environment.
When it comes to geographies, AWS is better since they have a head start of a few years. AWS in this span of time has been able to cover a larger market share and geographical locations. Now, it's time for the big decision. So, who's it going to be?
Yeah, who is it going to be? GCP or AWS?
I think I'm going to go for choosing the right cloud computing platform is a decision that's made on the basis of the user or the organization's requirement. On that note, I believe it's time for us to wrap this video up.
We hope you guys enjoyed this video and learned something new.
That AWS is better, right?
No, that choosing a platform entirely depends on you and your organization's requirement. If you're interested, you could also go through the AWS versus Azure video.
AWS, Azure and GCP are three of the world's largest cloud service providers. But how are they different from each other? Let's find out. Hey guys, I'm Rahul and I'll be representing Amazon Web Services.
I'm Chinmayi and I'll be representing Microsoft Azure.
And I'm Shruti and I'll be representing Google Cloud Platform. So welcome to this video on AWS versus Azure versus GCP.
Talking about market share, Amazon Web Services leads with around 32% of the worldwide public cloud share.
Azure owns up to 16% of the worldwide market share.
And GCP owns around 9% of the world's market share.
Let's talk about each of these service providers in detail. AWS provides services that enable users to create and deploy applications over the cloud. These services are accessible via the internet. AWS, being the oldest of the lot, was launched in the year 2006.
Azure, launched in 2010, is a computing platform that offers a wide range of services to build, manage, and deploy applications on the network using tools and frameworks.
Launched in the year 2008, GCP offers application development and integration services for its end users. In addition to cloud management, it also offers services for big data, machine learning, and IoT.
Now let's talk about availability zones. These are isolated locations within data center regions from which public cloud services originate and operate. Talking about AWS, they have 69 availability zones within 22 geographical regions. This includes regions in the United States, South America, Europe, and Asia Pacific. They are also predicted to have 12 more additions in the future.
Azure, available in 140 countries, has over 54 regions worldwide grouped into 6 geographies. These geographical locations have more than 100 data centers.
GCP is available in 200 plus countries across the world. As of today, GCP is present in 61 zones and 20 regions, with Osaka and Zurich being the newly added regions.
Now let's talk about pricing. These services follow the pay-as-you-go approach. You pay only for the individual services you need for as long as you use them without requiring long-term contracts or complex licensing. Now on screen, you can see the pricing for each of these cloud service providers with respect to various instances like general purpose, compute optimized, memory optimized, and GPU. Now let's talk about the compute services offered. First off, we have virtual servers. For AWS, we have EC2. It is a web service which eliminates the need to invest in hardware so that you can develop and deploy applications in a faster manner. It provides virtual machines in which you can run your applications.
Azure's virtual machines is one of the several types of computing resources that Azure offers. Azure gives the user the flexibility to deploy and manage a virtual environment inside a virtual network.
GCP's VM service enables users to build, deploy, and manage virtual machines to run workloads on the cloud.
Now let's talk about the pricing of each of these services. AWS EC2 is free to try. It is packaged as part of AWS's free tier that lasts for 12 months and provides 750 hours per month of both Linux and Windows virtual machines.
Azure Virtual Machine Service is a part of the free tier that offers this service for about 750 hours per month for a year. The user gets access to Windows and Linux virtual machines.
GCP's VM service is a part of a free tier that includes micro-instance per month for up to 12 months.
Now let's talk about Platform as a Service or PaaS services. For AWS, Elastic Beanstalk is an easy-to-use service for deploying and scaling web applications and services developed with Java, .NET, Node.js, Python, and much more. It is used for maintaining capacity, provisioning, load balancing, auto-scaling, and application health monitoring.
The PaaS backbone utilizes virtualization techniques where the virtual machine is independent of the actual hardware that hosts it. Hence, the user can write application code without worrying about the underlying hardware.
Google App Engine is a cloud computing platform as a service which is used by developers for hosting and building apps in Google data centers. The App Engine requires the apps to be written in Java or Python and store data in Google Bigtable and use the Google query language for this.
Next, let's talk about virtual private server services. AWS provides Lightsail. It provides everything you need to build an application or a website along with the cost-effective monthly plan and minimum number of configurations.
In simple words, VM image is a more comprehensive image for Microsoft Azure virtual machines. It helps the user create many identical virtual machines in a matter of minutes.
Unfortunately, GCP does not offer any similar service.
Next up, we have serverless computing services. AWS has Lambda. It is a serverless compute service that lets you run your code without facilitating and managing servers. You only pay for the compute time you use. It is used to execute backend code and scales automatically when required.
Azure Functions is a serverless compute service that lets you run event-triggered code without having to explicitly provision or manage infrastructure. This allows the users to build applications using serverless simple functions with the programming language of their choice.
GCP Cloud Functions make it easy for developers to run and scale code in the cloud and build event-driven serverless applications. It is highly available and fault-tolerant.
Now let's talk about storage services offered by each of these service providers. First off, we have object storage. AWS provides S3. It is an object storage that provides industry standard scalability, data availability, and performance. It is extremely durable and can be used for storing as well as recovering information or data from anywhere over the internet.
Blob storage is an Azure feature that lets developers store unstructured data in Microsoft's cloud platform. Along with storage, it also offers scalability. It stores the data in the form of tiers depending on how often data is being accessed.
Google Cloud Storage is an online storage web service for storing and accessing data on Google Cloud Platform infrastructure. Unlike the Google Drive, Google Cloud Storage is more suitable for enterprises. It also stores objects that are organized into buckets.
Amazon provides EBS or Elastic Block Store. It provides high-performance block storage and is used along with EC2 instances for workloads that are transaction or throughput intensive.
Azure Managed Disk is a virtual hard disk. You can think of it like a physical disk in an on-premises server but virtualized. These managed disks allow the users to create up to 10,000 VM disks in a single subscription.
Persistent storage is a data storage device that retains data after power to the device is shut off. Google Persistent Disk is durable and high-performance block storage for GCP. Persistent Disk provides storage which can be attached to instances running in either Google Compute Engine or Kubernetes Engine.
Next up, we have disaster recovery services. AWS provides a cloud-based recovery service that ensures that your IT infrastructure and data are recovered while minimizing the amount of downtime that could be experienced.
Site recovery helps ensure business continuity by keeping business apps and workloads running during outages. It allows recovery by orchestrating and automating the replication process of Azure virtual machines between regions.
Unfortunately, GCP has no disaster recovery service.
Next, let's talk about database services. First off, for AWS, we have RDS or Relational Database Service. It is a web service that's cost-effective and automates administration tasks. Basically, it simplifies the setup, operation, and scaling of a relational database.
Microsoft Azure SQL Database is a software as a service platform that includes built-in intelligence that learns app patterns and adapts to maximize performance, reliability, and data protection. It also eases the migration of SQL Server databases without changing the user's applications.
Cloud SQL is a fully managed database service which is easy to set up, maintain, and administer relational PostgreSQL, MySQL, and SQL Server databases in the cloud. Hosted on GCP, Cloud SQL provides a database infrastructure for applications running anywhere.
Next, we have NoSQL database services. AWS provides DynamoDB, which is a managed, durable database that provides security, backup and restore, and in-memory caching for applications. It is well known for its low latency and scalable performance.
Azure Cosmos DB is Microsoft's globally distributed multi-model database service. It natively supports NoSQL created for low latency and scalable applications.
GCP Cloud Data Store is a NoSQL database service offered by Google on the GCP. It handles replication and scales automatically to your application's load. With Cloud Data Store's interface, data can easily be accessed by any deployment target.
Now let's talk about the key cloud tools for each of these service providers. For AWS, in networking and content delivery, we have AWS Route 53 and AWS CloudFront. For management, we have AWS CloudWatch and AWS CloudFormation. For development, we have AWS CodeStart and AWS CodeBuild. For security, we have IAM and Key Management Service.
For Microsoft Azure, networking and content delivery, we have Content Delivery Network and ExpressRoute. For management tools, we have Azure Advisor and Network Watcher. For development tools, for management, we have Azure Advisor and Network Watcher. For development, we have Visual Studio IDE and Azure Blob Studio. For security, we have Azure Security Center and Azure Active Directory.
For GCP, we have the following tools. For networking and content delivery, we have Cloud CDN and Cloud DNS. For management, we have Stackdriver and GCP monitoring. For development, we have Cloud Build and Cloud SDK. And finally, for security, we have Google Cloud IAM and Google and Cloud Security Scanner.
Now let's talk about the companies using these cloud providers. For AWS, we have Netflix, Unilever, Kellogg's, NASA, Nokia, and Adobe.
Pixar, Samsung, eBay, Fujitsu, EMC, and BMW, among others, use Microsoft Azure.
So as seen on your screens, the companies that use GCP are Spotify, HSBC, Snapchat, Twitter, PayPal, and 20th Century Fox.
Let's talk about the advantages of each of these services. Amazon provides enterprise-friendly services. You can leverage Amazon's 15 years of experience delivering large-scale global infrastructure, and it still continues to hone and innovate its infrastructure management skills and capabilities. Secondly, it provides instant access to resources. AWS is designed to allow application providers, ISVs, and vendors to quickly and securely host your applications, whether an existing application or a new SaaS-based application. Speed and agility. AWS provides you access to its services within minutes. All you need to select is what you require and you can proceed. You can access each of these applications anytime you need them. And finally, it's secure and reliable. Amazon enables you to innovate and scale your application in a secure environment. It secures and hardens your infrastructure. More importantly, it provides security at a cheaper cost than on-premise environments.
Now talking about some of the advantages of Azure. Microsoft Azure offers better development operations. It also provides strong security profile. Azure has a strong focus on security, following the standard security model of detect, assess, diagnose, stabilize, and close. Azure also provides a cost-effective solution. The cloud environment allows businesses to launch both customer applications and internal apps in the cloud, which saves on IT infrastructure costs. Hence, it's OpEx friendly.
Let's now look at the advantages of GCP. Google bills in minute-level increments, so you only pay for the compute time you use. They also provide discounted prices for long-running workloads. For example, you use the VM for a month and get a discount. GCP also provides live migration of virtual machines. Live migration is the process of moving a running VM from one physical server to another without disrupting its availability to the users. This is a very important differentiator for Google Cloud compared to other cloud providers. GCP provides automatic scalability. This allows a site's container scale to as many CPUs as needed. Google Cloud Storage is designed for 99.9% durability. It creates server backup and stores them in a user-configured location.
Let's talk about the disadvantages of each of these services. For AWS, there's a limitation of the EC2 service. AWS provides limitations on resources that vary from region to region. There may be a limit to the number of instances that can be created. However, you can request for these limits to be increased. Secondly, they have a technical support fee. AWS charges you for immediate support, and you can opt for any of these packages. Developer, which costs $29 per month, Business, which costs more than $100, and Enterprise, that costs more than $15,000. It has certain network connectivity issues. It also has general issues when you move to the cloud, like downtime, limited control, backup protection, and so on. However, most of these are temporary issues and can be handled over time.
Talking about some of the disadvantages of Microsoft Azure. Codebase is different when working offline, and it requires modification when working on the cloud. PaaS ecosystem is not as efficient as IaaS. Azure Management Console is frustrating to work with. It is slow to respond and update and requires far too many clicks to achieve simple tasks. Azure Backup is intended for backing up and restoring data located on your on-premises servers to the cloud. That's a great feature, but it's not really useful for doing bare metal restores of servers in a remote data center.
Let's now look into the disadvantages of GCP. So when it comes to cloud providers, the support fee is very minimal, but in the case of GCP, it is quite costly. It is around $150 per month for the most basic service. Similar to AWS S3, GCP has a complex pricing schema. Also, it is not very budget-friendly when it comes to downloading data from Google Cloud Storage.
Also, if you want to master the field of cloud computing, the postgraduate program in cloud computing, designed in collaboration with Caltech CTME, helps you become an Azure, AWS, and GCP expert. This in-depth cloud computing certification course lets you master key architectural principles and develop the skills needed to become a cloud expert. Benefits of this postgraduate program includes Caltech CTME Postgraduate Certificate, enrollment in Simplilearn's JobAssist. You will receive up to 30 CEUs from Caltech CTME. You will attend masterclasses from Caltech CTME instructors, live virtual classes led by industry experts, hands-on projects and integrated labs, online convocation by Caltech CTME Program Director, 40 plus hands-on projects and integrated labs, capstone project in 4 different domains, and Caltech CTME Circle membership. You can also fast-track your career with this cloud computing certification and its in-depth course curriculum, which covers the key concepts of Microsoft Azure, Amazon Web Services, and Google Cloud Platforms, and services such as AWS Lambda, Amazon S3, Azure App Services, and many more. So this program also covers the essential skills to become an expert in cloud computing, and you can consider this program because it provides you with a certification from Caltech CTME, a well-reputed university in the United States. So what are you waiting for? Check out the link mentioned in the description box below and start your cloud computing career today. So without any further delay, let's get started.
AWS Certifications. So what exactly is an AWS certification? It represents a degree of expertise in AWS. It is obtained after passing one or more exams provided by Amazon, and each different role, like the SysOps administrator, developer, or solutions architect, has a different exam associated with it. This in turn helps employees demonstrate and validate technical cloud knowledge, which means that the people who are certified actually know what they're talking about. I have seen a common misconception among people where they believe that just because they're certified, they're entitled to a job. That's not true. Now, without proper practice or hands-on experience, the certification is wasted on you. So remember, just because you're certified does not mean you'll get a job. It only makes the job application process slightly easier relative to someone who's not been certified. Now, why is AWS given so much importance? Some of the important reasons are: an AWS certified individual gains credibility for their skills in AWS. They also gain access to free practice exams which help them prepare for the next AWS certification. There's an increase in monetary compensations, which only means that they get paid more, and you gain recognition for your knowledge and skills in AWS. Right now we're in the AWS certification website, whose link will be in the description, and now we're going to talk about the types of AWS certification. As you can see here, there are 3 levels of AWS certification. There's the foundational level, associate level, and professional level certification. Now the foundational level certification only requires you to have a basic understanding of how the AWS cloud works. The AWS Certified Cloud Practitioner is optional for the architect path, developer path, and operations path. It is mandatory for the specialty certifications like the advanced networking, big data, and security certifications. Now the associate level certifications are mid-level certifications for a technical role. Now, a professional certification is the highest level of certification that you can have for a technical role. Now, you have the solutions architect for the architect path and the DevOps engineer certification for both the developer and operations path. So how do you decide which of these certifications is suitable for you? So you've seen here that AWS provides various certifications for a number of job roles like SysOps administrator, solution architect, developer. So you need to make the right choice, taking into consideration the areas of your interest and the experience level that you have. Now we're going to talk about each of these certifications in detail. So first, let's talk about the AWS Certified Cloud Practitioner. Now we all understand that AWS is a widely recognized product in the market. So this certification helps you validate how well you know the AWS cloud. So this is just the basic understanding. Now, it is optional for the developer path and the operations path. I would suggest it's a good idea to start here because it forms a solid bedrock on all the other things that you're going to learn soon. Now, more importantly, it does not require any technical knowledge of other roles such as development, architecture, administration, and so on. So it's a great place to start for newcomers. Now you have the architect role certifications. Now, this is for you if you're interested in becoming a solutions architect or a solution design engineer or someone who just works with designing applications or systems on the AWS platform. Now, first we have the AWS Certified Solutions Architect Associate Level Certification. Now, this certification is for you if you want to show off how well you can architect and deploy applications on the AWS platform. Now, it is recommended that you have at least a year of experience working with distributed systems on the AWS platform. At the same time, it's also required that you understand the AWS services and be able to recommend a service based on requirements. You need to be able to use architectural best practices, and you need to estimate the AWS cost and how you can reduce them. Next up, you have the AWS Certified Solutions Architect Professional Level Certification. Now, you will not get this certification unless you're done with the AWS Certified Solutions Architect Associate Level Certification. This is to show off your technical skills and experience in designing distributed applications on the AWS platform. Now, this does require you to have 2 years of experience working with cloud architecture on AWS. At the same time, it also requires you to be able to evaluate requirements and then make architectural recommendations. You also need to provide guidance on the best practices on architectural design across a number of different platforms. The developer level certifications are for you if you're interested in becoming a software developer. Now, the AWS Certified Developer Associate certification is to test how well you know how to develop and maintain applications on the AWS platform. It does require you to have a year or more of hands-on experience to design and maintain AWS-based applications. Like any software developer role, it is necessary that you know in depth at least one high-level programming language. It's also necessary that you understand the core of AWS services, uses, and basic architectural best practices. You need to be able to design, develop, and deploy cloud-based solutions on AWS platform, and you need to understand how applications can be created. You need to have experience in developing and maintaining applications for a number of AWS services like Amazon SNS, DynamoDB, SQS, and so on. Now for the AWS Certified DevOps Engineer Professional Level Certification. Note here that this certification is exactly the same as the one you have under the operations role. So both of them are the same thing. So here it tests your ability to create, operate, and manage distributed applications on the AWS platform. Now it is necessary or it is mandatory to have the AWS Certified Developer Associate certification or the AWS Certified SysOps Administrator certification with 2 or more years of hands-on experience in doing the same in AWS environment. It requires you to be able to develop code in at least one high-level language. You need to be able to automate and test applications via scripting and programming, and to understand agile or other development processes. The operation certifications are for you if you want to become a SysOps administrator, systems administrator, or someone in a DevOps role who wants to deploy applications, networks, and systems in an automatable and repeatable way. The AWS Certified SysOps Administrator Associate certification tests your knowledge in deployment, management, and operations on the AWS platform. Now, you need to have 1 or more years of hands-on experience in AWS-based applications. You need to be able to identify and gather requirements, then define a solution to be operated on AWS. You need to be able to provide guidance for the best practices through the life cycle of a project as well. Now, the specialty certifications are for you if you're well versed in AWS and want to showcase your expertise in other technical areas. The AWS Certified Big Data Certification showcases your ability to design and implement AWS services which can help derive value from a large amount of complex data. You are, however, required to have completed the foundational or associate level certification before you can attempt this. You need a minimum of 5 years of hands-on experience in the data analytics field as well. Next, we have the AWS Certified Advanced Networking Certification. This validates your ability to design and implement AWS solutions as well as other hybrid IT network architectures at scale. This also requires you to have completed the foundational or associate level certification. You need to have a minimum of 5 years of hands-on experience architecting and implementing network solutions. And lastly, we have the AWS Certified Security Certification. It helps showcase your ability to secure the AWS platform. You're required to have an associate or cloud practitioner level of certification, a minimum of 5 years of IT security experience, and 2 years of hands-on experience securing AWS workloads. Now, say I wanted to schedule an examination. So, for example, I want to do the Solutions Architect certification. So first I would go there. Now, here I can click on Register Now and the process continues, or I can click on Learn More. By doing this, again, I can schedule the examination here. I can also get access to other data like the number of questions available, the cost of an examination, the portions I need to study, and so on. Now let's talk about the Solutions Architect certification with a little more detail. Now this certification exam costs $150 and the practice exam costs $20. Now here I can schedule the examination or download the exam guide. I've already downloaded the exam guide and here it is. Now this exam guide tells you about what you need to learn and what is expected from you. Here they want you to define a solution based on requirements and provide guidance in its implementation. It is also recommended that you know about how the AWS services work, 1 year of hands-on experience with distributed systems on AWS to identify and define technical requirements and so on. The rest is available in the exam guide. And most importantly, they tell you the main content domains and their weightages. Now we have 5 domains. First domain is to design resilient architectures, which holds 34% of weightage. At domain 2, you have to define performant architectures. 3 is to specify secure applications and architectures, cost-optimized architectures, and 5 to define operationally excellent architectures. Now, like you've seen here, you've selected one certification and learned it in detail. You can do the same for any of these other certifications. You can press Learn More and download their exam guide and learn everything that you need to know.
There are over 18 million jobs in the field of cloud computing globally. Simplilearn's AWS Certified Solution Architect Associate Level course will help you understand the key concepts required to prepare for the certification exam. The practice assignments and the 3 live projects, this course comprises of 24 hours of instructor-led training, 15 hours of e-learning, over 50 demonstrations to understand architecting through the AWS console, and you will also be provided with 3 question sets totaling 180 questions. The worldwide cloud computing market grew 28% to $110 billion in revenues in 2015. In the last quarter of 2015, AWS revenue was up 69% year on year. AWS Solutions Architect Associate Level is the perfect certification to start your journey with AWS. You'll enhance your existing knowledge of AWS and will deepen your understanding of every product and service that AWS offers. You will learn how to design, plan, and scale in the AWS cloud using Amazon recommended best practices. With the certification, you'll be an asset to any organization, helping it to leverage the benefits of best practices around advanced cloud-based solutions and migrate existing workloads to the cloud. Whether you're looking to future-proof your career or just prove your know-how about the leading cloud provider in the global market, becoming an AWS Solutions Architect Associate will put you well on your way to achieving your career goals. You can reach out to our teaching assistant support staff anytime during the course and for assistance with projects. Candidates can submit their queries at Help and Support on our website, or they can get connected with our staff using SimplyTalk and the live chat options. This concludes the course introduction, and we hope you're all geared up to begin the AWS Solutions Architect Associate Level course.
Also, if you want to master the field of cloud computing, the postgraduate program in cloud computing, designed in collaboration with Caltech CTME, helps you become an Azure, AWS, and GCP expert. This in-depth cloud computing certification course lets you master key architectural principles and develop the skills needed to become a cloud expert. Benefits of this postgraduate program includes Caltech CTME Postgraduate Certificate, enrollment in Simplilearn's JobAssist. You will receive up to 30 CEUs from Caltech CTME. You will attend masterclasses from Caltech CTME instructors, live virtual classes led by industry experts, hands-on projects and integrated labs, online convocation by Caltech CTME Program Director, 40 plus hands-on projects and integrated labs, capstone project in 4 different domains, and Caltech CTME Circle membership. You can also fast-track your career with this cloud computing certification and its in-depth course curriculum, which covers the key concepts of Microsoft Azure, Amazon Web Services, and Google Cloud Platforms, and services such as AWS Lambda, Amazon S3, Azure App Services, and many more. So this program also covers the essential skills to become an expert in cloud computing, and you can consider this program because it provides you with a certification from Caltech CTME, a well-reputed university in the United States. So what are you waiting for? Check out the link mentioned in the description box below and start your cloud computing career today. So without any further delay, let's get started.
So in an environment where there is a lot of automation, infrastructure automation, you'll be posted with this question: how can you add an existing instance to a new autoscaling group? Now this is when you are taking an instance away from the autoscaling group to troubleshoot, to fix a problem, to look at logs, or if you have suspended the autoscaling, you might need to re-add that instance to the autoscaling group. Only then it's going to take part in it. Right? Only then the autoscaling is going to count it as part of it. It's not a straight procedure. When you remove them, it doesn't get automatically re-added. And I've had worked with some clients when their developers were managing their own environment, they had problems adding the instance back to the autoscaling group. Irrespective of what they tried, the instance was not getting added to the autoscaling group, and whatever they fix that they were provided, or whatever fix that they have provided, were not getting counted in the autoscaling group. So like I said, it's not a straight a click button procedure. There are ways we'll have to do it. So how can you add an existing instance to the autoscaling group? There are a few steps that we need to follow. So the first one would be to, under the EC2 instance console, right, under the instance, under actions in specific, there's an option called attach to autoscaling group. Right? If you have multiple autoscaling groups in your account or in the region that you're working in, then you're going to be posted with the different autoscaling groups that you have in your account. Let's say you have 5 autoscaling groups for 5 different applications. You're going to be posted with 5 different autoscaling groups, and then you would select the appropriate autoscaling group and attach the instance to that particular autoscaling group. While adding to the autoscaling group, if you want to change the instance type, that's possible as well. Sometimes when you want to add the instance back to the autoscaling group, there would be requirement that you change the instance type to a better one, to a better family, to the better instance type. You could do that at that time. And after that, you have completely added the instance back to the autoscaling group. So it's actually a 7-step process, adding an instance back to the autoscaling group. In an environment where they're dealing with migrating the instance, or migrating an application, or migrating an instance, migrating an VM into the cloud, if the project that you're going to work with deals with a lot of migrations, you could be posted this question: what are the factors you will consider while migrating to Amazon Web Services? The first one is cost. Is it worth moving the instance to the cloud? Given the additional bells and whistles features available in the cloud, is this application going to use all of them? Is moving into the cloud beneficial to the application in the first place? Beneficial to the users who will be using the application in the first place. So that's a factor to think of. So this actually includes cost of the infrastructure and the ability to match the demand and supply transparency. Is this application in high demand? Is it going to be a big loss if the application becomes unavailable for some time? So there are a few things that needs to be considered before we move the application to the cloud. And then if the application needs to be provisioned immediately? Is there an urge? Is there an urge to provision the application immediately? That's something that needs to be considered. If the application requires to go online, if the application needs to hit the market immediately, then we would need to move it to the cloud, because in on-premises procuring or buying an infrastructure, buying the bandwidth, buying the switch port, buying an instance, buying the softwares, buying the license related to it, it's going to take time, at least like 2 weeks or so, before you can bring up an server and launch an application in it, right? So if the application cannot wait, waiting means workforce productivity loss, is it? So we would want to immediately launch instances and put application on top of it. In those cases, if your application is of that type, if there is an urge in making the application go online as soon as possible, then that's a candidate for moving to the cloud. And if the application, or if the software, or if the product that you're launching, it requires hardware, it requires an updated hardware all the time, that's not going to be possible in on-premises. We try to deal with legacy infrastructure all the time in on-premises, but in the cloud, they're constantly upgrading their hardwares. Only then they can keep themselves up going in the market. So the cloud providers are constantly updating their hardwares. And if you want to be benefited, or if your application wants to be benefited by the constant upgrading of the hardwares, making sure the hardware is as latest as possible, the software version, the licensing is as latest as possible, then that's a candidate to be moved to the cloud. And if the application does not want to go through any risk, if the application is very sensitive to failures, if the application is very much tagged to the revenue of the company, and you don't want to take a chance in seeing the application fail and seeing the revenue drop, then that's a candidate for moving to the cloud. And business agility, moving to the cloud, at least half of the responsibility is now taken care by the provider. In this case, it's Amazon. At least half of the responsibility is taken care by them. Like if the hardware fails, Amazon makes sure that they're fixing the hardware immediately. And notifications, if something happens, there are immediate notifications available that we can set it up and make ourselves aware that something has broken, and we can immediately jump in and fix it. So you see, the responsibility is now being shared between Amazon and us. So if you want to get that benefit for your application, for your organization, for the product that you're launching, then it needs to be moved to the cloud so you can get that benefit from the cloud. The other question you could get asked is, what is RTO and RPO in AWS? They are essentially disaster recovery terms. When you're planning for disaster recovery, you cannot avoid planning disaster recovery without talking about RTO and RPO. Now, what's the RTO? What's the RPO in your environment? Or how do you define RTO? How do you define RPO? Are some general questions that get asked. RTO is recovery time objective. RTO stands for the maximum time the company is willing to wait for the recovery to happen, or for the recovery to finish when a disaster strikes. So RTO is in the future, right? How much time is it going to take to fix and bring everything to normal? So that's RTO. On the other hand, RPO is recovery point objective, which is the maximum amount of data loss your company is willing to accept as measured in time. RPO always refers to the backups, the number of backups, the frequency of the backups, right? Because when an outage happens, you can always go back to the latest backup, right? And if the latest backup was before 12 hours, you have lost the in-between 12 hours of data storage, right? So RPO is the acceptable amount. If the company wants less RPO is 1 hour, then you should be planning on taking backups every 1 hour. If RPO is 12 hours, then you should be planning on taking backups every 12 hours. So that's how RPO and RTO helps disaster recovery. The fourth question you could get asked is, if you'd like to transfer huge amount of data, which is the best option among Snowball, Edge, and Snowmobile? Again, this is a question that gets asked if the company is dealing with a lot of data transfer into the cloud, or if the company is dealing with migrating data into the cloud. I'm talking about a huge amount of data in petabytes. Snowball, and all of the Snowball series deals with petabyte-sized data migrations. So there are three options available as of now. AWS Snowball is an data transport solution for moving high volume of data into and out of a specified AWS region. On the other hand, AWS Snowball Edge adds additional computing functions. Snowball is simple storage and movement of data, and Snowball Edge has a compute function attached to it. Snowmobile, on the other hand, is an exabyte scale migration service that allows us to transfer data up to 100 petabytes. That's like 100,000 terabytes. So depending on the size of data that we want to transfer from our data center to the cloud, we can rent any of these three services. Let's talk about some CloudFormation questions. This is a classic question. How is AWS CloudFormation different from AWS Elastic Beanstalk? From the surface, they both look like the same. You don't go through the console provisioning resources. You don't go through CLI and provision resources. Both of them provision resources through click button. Right? But underneath, they are actually different services. They aid different services. So knowing that is going to help you understand this question a lot better. Let's talk about the difference between them, and this is what you will be explaining to the interviewer or the panelist. So the CloudFormation service helps you describe and provision all the infrastructure resources in the cloud environment. On the other hand, Elastic Beanstalk provides an simple environment to which we can deploy and run application. CloudFormation gives us an infrastructure, and Elastic Beanstalk gives us a small contained environment in which we can run our application. And CloudFormation supports the infrastructure needs of many different types of application, like the enterprise application, the legacy applications, and any new modern application that you want to have in the cloud. On the other hand, the Elastic Beanstalk, it's a combination of developer tools. They are tools that helps manage the lifecycle of a single application. So CloudFormation, in short, is managing the infrastructure as a whole, and Elastic Beanstalk, in short, is managing and running an application in the cloud. And if the company that you're getting hired is using CloudFormation to manage their infrastructure, or if they're using infrastructure or any of the infrastructure as a code services, then you would definitely face this question: what are the elements of an AWS CloudFormation template? So it has 4 or 5 basic elements, right? And the template is in the form of JSON or in YAML format. Right, so it has parameters, it has outputs, it has data, it has resources, and then the format or the format version or the file format version for the CloudFormation template. So parameter is nothing but it actually lets you to specify the type of EC2 instance that you want, the type of RDS that you want, right? So EC2 is an umbrella, RDS is an umbrella, and parameters within that EC2 and parameters within that RDS are the specific details of the EC2 or the specific details of the RDS service. So that's what parameters in a CloudFormation template. And then the element of the CloudFormation template is outputs. For example, if you want to output the name of an S3 bucket that was created, if you want to output the name of the EC2 instance, if you want to output the name of some resources that have been created, instead of looking into the template, instead of navigating through in the console and finding the name of the resource, we can actually have them outputted in the result section. So you can simply go and look at all the resources created through the template in the output section, and that's what output values or output does in the CloudFormation template. And then we have resources. Resources are nothing but what defines what are the cloud components or cloud resources that will be created through this CloudFormation template. Now, EC2 is a resource, RDS is a resource, and S3 bucket is a resource, Elastic Load Balancer is a resource, and NAT Gateway is a resource, VPC is a resource. So you see, all these components are the resources, and the resource section in the CloudFormation defines what are the AWS Cloud resources that will be created through this CloudFormation template. And then we have a version. A version actually identifies the capabilities of the template. We just need to make sure that it is of the latest version type, and the latest version is 0909 2010. That's the latest version number. You'll be able to find that on the top of the CloudFormation template, and that version number defines the capabilities of the CloudFormation template. So just need to make sure that it's the latest all the time. Still talking about CloudFormation, this is another classic question. What happens when one of the resources in a stack cannot be created successfully? Well, if the resource in a stack cannot be created, the CloudFormation automatically rolls back and terminates all the resources that was created using the CloudFormation template. So whatever resources that were created through the CloudFormation template from the beginning, let's say we have created like 10 resources and the 11th resource is now failing, CloudFormation will roll back and delete all the 10 resources that were created previously. And this is very useful when the CloudFormation cannot go forward. CloudFormation cannot create additional resources because we have reached the elastic IP limits. Elastic IP limit per region is 5, right? And if you have already used 5 IPs and your CloudFormation is trying to buy 3 more IPs, we've hit the soft limit. Till we fix that with Amazon, CloudFormation will not be able to launch additional resources and additional IPs. So it's going to cancel and roll back everything. That's true with a missing EC2 AMI as well. If an AMI is included in the template but the AMI is not actually present, then CloudFormation is going to search for the AMI, and because it's not present, it's going to roll back and delete all the resources that it created. So that's what CloudFormation does. It simply rolls back all the resources that it created. I mean, if it sees a failure, it would simply roll back all the resources that it created. And this feature actually simplifies the system administration and layered solutions built on top of AWS CloudFormation. So at any point, we know that there are no orphan resources in our environment, because something did not work, or because there was an CloudFormation executed some, there are no orphan resources in our account. At any point, we can be sure that if CloudFormation is launching a resource and if it's going to fail, and it's going to come back and delete all the resources it's created, so there are no orphan resources in our account. Now let's talk about some questions in Elastic Block Store. Again, if the environment deals with a lot of automation, you could be thrown this question: how can you automate EC2 backup using EBS? It's actually a 6-step process. To automate the EC2 backups, we'll need to write a script to automate the below steps using AWS API. And these are the steps that should be found in the scripts. First, to get the list of instances, and then the script that we are writing should be able to connect to AWS using the API and list the Amazon EBS volumes that are attached locally to the instance. And then it needs to list the snapshots of each volume, make sure the snapshots are present, and it needs to assign a retention period for the snapshot, because over time the snapshots are going to be invalid, right? Once you have some 10 latest snapshots, any snapshot that you have taken before that 10 becomes invalid because you have captured the latest, and 10 snapshot coverage is enough for you. And then the 5th point is to create a snapshot of each volume, create a new snapshot of each volume, and then delete the old snapshot. Anytime a new snapshot gets created, the oldest snapshot in the list needs to go away. So we need to include options, we need to include scripts in our script, lines in our script that make sure that it's deleting the older snapshots which are older than the retention period that we are mentioning. Another question that you could see in the interview, be it a written interview, be it online interview, or be it an telephonic or face-to-face interview, is what's the difference between EBS and Instant Store? Let's talk about EBS first. EBS is kind of permanent storage. The data in it can be restored at a later point. When we save data in EBS, the data lives even after the lifetime of the EC2 instance. For example, we can stop the instance and the data is still going to be present in EBS. We can move the EBS from one instance to another instance, and the data is simply going to be present there. So EBS is kind of permanent storage when compared to instance. On the other hand, instance store is temporary storage, and that storage is actually physically attached to the host of the machine. EBS is an external storage, and instance store is locally attached to the instance, or locally attached to the host of the machine. We cannot detach an instance store from one instance and attach it to another, but we can do that with EBS. So that's a big difference. One is permanent data, and another one is EBS is permanent, instance store is volatile data. And instance store, with instance store we won't be able to detach the storage and attach it to another instance. And another feature of instance store is data in an instance store is lost if the disk fails or the instance is stopped or terminated. So instance store is only good for storing cache data. If you want to store permanent data, then we should think of using EBS and not instance store. While talking about storage on the same lines, this is another classic question. How can you take backups of EFS like EBS? And if you can take backup, how do you take that backup? The answer is yes, we can take EFS to EFS backup solution. EFS does not support snapshot. Like EBS, EFS does not support snapshot. Snapshot is not an option for EFS, Elastic File System. Right? We can only take backup from one EFS to another EFS, and this backup solution is to recover from unintended changes or deletions of the EFS, and this can be automated. Right? Any data that we store in EFS can be automatically replicated to another EFS, and once this EFS goes down or gets deleted, or data gets deleted, or the whole EFS is for some reason interrupted or deleted, we can recover the data we can use the other EFS and bring the application to consistency. And to achieve this, it's not an one-step configuration, it's a cycle. There are a series of steps that's involved before we can achieve EFS to EFS backup. The first thing is to sign in to the AWS Management Console, and under EFS, or click on EFS to EFS restore button from the services list, and from there we can use the region selector in the console navigation bar to select the actual region in which we want to work on, and from there ensure that we have selected the right template. Some of the templates would be EFS to EFS backup, granular backups, incremental backups. Right, so there are some templates, the kind of backups that you want to take. Do you want to take granular? Do you want to take increment backups? Stuff like that. And then create a name to that solution, the kind of backup that we have created. And finally, review all the configurations that you have done and click on save. And from that point onwards, the data is going to be copied. And from that point onwards, any additional data that you put is going to copy it and replicate it. Now you have an EFS to EFS backup. This is another classic question in companies which deals with data management. There are easy options to create snapshots, but deleting snapshots is not always an click button or a single step configuration. So you might be facing a question like, how do you auto delete old snapshots? And the procedure is like this. Now, as best practice, we will take snapshots of EBS volume to S3. All snapshots get stored in S3. We know that now. And we can use AWS Ops Automator to automatically handle all snapshots. The Ops Automator service, it allows us to create, copy, delete EBS snapshots. So there are CloudFormation templates available for AWS Ops Automator, and this Automator template will scan the environment, and it would take snapshots. It would copy the snapshot from one region to another region if you want, if you're setting up a DR environment. And not only that, based on the retention period that we create, it's going to delete the snapshots which are older than the retention period. So life or managing snapshot is made a lot easier because of this Ops Automator CloudFormation template. Moving into questions in Elastic Load Balancer, this again could be a question in the interview. What are the different types of load balancers in AWS, and what's their use case? What's the difference between them? And as of now, as we speak, there are three types of load balancers. which are available in AWS. The first one being application load balancer. Just like the name says, the application load balancer works on the application layer and deals with HTTP and HTTPS requests. And it also supports path-based routing. For example, simplilearn.com / some web page, simplilearn.com / another website. So it's going to direct the path based on the / value that you give in the URL. So that's path-based routing. So it supports that. And not only that, it can support port-based :8080, :8081, or :8090. Based on that port also, it can take a routing decision, and that's what application load balancer does. On the other hand, we have network load balancer, and the network load balancer makes routing decisions at the transport level. It's faster because it has very less thing to work on. It works on lower OSI layer. It works on a lower layer, so it has very less information to work with than compared with application layer. So comparatively, it's a lot faster, and it handles millions of requests per second. And after the load balancer receives a connection, it selects a target group for the default rule using the flow hash routing algorithm. It does simple routing, right? It does not do path-based or port-based routing. It does simple routing, and because of it, it's faster. And then we have classic load balancer, which is kind of expiring as we speak. Amazon is discouraging people using classic load balancer, but there are companies which are still using classic load balancer. They are the ones who were the first one to step into Amazon when classic load balancer was the first load balancer or the only load balancer available at that point. So it supports HTTP, HTTPS, TCP, SSL protocol, and it has a fixed relationship between a load balancer port and the container port. So initially we only had classic load balancer, and then after some point Amazon said, instead of having one load balancer address all type of traffic, we're going to have two load balancers called as the child from the classic, two load balancer, and one is going to specifically address the application requirement and one is going to specifically address the network requirement, and let's call it as application load balancer and network load balancer. So that's how now we have two different load balancers. Talking about load balancer, another classic question could be, what are the different uses of the various load balancer in AWS Elastic load balancing? There are three types of load balancer. We just spoke about it. Application load balancer is used if we need flexible application management and TLS termination, and network load balancer if we require extreme performance and the load balancing should happen based on static IPs for the application. And classic load balancer is an old load balancer which is for people who are still running their environment from EC2 classic network. Now this is an older version of VPC, or this is what was present before VPC was created. EC2 classic network is what was present before EC2 was created. So they are the three types, and they are the use cases of it. Let's talk about some of the security related questions you would face in the interview. When talking about security and firewall in AWS, we cannot avoid discussion talking about WAF, Web Application Firewall, and you would definitely see yourself in this situation where you've been asked how can you use AWS WAF in monitoring your AWS applications. WAF, or Web Application Firewall, protects our web application from common web exploits, and WAF helps us control which traffic source your application should be allowed or blocked, which traffic from a certain source, which source or which traffic from a certain source should be allowed or blocked your application. With WAF, we can also create custom rules that blocks common attack patterns. If it is a banking application, it has a certain type of attacks, and if it is simple data management, data storage application, it has content management application, it has a separate type of attack. So based on the application type, we can identify a pattern and create rules that would actually block that attack based on the rule that we create. And WAF can be used for three cases. The first one is allow all requests, and then block all requests, and count all requests for a new policy. So it's also an monitoring and management service which actually counts all the policies, or counts all the requests that matches a particular policy that we create. And some of the characteristics we can mention in AWS WAF are the origin IPs and the strings that appear in the request. We can allow block based on origin IP, allow block based on strings that appear in the request. We can allow block or count based on the origin country, length of the request. Yeah, we can block and count the presence of malicious scripts in an connection. We can count the request headers, or we can allow block a certain request header, and we can count the presence of a malicious SQL code in a connection that we get and that want to reach our application. Still talking about security, what are the different AWS IAM categories we can control? Using AWS IAM, we can do the following. One is create and manage IAM users. And once the user database gets bigger and bigger, we can create and manage them in groups. And in IAM, we can use it to manage the security credentials, kind of setting the complexity of the password, setting additional authentications, like MFA, and rotating the passwords, resetting the password. There are a few things we could do with IAM. And finally, we can create policies that actually grants access to AWS services and resources. Another question you will see is, what are the policies that you can set for your user's password? So some of the policies that we can set for the user password is the minimum length, or the complexity of the password by at least having one number or one special characters in the password. So that's one. And then the requirement of a specific character types, including uppercase, lowercase, number, and non-alphabetic characters. So it becomes very hard for somebody else to guess what the password would be and try to hack them. So we can set the length of the password, we can set the complexity in the password, and then we can set an automatic expiration of the password. So after a certain time, the user is forced to create a new password, so the password is not stale, old, and easy to guess in the environment. And we can also set settings like the user should contact the admin when the password is about to expire. So you can get a hold of how the user is setting their password. Is it having good complexity in it? Is it meeting company standards? Or there are a few things that we can control and set for the users when the users are setting or recreating the password. Another question that could be posted in an interview, so to understand your understanding of IAM, is what's the difference between an IAM role and an IAM user? Let's talk about IAM user. Let's start small and then go big, or let's start simple and then talk about the complex one. The IAM user has a permanent long-term credential, and it's used to interact directly with AWS services. And on the other hand, IAM role is an IAM entity that defines a set of permissions for making AWS service requests. So IAM user is an permanent credential and role are temporary credentials. And IAM user has full access to all AWS IAM functionalities. And with role, trusted entities such as IAM users, application, or AWS services assume the role. So when an IAM user is given a permission, it sticks within the IAM user. But with roles, we can give permissions to applications, we can give permissions to users in the same account, in a different account, the corporate ID. We can give permissions to EC2, S3, RDS, VPC, and lot more. Role is wide, and IAM user is not so wide. It's very constrained only for that IAM user. Let's talk about managed policies in AWS. Managed policies, there are two types, customer managed and Amazon managed. So managed policies are IAM resources that express permissions using the IAM policy language. We can create policies, edit them, manage them separately from the IAM user group and roles which they are attached to. So they are something that we can do to managed policies if it is customer managed. And we can now update policy in one place, and the permissions automatically extend to all the attached entries. So I can have like 3 services, 4 services point to a particular policy, and if I edit that particular policy, it's going to reflect on those 3 or 4 services. So anything that I allow is going to be allowed for those 4 services. Anything that I denied is going to be denied for the 4 services. Imagine what would be without the IAM managed policy. We'll have to go and specifically allow deny on those different instances 4 or 5 times depending on the number of instances that we have. So like I said, there are two types of managed policies. One is managed by us, which is customer managed policies, and then the other is managed by AWS, which is AWS managed policy. This question, can you give an example of an IAM policy and a policy summary? This is actually to test how well versed are you with the AWS console. The answer to that question is, look at the following policy. This policy is used to grant access to add, update and delete objects from a specific folder. In this case, name of the folder is example folder, and it's present in a bucket called example bucket. So this is an IAM policy. On the other hand, the policy summary is a list of access level, resource and conditions for each service defined in a policy. So IAM policy is all about one particular resource, and the policy summary is all about multiple resources. With IAM policy, it was only talking about S3 bucket and one particular S3 bucket. Here it talks about CloudFormation template, CloudWatch logs, EC2, Elastic Beanstalk services. Summary of resources and the permissions and policies attached to them. That's what policy summary is all about. Another question could be like this: what's the use case of IAM and how does IAM help your business? Two important or primary work of IAM is to help us manage IAM users and their access. It provides secure access to multiple users to their appropriate AWS resources. So that's one it does. And the second thing it does is manage access for federated users. Federated users are non-IAM users, and through IAM we can actually allow and provide secure access to resources in our AWS account to our employees without the IAM user. Now, they could be authenticated using the Active Directory, they could be authenticated using the Facebook credential, Google credential, Amazon credential, and a couple of other credentials, third-party identity management, right? So we could actually trust them and we could give them access to our account based on the trust relationship that we have built with the other identity systems. All right, so two things. One is manage users and their access manage IAM user and their access in our AWS environment, and second is manage access for federated users who are non-IAM users. And more importantly, IAM is a free service, and with that we'll only be charged for the use of the resources, not for the IAM username and password that we create. Alright, let's now talk about some of the questions in Route 53. One classic question that could be asked in an interview is, what is the difference between latency-based routing and geo-DNS or geo-based DNS routing? Now, the geo-based DNS routing takes routing decisions on the basis of the geographic location of the request, and on the other hand, the latency-based routing utilizes latency measurements between networks and data centers. Now, latency-based routing is used where you want to give your customers the lowest latency as possible. So that's when we would use latency-based routing. And on the other hand, geo-based routing is when we want to direct customers to different websites based on the country they are browsing from. You could have 2 different or 3 different websites for the same URL. Take Amazon, the shopping website, for example. When we go to Amazon.com from in the US, it directs us to the US web page where the products are different, the currency is different, right, and the flag and a couple of other advertisements that shows up are different. And when we go to Amazon.com from India, it gets directed to the Amazon.com Indian site, where again the currency, the product and the advertisements, they're all different, right? So depending on the country they're trying to browse, if you want to direct customers to 2 or 3 different websites, we would use geo-based routing. Another use case of geo-based routing is if you have a compliance that you should handle all the DNS requests, or if you should handle all the requests from a country within the country, then you would do geo-based routing. Now, you wouldn't direct the customer to a server which is in another country, right? You would direct the customer to a server which is very local to them. That's another use case of geo-based routing. And like I said, for latency-based routing, the whole goal or aim is to achieve minimum end-user latency. If you are hired for the architect role and if that requires working a lot on the DNS, then you could be posted with this question: what is the difference between domain and a hosted zone? A domain is actually a collection of data describing a self-contained administrative and technical unit on the internet. Right? So for example, Simplilearn.com is actually a domain. On the other hand, hosted zone is actually an container that holds information about how you want to route traffic on the internet to a specific domain. For example, lms.simplilearn.com is an hosted zone, whereas simplilearn.com is an domain. So in other words, in hosted zone, you would see the domain name plus a prefix to it. LMS is a prefix here. FTP is a prefix. Mail.simplilearn.com is a prefix. So that's how you would see a prefix in hosted zones. Another classic question from Route 53 would be: how does Amazon Route 53 provide high availability and low latency? The way Amazon Route 53 provides high availability and low latency is by globally distributed DNS servers. Amazon is a global service and they have DNS services globally. Any customer doing a query from different parts of the world, they get to reach an DNS server which is very local to them, and that's how it provides low latency. Now, this is not true with all the DNS providers. There are DNS providers who are very local to a country, who are very local to a continent. So they generally don't provide low latency service. Right? It's always high latency. It's low latency for local users, but anybody browsing from a different country or a different continent, it's going to be high latency for them. But that's not again true with Amazon. Amazon is a globally distributed DNS provider. It has DNS servers global wide, and like I said, it has optimal locations. It has got global servers, or in other words, it has got servers around the globe, different parts in the globe, and that's how they are able to provide high availability. And because it's not running on just one server but on many servers, they provide high availability and low latency. If the environment that you're going to work on is going to take a lot of configuration backups, environmental backups, then you can expect questions in AWS config. A classic question would be: how does AWS config work along with AWS CloudTrail? AWS CloudTrail actually records user API activity on the account, and any HTTPS access or any sort of access that's made to the cloud environment, that's recorded in the CloudTrail. In other words, any API calls, the time is recorded, the type of call is recorded, and what was the response given. Was it a failure? Was it successful? They also get recorded in CloudTrail. It's actually a log. It actually records the activity in your cloud environment. On the other hand, config is a point-in-time configuration details of your resources. For example, at a given point, what are all the resources that were present in my environment? What are all the resources, or what are the configuration in those resources at a given point? They get captured in AWS config. Right? So with that information, you can always answer the question: what did my AWS resource look like at a given point in time? That question gets answered when we use AWS config. On the other hand, with CloudTrail, you can answer the question, by looking at the CloudTrail or with the help of CloudTrail, you can easily answer the question: who made an API call to modify this resource? That's answered by CloudTrail. And with the CloudTrail, we can detect if a security group was incorrectly configured and who did that configuration. Let's say there happened to be a downtime and you want to identify let's say there happened to be a downtime and you want to identify who made that change in the environment. You can simply look at CloudTrail and find out who made the change. And if you want to look at how the environment looked like before the change, you can always look at AWS config. Can AWS configure or AWS config aggregate data across different AWS accounts? Yes, it can. Now this question is actually to test whether you have used AWS config or not. I know some of the services are very local, is it? Some of these services are availability zone specific, some of them are regional specific, and some of them are global services in Amazon. And though some of the services are region services, you still can do some changes, add some configuration to it and collect regional data in it. For example, S3 is a regional service, but still you can collect logs from all other regions into an S3 bucket in one particular region. That's possible. And CloudWatch is an regional service, but still you can, with some changes to it, with some adding permissions to it, you can always monitor the CloudWatch that belongs to CloudWatch logs that belongs to other regions. They're not global by default, but you can do some changes and make it global. Similarly, AWS Config is a service that's a region-based service, but still you can make it act globally. We can aggregate data across a different region and different accounts in an AWS config and deliver the updates from different accounts to one S3 bucket and can access it from there. AWS config also works or integrates seamlessly with SNS topic. So, anytime there is a change, anytime the new data gets collected, you can always notify yourself or notify a group of people about the new log or the new config or new edit that happened in the environment. Let's look at some of the database questions. Database should be running on reserved instances. So whether you know that fact or not, the interviewer wants to understand how well you know that fact by asking this question. How are reserved instances different from on-demand DB instances? Reserved instances and on-demand instances are exactly the same when it comes to their function, but they only differ based on how they are built. Reserved instances are purchased for 1 year or 3-year reservation, and in return we get a very low per hour pricing because we're paying upfront. It's generally said that reserved instance is 75% cheaper than on-demand instance, and Amazon gives you that benefit because you're committing for 1 year and sometimes you're paying in advance for the whole year. On the other hand, on-demand instances are built on an hourly price. Talking about auto-scaling, how will you understand the different types of auto-scaling? The interviewer might ask this question: which type of scaling would you recommend for RDS and why? There are two types of scaling, as you would know now, vertical and horizontal. And in vertical scaling, we can vertically scale up the master database with a couple of clicks. Right, so that's vertical scaling. Vertical scaling is keeping the same node and making it bigger and bigger. If previously it was running on T2 micro, now we would like to run it on M3, 2 times large instance. Previously it had 1 virtual CPU, 1 gigabit. Now it's going to have 8 virtual CPU and 30 gigabit of RAM. So that's vertical scaling. On the other hand, horizontal scaling is adding more nodes to it. Previously it was running on 1 VM. Now it's going to run on 2, 3, 10 VMs. Right? That's horizontal scaling. So a database can only be scaled vertically, and there are 18 different types of instances we can resize our RDS to. Right, so this is true for RDS MySQL, Postgres SQL, MariaDB, Oracle, Microsoft SQL servers. There are 18 type of instances we can vertically scale up to. On the other hand, horizontal scaling are good for replicas. So they are read-only replicas. We're not going to touch the master database. We're not going to touch the primary database, but I can do horizontal scaling only with Amazon Aurora, and I can add additional read replicas. I can add up to 15 read replicas for Amazon Aurora and up to 5 read replicas for RDS MySQL, Postgres SQL, and MariaDB RDS instances. And when we add replica, we are horizontally scaling, adding more nodes, right? Read-only nodes. So that's horizontal scaling. So how do you really decide between vertical and horizontal scaling? If you're looking to increase the storage and the processing capacity, we'll have to do a vertical scaling. If you're looking at increasing the performance or of the read-heavy database, we need to be looking for horizontal scaling, or we need to be implementing horizontal scaling in our environment. Still talking about database, this is another good question you can expect in the interview. What is the maintenance window in Amazon RDS? Will your DB instance be available during the maintenance event? Right, so this is really to test how well you have understood the SLA, how well you have understood the Amazon RDAs, the failover mechanism of Amazon RDAs, stuff like that. So RDA's maintenance window, it lets you decide when a DB instance modification, a database engine upgrades, or software patching has to occur. And you actually get to decide, should it happen at 12 in the night, or should it happen at afternoon? Should it happen early in the morning? Should it happen in the evening? You actually get to decide. And automatic scheduling by Amazon is done only for patches that are security and durability related. Sometimes Amazon takes down and does automatic scheduling if there is a need for a patch update that deals with security and durability. And by default, the maintenance window is for 30 minutes. And the important point is the DB instance will be available during that event, because you're going to have primary and secondary, right? So when that upgrade happens, Amazon would shift the connection to the secondary, do the upgrade, and then switch back to the primary. Another classic question would be, what are the consistency models in DynamoDB? In DynamoDB, there is eventual consistency read. This eventual consistency model, it actually maximizes your read throughput. And the best part with eventual consistency is all copies of data reach consistency within a second. And sometimes when you write and when you're trying to read immediately, chances that you would still be reading the old data. That's eventual consistency. On the other hand, there is another consistency model called the strong consistency or strongly consistent read, where there is going to be a delay in writing the data, making sure the data is written in all places, but it guarantees one thing, that is, once you have done a write and then you're trying to do a read, it's going to make sure that it's going to show you the updated data, not the old data. You can be guaranteed of it that it is going to show the updated data and not the old data. That's strongly consistent. Still talking about database, talking about NoSQL, DynamoDB or NoSQL database, which is DynamoDB in Amazon. You could be asked this question: what kind of query functionality does DynamoDB support? DynamoDB supports get and put operation. DynamoDB supports, or DynamoDB provides flexible querying by letting you query on non-primary key attributes using global secondary index and local secondary indexes. A primary key can be either a single attribute partition key or a composite partition sort key. In other words, a DynamoDB indexes a composite partition sort key as a partition key element and a sort key element. And by holding the partition key, when doing a search or when doing a query, by holding the partition key element constant, we can search across the sort key element to retrieve the other items in that table. And the composite partition sort key should be a combination of user ID partition and a timestamp. So that's what the composite partition sort key is made of. Let's look at some of the multiple choice questions. Sometimes some companies would have a written test or an MCQ type online test before they call you for the first level or before they call you for the second level. So these are some classical questions that companies ask in their multiple choice online questions. Let's look at this question. As a developer, using this pay-per-use service, you can send, store, and receive messages between software components. Which of the following is being referred here? Let's look at it. Right, we have AWS Step Functions, Amazon MQ, Amazon Simple Queue Service, Amazon Simple Notification Service. Let's read the question again. As a developer, using this pay-per-use service, so the service that we are looking for is a pay-per-use service, you can send, store, and retrieve messages between two software components, kind of like a queue there. So what would be the right answer? It would be Amazon Simple Queue Service. Now, Amazon Simple Queue Service is the one that's used to decouple the environment. It breaks the tight coupling and then it introduces decoupling in that environment by providing a queue or by inserting a queue between two software components. Let's look at this other question. If you would like to host a real-time audio and video conferencing application on AWS, right? It's an audio and video conferencing application on AWS. This service provides you with a secure and easy to use application. What is this service? Let's look at the options. They are Amazon Chime, Amazon Workspace, Amazon MQ, Amazon AppStream. You might tend to look at Amazon AppStream because it's real-time and a video conference, but it's actually for a different purpose. It's actually Amazon Chime that lets you create chat and create a chat board and then collaborate with the security of the AWS services. So it lets you do the audio, it lets you do the video conferencing, all supported by AWS security features. It's actually Amazon Chime. Let's look at this question. As your company's AWS solution architect, you are in charge of designing thousands of individual jobs which are similar. Which of the following service best serves your requirement? AWS EC2 autoscaling, AWS Snowball, AWS Fargate, AWS Batch. Let's read the question again. As your company's AWS solution architect, you are in charge of designing thousands of individual jobs which are similar. It looks like it's batch service. Let's look at the other options as well. AWS Snowball is actually an storage transport service. EC2 autoscaling is introducing scalability and elasticity in the environment, and AWS Fargate is container services. AWS Batch is the one is being referred here that actually runs thousands of individual jobs which are similar. AWS Batch is the right answer. Right, let's look at the other one. You are a machine learning engineer and you're looking for a service that helps you build and train machine learning models in AWS. Which among the following are we referring to? So we have Amazon SageMaker, AWS Deep Lens, Amazon Comprehend, AWS Device Farm. Let's read the question again. You are a machine learning engineer and you're looking for a service that helps you build and train machine learning models in AWS. Which among the following are referred here? The answer is SageMaker. It provides every developer and data scientist with the ability to build, train, and deploy machine learning models quickly. That's what SageMaker does. Now, for you to be familiar with the products, I would recommend you to simply go through the product description. There's one page available on Amazon that explains all the products, quick, neat, and simple. That really helps you to be very familiar with what the product is all about and what it is capable of. Is it a DB service? Is it a machine learning service? Or is it a monitoring service? Is it a developer service? Stuff like that. So get that information, get that details before you attend an interview, and that should really help to answer or face such questions with great confidence. So the answer is Amazon SageMaker, because that's the one that provides developers and data scientists the ability to build, train, and deploy machine learning models quickly as possible. All right, let's look at this one. Let's say that you are working for your company's ID team and you are designated to adjust the capacity of the AWS resource based on the incoming application and network traffic. How do you do it? So what's the service that actually helps us to adjust the capacity of the AWS resource based on the incoming application? Let's look at it. Amazon VPC, Amazon IAM, Amazon Inspector, Amazon Elastic Load Balancing. Amazon VPC is a networking service. Amazon IAM is an username password authentication. Amazon Inspector is a service that actually does a security audit in our environment. And Amazon Elastic Load Balancer is a service that helps in scalability. That's in one way, indirectly that helps in increasing the availability of the application, right? And monitoring how much requests are coming in through the Elastic Load Balancer, we can actually adjust the environment that's running behind it. So the answer is going to be Amazon Elastic Load Balancer. All right, let's look at this question. This cross-platform video game development engine that supports PC, Xbox, PlayStation, iOS, and Android platforms allows developers to build and host their games on Amazon's servers. So we have Amazon GameLift, Amazon Greengrass, Amazon Lumberyard, Amazon Sumerian. Let's read the question again. This cross-platform video game development engine that supports PC, Xbox, PlayStation, iOS, and Android platforms allows developers to build and host their games on Amazon servers. The answer is Amazon Lumberyard. This Lumberyard is a free AAA gaming engine deeply integrated with AWS and Twitch with full source. This Lumberyard provides a growing set of tools that helps you create an highest game quality applications. and they connect to a lot of games and vast compute and storage in the cloud. So it's that service they are referring to. Let's look at this question. You are the project manager of your company's cloud architect team. You are required to visualize, understand, and manage your AWS cost and usage over time. Which of the following service will be the best fit for this? We have AWS Budgets, we have AWS Cost Explorer, we have Amazon Workmail, we have Amazon Connect, and the answer is going to be Cost Explorer. Now, Cost Explorer is an option in the Amazon console that helps you to visualize and understand and even manage the AWS cost over time. Who's spending more? Who's spending less? And what is the trend? What is the projected cost for the coming month? All these can be visualized in AWS Cost Explorer. Let's look at this question. You are a chief cloud architect at your company, and how can you automatically monitor and adjust computer resources to ensure maximum performance and efficiency of all scalable resources? So we have a CloudFormation as a service, we have AWS Aurora as a solution, we have AWS Auto Scaling, and Amazon API Gateway. Let's read the question again. You're the chief cloud architect at your company. How can you automatically monitor and adjust computer resources? How can you automatically monitor and adjust computer resources to ensure maximum performance and efficiency of all scalable resources? This is an easy question to answer. The answer is autoscaling. Right, that's a basic service and solution architect course, is it? Autoscaling is the service that helps us to easily adjust, monitor, and ensure the maximum performance and efficiency of all scalable resources. It does that by automatically scaling the environment to handle the inputs. Let's look at this question. As a database administrator, you will use a service that is used to set up and manage databases such as MySQL, MariaDB, and PostgreSQL. Which service are we referring to? Amazon Aurora, Amazon Elasticache, AWS RDS, AWS Database Migration Service. Amazon Aurora is Amazon's flavor of the RDS service, and Elasticache is the caching service provided by Amazon. They are not full-fledged database. And database migration service, just like the name says, it helps to migrate the database from on-premises to the cloud and from one database flavor to another database flavor. Amazon RDS is the service, is the console, is the service, is the umbrella service that helps us to set up, manage databases like MySQL, MariaDB, and PostgreSQL. It's Amazon RDS. Let's look at this last question. A part of your marketing work requires you to push messages onto Google, Facebook, Windows, and Apple through APIs or AWS Management Console. You will use the following service. So the options are AWS CloudTrail, AWS Config, Amazon Chime, AWS Simple Notification Service. All right, it says a part of your marketing work requires you to push messages. It's dealing with pushing messages to Google, Facebook, Windows, and Apple through APIs or AWS Management Console. You will use the following service. It's Simple Notification Service. Simple Notification Service is a message pushing service. Right? SQS is pulling. Similarly, SNS is pushing. Right? Here it talks about a pushing system that pushes messages to Google, Facebook, Windows, and Apple through API, and it's going to be a simple notification.
Click the link in the description to know more.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.